Hello everyone, so this is our course Introduction to AWS Certified SysOps Administrator course. Okay, this is AWS Certified SysOps Administrator course, and this is the introduction video of it. Let us see some key points of this course, that what we are going to do in this course. So this AWS SysOps Administrator course is designed to equip you with the knowledge and hands-on experience required to efficiently operate and maintain systems on the AWS platform. From deploying applications to ensuring high availability and security, this course covers a comprehensive range of topics essential for anyone aspiring to become a proficient AWS SysOps administrator. This course is ideal for system administrators, IT professionals, and anyone looking to enhance their skills in managing AWS environments. Whether you are new to AWS or seeking to deepen your expertise, the SysOps Administrator course provides a well rounded curriculum to meet your needs. While there are no strict prerequisites, a basic understanding of cloud computing concepts and familiarity with AWS services will be beneficial. Participants with experience in system administration will find the course content particularly relevant. The only thing you should have is an AWS account and nothing at all. So let's meet in our next videos. Let's do this course now. Thank you.
Hello everyone. So this is our first video, and in this video we will be creating EC2 instance in AWS. Okay, so let us start without wasting any time. So this is our EC2 instance service. Whenever you will go to your Amazon dashboard, it will look like this, and then you have to access your services here. You can search for the services, like if you have recently visited any of the services, it will be visible here, and here are all services available, and you can search EC2 from here. Like if you have to search, then you can search EC2, and here it is, EC2 virtual servers in the cloud, and you have to select it. Just click on it. You will be redirected to the EC2 dashboard, and then we have to launch an instance of EC2. Okay, so let's get started. Just click on this launch instance first, and then your instance will be launched on your location. Okay, now what you have to do, you have to enter your instance name first. So for example, any meaningful name you can give. Suppose I am giving it my first instance. Okay, first instance. In this, you have to select your AMI. AMI means Amazon Machine Image. This Amazon Machine Image is a template that contains the software configuration basically. Then just click on any of this. Suppose I have to select Amazon Linux, and from here you can select any of the EMIs. If you have to go free tier, you can select any free tier eligible. Okay, if you have to pay anything, if you have to work according to your requirement, then you can select any of the AMIs here. Okay, next is this instance type. You can select any of the instance. Suppose if you have a small work, then you can choose t2.micro, or a newer version where t2.micro is not available. t3.micro is there, but here we will be charged if we are using t3.micro. Just see, let me show you. Yep, this t3.micro here is not free, so we will not go for it. We'll just choose t2.micro, and then if you have created a key pair already, then it's okay, but first of all you have to create a new pair, and in this you have to enter your pair name. Suppose my key. Okay, this is my key pair name dot pem. I'll go with default settings only. I'll create this pair. It is downloaded here. Okay, so it is downloaded, and then what I have to do, I have to just keep the settings default. Let me tell you one more thing. You can configure your storage, and if you are using free tier, then free tier eligible. Here it is written that in free tier eligible, customers can get up to 30 GB of EBS general purpose SSD or magnetic storage. Okay, so that's all. You just have to select the number of instances. Okay, so I am creating just one instance, so I will keep this number as 1. Here is my information for the instance whatever I'm creating. T2.micro firewall security group, new security group. Its storage is 1 volume, that means 8 gigabytes. And yep, I'll just launch this instance. So my instance is getting ready, it is being launched. You can see this success message here, that this means that my instance is already created. Now what can I do? I can just check the launch log. It is initializing requests, creating security groups. Okay, so my instance is already created. Let's go to the dashboard where I can see my instance. And yes, this is my instance, this is my first instance. Instance ID is here, instance state is running, type is t2.micro, status check is initializing, alarm status no alarms, availability zone is here, and everything I got. And wait, yeah, when I just select this instance, I can work on into this instance if I want. Okay, so this was my instance creation. I can just connect from my instance, connect using EC2 instance connect, and I can connect it. Like suppose, just look here, I have connected to my instance and I'm into my instance. Now I can work whatever I want. I can write codes and snippets here. So that's all for instance connection. And yep, I have connected to my Amazon Linux, and whatever I'll be writing would be performed here. It is as same as your Linux machine that is installed in your system, in your local system. This is very similar to it. So thank you for watching this video. Let's meet into our next video. Hello friends, so in this video we will check that how we can change the EC2 instance type. Okay, so you can change the EC2 instance type if your instance is EBS backed up. And for this you have to do, like, first of all you have to stop your instance, whatever instance it is, or if it is running you have to stop that instance. Then you have to refresh it, and then it will show you that you can change the instance type in settings. Okay, that I'll show you in this hands-on. So let us start by doing so. First of all, I'll just give you an idea that how we can change the EC2 instance and why should we change the instance according to our need. Suppose we need some more memory to our file, so how can we give that? We can give that by changing the instance type. Let us start by changing this, and let us start by having one example for this. Okay, so first of all I'll check the memory that is available in my t2.micro instance type, and then I'll change it to some other instance type, and then we will check the memory. We will compare that. So first of all, let us connect to this instance EC2 user. Okay, let me connect to it. As you can see that connection is established here. Now I will write some example, okay, to show you what is the available memory in t2.micro for me. Echo hello, we will write echo hello hello.txt. We will make a file named hello.txt. Enter ls. Okay, so hello.txt is there. We will check whether this hello is there in our hello.txt or not. So cat command, using cat command we can do so. Okay, so hello is there in our hello.txt. Now we will check the memory. Okay, free minus. So this is our memory. 949 total, used 153, free 578, available 656. Okay, now what I'll do, I'll just change the instance type, and as I said, the steps were, I'll not just clear it, I'll use it for comparing. I'll click on this EC2 connects. Okay, this is my running instance. I'll just stop this instance right now. Stop instance. Yeah, stop. As you can see, this instance has already stopped here. EC2 connects is already stopped. Now what I can do, I can just change its instance type by just clicking here instance, and in this action we will go to instance setting. We'll click here, and yeah, this is the option, change instance type. If your instance is running, then this option is disabled, like this, change nitro enclaves, this is disabled option. So if your instance will be running, this will also be disabled, but if your instance is stopped, as I have stopped it, this will be accessible. I'll just change this instance type to like T2 small. Suppose I want to change it to T2 small, and I'll apply this. So here my instance is already changed. Instance type is T2 dot small, as you can say, see here. And now what I'll do, I'll just start this instance, and then I'll write the same commands. I'll just check the file that I have created. Let me connect to it. This is, yep. So this is my instance is running here. I am just connecting to it, and I'll just check the file size. Okay. Previously it was 949 total, and I'll just check for hello.txt. Let us. Okay, so I have connected to my instance. I'll write ls. So hello.txt is there. Cat space hello.txt. As I have changed instance type, so this is hello is there now. Free minus. Look, this is 1956. This memory has been increased as I have changed the instance type. So if required, as per your requirement, you can change the instance type. So this was how we can change the instance. And please don't forget to stop this instance or change this instance type first. Okay, I'll just change this instance type because you want to be in your, if you want to be in your free tier limit, so you can just change, or either it will charge you. Okay, so that's all for today's video. I hope now you know how to change EC2 instance type, and thank you, and let's meet in our next video. Thank you. Hello friends. Okay, so let's talk about enhanced networking now. So it is another way for us to get better networking performance for our EC2 instances. And so we have the type EC2 Enhanced Networking SRIOV. Okay, it gives us higher bandwidth and higher PPS, packets per second, which is with a lower latency. And this is something that can come in the exam. Also, we have two options for this. First one is Elastic Network Adapter ENA, which supports till 100 gigabits per second, and option 2 is, or choice 2 is Intel 8259 VF to 10 Gbps. Okay, this is legacy. So this EC2 enhanced networking, especially the ENA adapter, works for the newer generations, or you can say the latest generations of EC2 instances, as we will see in the hands-on practical. Okay. Also, then we have elastic fiber adapter, fabric adapter, you can say, which is an improved ENA dedicated for HPC. Okay, it only works on Linux. Great for internode communication, tightly coupled workloads. As we know, because they live in the same cluster, so we have a lot of internal node communication, and those node communications are tightly coupled. Okay, then there is MPI. This MPI is basically, like, suppose when they are living in the same cluster, then they are going to get better network performance. Okay, while talking to each other. So when talking to one another, this is going to leverage a standard, and this standard is called MPI standard, which is message passing interface. Okay, and the idea is that elastic fabric adapter is having a higher performance because our EC2 instances are talking with one another, and so it knows that it will bypass the underlying Linux OS to provide low latency, reliable transport. So this is all we have now for theory. Let's move on to hands-on, and we will see what are the drivers for like older generation and newer generation. In older generation, we will see T2 dot micro, and in newer generation, we will be seeing, suppose, T3 dot micro. We will be making an instance, and then we will be doing some hands-on. So let's move on to hands-on. So this is my instance. This is T2 dot micro. I have already made it. So I'll just start it for now. Okay, I'll just start it. Until then, I'll make another instance of T3 dot micro. Okay, newer version instance type. So let us name this like // only. Let us not name it anything. AMI. Okay, Amazon Linux 2 AMI I'll be selecting, which is also free tier eligible to me. Instance type will be T2 dot micro. It is now, it will be T3 dot micro. T3, just look, T3.micro will not be free because T2.micro is free to me. So it is chargeable. So if you are making an instance of T3.micro or any not free eligible instance, so make sure you stop it to make it some cost effective. Okay. Now I'll select a key pair, which is my key. Then I'll just keep all the settings as default. I'll launch this instance now. Okay, so this instance is successfully initiated now. Now I'll be just checking, I'll be refreshing this, and here it is my instance, it is running right now. And let us connect to t2.micro first. Okay, let us connect to t2.micro instance. Okay, this is the username, EC2 user. I'm good with it, I'm okay with it. Okay, so now we have already connected our t2.micro instance. Now we are going to write some basic commands to check, like mod info space ena, and this will just show us the information, and this is installed now. Now we'll be writing another command to check the drivers, which are the drivers in this, and whether it is a latest driver, like it is ena or not. We will check it right now. So we will just see eth tool minus h0 minus I. Okay, I forgot that, minus I, and then h0. Just click enter. You can see driver is our VIF. Okay, this is an older version. Now in t3.micro we will check whether it is a newer version or not. So let us connect to t3.micro instance. This is an instance type, and let us connect to it. Now you can see I am already connected into my t3.micro instance, which is a newer version of instance. And yep, let us write mod info space ena. And as I have connected Amazon Linux 2, so this is same version 2.10.0. And let us now write another command, which was tool dash I eth0, and let us see, this driver is our ena. This is nothing but ena, which is new version, new driver. So yep, we have enhanced our networking. So this is how we can enhance our networking, by making newer type of instances. Okay, so that's all for today. Let's meet in our next video. Hello, so let's talk about placement groups today. See, we will do theory this time. So placement groups are basically a bit more advanced, and we want to use them once we want to have control over our EC2 instances. Okay. So sometimes when we want control over EC2 instances, placement strategy, so we use these placement groups. Okay. Now, that type of strategy is basically called placement group. Suppose if we want control over our EC2 instance placement strategy, then that type of strategy is defined as placement groups. Then we can create a placement group, and then we mention one of the strategies for a group. And what are the strategies? So we don't get direct interaction, because we don't get direct interaction with hardware, AWS hardware, because it is cloud, AWS is cloud, so we don't get direct interaction with hardware of AWS. But we let AWS know that how we would like our EC2 instance to be placed compared to one another. Cluster. So first is cluster. Clusters instances are basically all the, like EC2 instances are placed at a single or in a single cluster. Clusters instances into low latency group in a single availability zone. Okay, single AZ you can say. Next is spread. Spreads instances across underlying hardware, maximum 7 instances per group per availability zone can be there, and this is used in critical application. Okay, we will see details in a second. And then third comes partition. Partitions are basically spreads instances across many different partitions. We just spread our instances in different partitions within an availability zone, and it can scale to hundreds of EC2 instances per group. In a group we can place many of instances, EC2 instances, like Hadoop, Cassandra, and Kafka do. Next comes placements groups cluster. Okay, Now let's start. This is the first one, basically placements groups cluster. Let's start. So in this placement group cluster, all the EC2 instances are interconnected. Okay, you can see all the EC2 instances are connected to each other. In a same rack they are placed and in the same availability zone. So now this placement group cluster is this low latency and high throughput. It gives you high throughput. So in a network where low latency and high throughput is required, we can use placement groups like this. Okay, what are its pros? Pros is great network, 10 Gbps bandwidth between instances are supported here. What are cons? So if the rack fails, suppose, because all the EC2 instances are placed in a same rack, so if the rack fails, all the instances fails simultaneously. Okay, at the same time all the instances will fail and we will lose our instance. Next comes use case. So big data work that needs to be completed fast, at that time placement group cluster is used. Okay, those application that needs, as I said, that needs extremely low latency and high network throughput, then at that case we can place all the EC2 instances at the same rack and in the same availability zone using this cluster. Now comes placements group spread. Okay, in this case, when we asked for a spread placement group, all the EC2 instances are going to be located on different hardware. So as you can see here, we have 3 AZ availability zones and we have 6 EC2 instances. Basically in this we have 2 only. Total is 6. We have 2 EC2 instances per partition. Okay, and now what we will see, that these are groups basically, and these are located on different hardware. Suppose first is on AP South 1A, then next is AP South 1B, next is AP South 1C. So these are all different, located at different hardwares. Suppose EC2 1 is on hardware 1, EC2 next is hardware 2, other is on hardware 3, other is on hardware 4. So what does that mean? Well, what we get is that we can span across multiple availability zones and there is a reduced risk of simultaneous failure. And why so? Because if any of my hardware suppose fails, I am pretty sure that my hardware 2 will not fail, or my hardware 3 will be there to support. Okay, and so that is the benefit from it. What is the pros and cons now? Pros can span across different availability zones. Reduce risk is simultaneous failure, as I said. EC2 instances are on different physical hardware. So when they are on different physical hardware, if one fails, then another will be working. Now, what are cons of it? So basically, it is limited to 7 instances per availability zone per placement group only. Next is use case. So application that needs to maximize high availability, we can use it there. Next is critical applications where each instances must be isolated from failure from each other. Suppose if my first instance is failed now, and if we want to separate, isolate them, so that if my first instance fails, then another instance which is located at different hardware should work properly, should not be affected. So there we can use this placement group spread. Next we can use placement groups partition. In this you can see partition. And what is this? In this partition placement group, we can have instances spread across partitions. Okay, in multiple availability zones. We can have 7 partitions per availability zone. So in this example, we have partition 1 in US East 1A, partition 2 in US East 1A, partition 3 in US East 1B. And on each partition, we could have many EC2 instances. You can see on this partition 1, we have 4 instances. In partition 2, we have 4 instances. Partition 3, we have 4 instances. We can take as many as we can. So in the first one, I have 4, second one, 4, 4, and all this. So why do we use a partition placement group? This is the question. Well, each partition represents a rack in AWS. So by having many partitions, we are making sure that our instances are distributed across many hardware racks, and so therefore they are safe from a rack failure from one another, as in we saw in cluster. As in our cluster, our EC2 instances were interconnected with each other, and if one fails, then all the system fails, all the EC2 instances fail simultaneously. But this is very different. This partition is very different from the first case. Okay. Next is up to 100 of EC2 instances could be kept. As I said, the instances in a partition do not share racks with the instances in other partitions. Next, a partition failure can strike many EC2 but won't strike other partitions. Suppose here, if in my partition 1, suppose there are 4 EC2 instances. So if one instance fails, then other instance would be affected. But the instances which are on different partition won't be affected. Other EC2 instances won't be affected by it. So this is something better. This is something advanced about this placement groups partition. EC2 instances get access to the partition information as metadata. They have images, they have metadata in that. Okay. So this was a placement group partition, and usually the use cases are going to be big data applications which are partitions aware. We have used like in our Hadoop system, we use partitions or buckets. So partitions there, that static partition and dynamic partition are used cases of this placement groups partition, like SDFS, HBase, Cassandra, and Apache Kafka. So I hope now here you have got placement groups partition, and now you can understand what are all the partition groups, and I hope now you can work on it. So next we will do some hands-on on this. Till then, thank you. So hello everyone. So in this video we will be doing some hands-on. We will be creating placement groups in AWS. So open this EC2 dashboard, and in this scroll down, and then you will find placement groups in network and security. So in network and security, placement groups are there. Just click on it, and now we will be creating placement group. While creating placement group, you have to name suppose this is my placement group. So the first placement group was cluster, so I will name it my placement cluster. Okay, my placement cluster. I'll choose strategy, I'll be choosing cluster here, and then I can add a tag, or suppose I have created this group. So my placement cluster group will be created here. You can see this cluster, and all the instances will be shared in the same cluster. Okay, all the instances that I'll be making will be saved in the same cluster. Next, I can make another placement group, which is my placement spread. My placement spread it is. Let me name it my placement spread. Okay, then I'll choose strategy, which is spread. Spread, in this spread, the EC2 instances are spread across different hardwares. So here you can see rack, that means hardware or host. So I'll be choosing racks here. I hope you know why. And then I'll be creating group. So this is strategy is spread, and then whatever instances I'll be making will be saved in different hardwares to prevent EC2 instance failure. Okay, next is I'll be creating placement partition. And in partition, I hope you have watched my previous video. So in partition, what we do, we choose number of partition. As I have mentioned in my theory in my previous video, that we can make 7 up to 7 partition in one placement group. So I have chose the maximum number of partition, and now I'll be making this group. So this is how we can make placement group in AWS. I hope this is clear to you now. So thank you, and that's all for today.
So hello friends, in this video we will see the shutdown behavior and termination protection in AWS instance. So first we have shutdown behavior. So whenever we make an instance, we have two options. Instance will be shut down in two ways, okay? And those two options are, first is stop, which is by default, and second is terminate. We can terminate instance by its shutdown behavior only. Okay, next is, this thing isn't applicable when we shut down from console. We will see how. Okay, we will see it on our hands-on. Next is CLI, instance initiated shutdown behavior. This is the CLI stuff, CLI command, which is very much relatable by its name only. Next is termination protection. So we can enable termination protection to prevent accidental termination of our instance. Suppose if we have 2 or 3 instances and we want to shut down another instance, we want to terminate other instance, and by mistake we terminate our useful instance. So to prevent that type of stuff, we can enable termination protection of an instance. The note is, if we have shutdown behavior is equal to terminate. Suppose if we have ticked the shutdown behavior as terminate and termination protection is enabled, then also instance can be terminated from OS from CLI by writing sudo space shutdown command. We will see how. Okay, so now let's move on to hands-on and let's check whether this is applicable or not. So here I will launch an instance first. My instance name, let us name it hyphen only, nothing else. -- Amazon Linux AMI 2 I'll be choosing, and then instance type is equal to t2.micro, no worries, architecture 64-bit. Key pair I'll be selecting my key. Okay, no security group, no changes in that. We will just move on to advanced detail, and here in advanced detail you can see that shutdown behavior by default it is stop, but now we will choose terminate because we want to do shutdown behavior is equal to terminate, and we want to do some hands-on on CLI. Okay, next is termination protection, and then we will be enabling this termination protection. So termination protection is enabled now, and we will just launch this instance. As you can see, my instance is in now running state. We named it -- okay, this is instance ID. Now what we will do, we will just try to terminate it because we have enabled termination protection, and we will see what is the message we are getting. So whenever we will terminate, so here is the message, termination protection enabled. So we have enabled termination protection. Now let's terminate, try to terminate it, and you will see that it is failed to terminate an instance. The instance may not be terminate. Okay, this is the message we are getting. So we have prevented our instance from being terminated accidentally. Now we will go on to CLI, and then we will check whether we can shut down it from the CLI or not, and what stuff we are getting when we are writing shutdown command, because I have set shutdown behavior is equal to terminate. So whenever I should shut down, my instance should be terminated. Okay, so let's check whether it is being terminated or not. I'll just connect it. Okay, so I'll write simple command which is sudo space shutdown, and we will check whether it is being terminated or being stopped. Okay, so as I have enabled shutdown behavior is equal to terminate, so it should be terminated. Let's check it. The system is going down for power off at this moment. Okay, let's now check whether it is being terminated or not. What is its shutdown behavior now? So we will go on this tab, instance EC2. We will check our instance ID, and instance state is running here. In a moment or two it will be terminated. Let's wait for it. Okay, now you can see instance state is here terminated. So our instance is terminated successfully when we entered this command sudo space shutdown in CLI. So this is how we can enable shutdown behavior as terminate, and we have terminated it. We have checked that if you have termination enabled, termination protection enabled, and you have instance like behavior is equal to terminate, then it will be terminated in CLI. So that's it for today. Let's meet in our next video. Hello everyone. So in this video we will see EC2 launch troubleshooting. Okay, so let's move. The first type of error that we can get whenever we are launching an instance is instance limit exceeded, and this error basically shows that we have reached the maximum number of vCPUs in a region. Suppose we are provided a limit of like 64 vCPUs, and we reach that vCPUs in a region, then this error might occur. Okay, like instance limits are set on a per region basis. Suppose if you are in US, so your region, whatever your region is, that will be your instance limit will be set as per your region only. For example, suppose if you are running on demand instance types, then you will have 64 vCPUs by default. Okay, next is how to solve this error, how to resolve this error. So the solution of this error will be like, if you can launch your instance on a different region, you can do so, or you can put a request on AWS to increase your limit for the region. You can put a request simply on your AWS to increase whatever limit you want. Okay, and they will increase that for you. vCPU based limits only apply to running on demand instances and spot instances that we will see in hands-on right now. Okay, so let's move on to hands-on. Let's check. So here is our EC2 dashboard. Let's see something like the first thing is how we can check whether what is our limit of vCPU. Okay, so let us check. Earlier in AWS, that thing was present here below this events part, but now it is shifted to service quotas console. Okay, now it is shifted to service quotas console, and this service quotas console is a very cool service. So you would go into the Amazon Elastic Computes in this. Let's open this first, service quotas, and here on the very right side you will get manage quotas, and just click here AWS services, then type Amazon Elastic Compute Cloud. Okay, because the full form of EC2 is Elastic Compute Cloud, as you know. So just click on it and get the quotas, view quotas from here, and you will get that there are a lot of quotas as per like their alphabetical order. So let's search standard keyword now. All standard spot instance request has a 64 limit, and running on demand as well has 64 limits. But now here you can see that I have 32 because I have applied account level quota value, right? Let's check it. Here I can also increase, like if I reach this 32 vCPUs, then I can just request increase at this account level. Okay, and let us see that which type of instance holds how many vCPUs. So we can check that by launching an instance in EC2. So whenever you are launching an instance in EC2, so just click on it, launch instance. Okay, and then check your instance type, and in that instance type vCPUs are given, that how many vCPUs an instance is taking. Suppose this t2.micro takes 1 vCPU. Okay, and we can compare instance types from here. Suppose I had 32 vCPUs in my limit. Okay, 32 vCPUs in my limit. So suppose if I just select this C3.8x large instance type, and the required vCPUs are 32 here. Okay, suppose I create this instance, then the limit will be reached in one instance only. So after that, if I'll request another instance, then it will show me that error. Okay, so this is one type of error that I might get, and I can resolve it by either changing my availability zone or either requesting AWS to increase my limit. Next is, Let us see some more troubleshootings and some more errors right now. So let's go to theory part again. As this instance limit exceeded, we checked that how many vCPUs are present and how we can resolve this, how we can check that which instance type contain how many vCPUs. Okay. Next type of troubleshooting is insufficient instance capacity. This error occurs when AWS doesn't have enough on-demand capacity in the particular availability zone where your instance is launched. And solution is, you can wait a while before requesting. You can, suppose if you're requesting continuously, then just take a break and then again you can try after some time. Next is, suppose if you're requesting for 5 instances, okay, so rather than applying all at once, you can break down the request and request multiple instances one by one. Okay, if needed, submit a request for a different instance type too, and then you can change that instance type as per your requirement, as we have already seen that in our previous videos, that how we can change the instance type. Also, we can request the EC2 instance in a different availability zone. We can request EC2 instance to be launched in a different availability zone so that that zone should have enough on-demand capacity and we do not get this type of error. Next is instance terminates immediately. Suppose if you are creating an instance and from pending it just goes to terminated and it doesn't shows you running or stopped. So how this error can occur? You might have reached your EBS limit. EBS snapshot might be corrupted. Okay, you should check that. The root of EBS volume is encrypted and you do not have the permission to get the KMS key. Suppose the root EBS volume is encrypted and that you do not have key or permission to get the KMS key, so you cannot terminate, like launch your instance, and you cannot run. Your instance will terminate immediately. The instance store backed AMI that you use to launch the instance is missing a required part, an image.part.xx file. Next is to get the exact reason why that error is occurring, why that instance is being terminated immediately, then you can check out the EC2 console of AWS. In that instances and in that description tag, you can note the reason which is next to the state transition reason label, and you can check that reason from there, and now you will know that what is the reason behind the termination of the instance. Okay, so I hope you got this video correctly, and now you can troubleshoot if these type of errors occurs while you are working in AWS. So thank you, and let's meet in our next video. Hello everyone. So today in this video we will be learning about EC2 SSH troubleshooting. Okay, so we will see that how we can connect to EC2 with SSH and what problems we might get when we are connecting with SSH. Okay, we will see how can we edit security groups, edit inbound rules in that. So let us move. You will get an unprotected private key file error if you don't have 400 permissions for your private key PM file on your Linux. Okay, you might get an error. Make sure you provide correct username for the OS when logging in into SSH, else you will get host key not found or permission denied or connection closed by instance port 22. Port 22 is the port at which EC2 instance runs actually. Okay, reasons for connection timed out might be your security group is not configured accurately. This might be a reason for a message connection timed out to EC2 instance whenever you are connecting via SSH. NACL, that is network access control list, it might not be configured correctly. That might show this error. Next is view the route tables for the subnet. Okay, if you are connecting your EC2 instance with SSH, just check inbound and into that route tables whether the subnet is given correctly or not. Instance might not have a public IPv4. Your instance might not have a public IPv4 address, that address which is used to connect to your instance, okay, in your region. Next is CPU load of the made instance might be high. Suppose if your CPU load is high, instance might not get connected and it might show connection timed out. Okay, it may show that result to you. So that is an error. So these may be the reasons of this type of message. So this is all possible reasons. Next is whenever you are connecting to EC2 SSH troubleshooting, then suppose if you are connecting with a permanent key, then what happens if you are not a user with correct IP address, then security group would not allow you to enter into the EC2 instance or connect to the EC2 instance. Next, whenever you connect EC2 instance with API, then what happens, then there in every region like this you get a IP prefix, and suppose you are a user whose IPv4 is 1.2.3.4, then you are connecting with EC2 instance via API, then it will give you a one-time SSH public key which is valid for 60 seconds to connect to your security group, or you can say to connect to your EC2 instance. Okay, so let's do some hands-on on this. Let's see how can we connect with SSH. So this is our instance that we have made. We have saved our key, we have made a key.pem key and we have saved it. Okay, now what I'll be doing, I'll be just starting this instance. Okay, this instance is successfully started. Let's click on this instance ID. Now I'll be copying this public IPv4 address, which this address is given to me. Okay, public IPv4 address. Then I'll be opening my command prompt with administrator. Okay, this is my IP basically. Okay, let's paste it. Look, this is the location where I have saved my key. Okay, .pem key, my EC2 SSH.pem key. Okay, what is key? You can see that in my previous video when I made an instance, I had to made a key and I downloaded it and I have stored that key here in this location in my PC. Okay, now I'll just click enter here and you will see that I'll be connected successfully into my instance. Okay, I have to type yes and then I have permanently added. Now I can access my instance. Okay, I am connected. Now if I write echo hello, then yep, hello will be printed here successfully. You can see that. Correct, this is the message. So I am successfully logged in. Now I'll just log out from here. What I'll see now, I'll just go to the security settings. In that I'll be opening security groups and here type is SSH. Okay, I'll just edit inbound rules. In this rule there is source is custom and this is 0.0.0.0. Now what I am doing, I am just doing this my IP, which is private IP basically. Okay, this is private IP and now I am saving it. And when I have changed this inbound rule, I have edited inbound rule. Now this IP is this. Okay, still I can connect. I have changed it to private my IP, but still I can connect using the same commands. Okay, these are the commands, these are the code basically, and using the same commands I can still connect using my SSH. See, I'm successfully connected. Okay, now I'll again log out from here. Now what I'll do, I'll just do some more changes and see. But now what you will see that I have edited it to my IP. Okay, I just changed it from 0.0.0 to my IP. Now what I am doing, I'll just try to connect my instance through here from the dashboard itself, I'll be going to instance. Okay, so I'll try to connect it from here. Connect. Okay, when I try to connect to my EC2 instance, because I have changed my security group, I have edited my inbound rules. Now this shows that I cannot connect to my EC2 instance because I have edited my inbound rule. I have changed my security group, so I cannot connect to this. Okay, so to get correct IP, what I can do to get correct IP, to get my IP, I can just copy this, okay, and paste it to a new tab. When I'll paste it to a new tab, this thing will open documentation, Amazon EC2, and then user guide for Linux instance. And in this, I can just go to security group rule, and then I'll see all the AWS IP ranges. I'll open it now. Okay, and in this I'll just download this IP ranges JSON, and when I'll click on this type of page will be opened. Look, and and in this there are regions, IP prefix, service, network, border group, and I have to select my region here. Okay, I have to select my region, in which region I am. So my instance is at, you can see, instance EC2 AP Southeast 2. Okay, my location is Sydney, which is AP Southeast 2. Here is AP Southeast 2. Okay, service Amazon AP Southeast 2. What I have to do, I just have to connect now. So I'll be checking this IP prefix. I'll be just copying this IP prefix right now. Okay, and I'll be changing it to inbound rules, the inbound rules that I am having. Okay, let's go and edit inbound rule, and then paste the region's IP into that. Here is security, here is security groups. I am in editing inbound rules now. Okay, I'll be changing this to this regions IP, save rules. This is now updated successfully. What I have to do, I have to connect it again. Okay, so here you can see I have connected to my EC2 instance as I edited with my regions IP, okay, which was AP Southeast 2. I just edited this into my inbound rules security group, and now I am connected into my EC2 instance. Okay, so I hope this video is very clear to you. And one more thing, let me tell you, if you will change this user group here, username here, while writing this command, suppose you have written this command and you are just changing the username, which is EC2 connect, okay, which is this one. Suppose I am logging out, and then what I have to do, I'll just do this. So here it is EC2 user. If you will change it from EC2 user to any other username, then also you will not be connected to your EC2 instance. So make sure you are entering correct username. So I hope this video is now clear to you, and we have covered all the things regarding SSH troubleshooting. So let's meet in our next video. Till then, thank you. Hello friends. So in this video, we will see the EC2 instances purchasing options, that what type of purchasing options are provided by EC2 instances or AWS for us. Okay, so let's move forward. First is on-demand instances. These type of instances are useful for short workload. Predictable pricing are here, and you have to pay by second. Okay, suppose you have to pay every second for your usage. Okay, next is reserved. Reserved is like you are reserving an instance for certain period of time. So here if you have a long workload and you know that you are going to work on it for 1 year or 3 years, so these type of reserved instances are better for you because they give a certain amount of discount. Next is convertible reserved instances. These types of instances are sub part of reserved instances. Basically in these type of instance, reserved instance, convertible reserved instance, they provide you some flexible instance, like you can change the instance type or instance size. We will see in a minute. Savings plan are basically, suppose you are paying some amount, you have proposed some amount, like I will pay this much amount every hour or for this time, like this duration. Suppose you have said that for 1 year I'll be paying $2 per hour to you. So according to that payment scenario, they will give you one instance, okay, and they will fix your availability zone. They will lock something for you and you will be using that for a certain period of time. Next are spot instances. Spot instances are basically used for short workloads, and they can be lost anytime. You can lose instances anytime. They are very less reliable. So these are spot instances. Next are dedicated hosts. Suppose you are booking an entire physical server and controlling instance placement, that where you want to place your instance, so that is dedicated host. Dedicated instances are basically no other customer will share your hardware. You will have your own hardware with yourself and you will be using it. Next, let's see one by one. So first is EC2 on demand. Pay for what you use. You are paying for what thing you are using. Suppose you are using it on Linux or Windows, so billing will be per second after the first minute. In any other OS, billing will be per hour, okay, per hour based. Next is has the highest cost, but it has no upfront payment. You will be only paying for your usage only, okay. You don't have to prepay anything, okay. Everything will be like you will get a bill and you will have to pay for what you have used. Next is no long-term commitment is here. You don't have to commit that I am gonna work with you, or I am gonna book this instance for 1 year or 3 years. So there is no long-term commitment. You can leave that EC2 instance anytime because you are on demand. You are demanding that instance and you are just paying for what you are using here. Next is recommended for short-term and uninterrupted workloads. Suppose you have a shorter term and uninterrupted workload you want, okay, so you have to work on 3 months only, and then you will be paying it. Suppose for 3 months, whatever you are using, you will be paying for it, and you don't want any interruption, then also you can use that. You can't predict here. Suppose you can't, it is short term, but you can't predict that how application will behave. Is it gonna work in 2 weeks or 3 weeks or 1 month or 3 months? So you don't know, but yes, you have an idea that this is a short term stuff and I can work on it. So you can use EC2 on demand. No discounts are given on this. Next is reserved instances. EC2 reserved instances are basically giving you 72% discount compared to on demand instances, because you are reserving it for a long period of time, okay. You have reserved a specific instance attributes like instance type, region, tenancy and operating system. You have reserved it for a specific time, like reservation period is 1 year, so you will get some discount. If you are reserving it for 3 years, you will get more discount. Payment options, if you are not paying anything, no upfront payment, then you will get some discount. If you are doing some partial payment, then you will get a moderate discount, and if you are paying all the amount at one go, you will surely get some more discount in it. Reserved instances scope. Suppose you are reserving your instance on a region or a zonal scope, so you can reserve your capacity in any availability zone here. Recommended for steady state usage application. If your application doesn't want any interruption in that, and it doesn't wants to be lost also, so this type of stuff EC2 reserved instance can handle. Okay, you can buy and sell in the reserved instances marketplace. Suppose you have used only 2.5 years and you have reserved your instance for 3 years, so that 6 months, for that 6 months you can sell your instance in reserved instances marketplace. So you can also buy and sell, so this is also something that is more beneficial to you. Convertible reserved instance. This is another type of subpart in reserved instances. In these, we have the privilege to change the EC2 instance type, instance family, OS like operating system, scope and tenancy. You can change all the things. You will surely get some lesser discount than reserved instances because you are getting these type of privilege to change your EC2 instance type at any point of time. So it will surely not give you that much discount, but yeah, it will also give you a bit of discount like 66%, which is lesser, but it is much more greater than on-demand instances. Next is EC2 savings plan. You get a discount based on long-term usage up to 72%, same as RIs, okay, reserved instances. Commit to a certain type of usage, $10 per hour for 1 or 3 years. What you are doing here, you are just committing a certain amount that you will be paying to AWS, okay, for some duration like 1 year or 3 years. In this, what you are doing, you are not giving that I want this instance basically. No, you just want to pay this much amount and you will be using whatever instance they are giving you. Usage beyond EC2 saving plan are billed at the on-demand price. Suppose you have crossed your EC2 saving plan bill, suppose you have crossed your $10 per hour, okay, so now what? So now you will be paying at the on-demand price, okay, because now your saving plans has been crossed and you will be paying your on-demand price. Logged to a specific instance family, it will be logged like if you have micro or T2 or T3, it will be specific, okay. And AWS region is also fixed here like M5 in US East I. So this AWS region is also logged here whenever you are working with EC2 savings plan. It is very flexible across instance size. You can change the size at any point, okay. You can also change the OS like Linux or Windows at any point of time. You can also change the tenancy like host or dedicated or default. You can also change that, okay. EC2 spot instances. Now what is this? So this is the most feasible stuff because you will get a higher discount on it. You can get about 90% compared to on-demand instances, but there is some drawbacks. Let us see. Instances that you can lose at any point of time. If your maximum price is less than the current spot price, you will lose that. Now what is this? Suppose if you have set the price is your price is like $20 and you have crossed it, you have $21 or $22 used, okay, so you have used your more than your maximum price. Your current spot price is more than your maximum price. So what now? Your instance will be lost, okay. The most cost efficient instances in AWS, it is very useful that are resilient to failure, okay. It is very useful for works that are resilient to failure. You can afford that failure of instance at any point. You don't have to worry. So in that use case, you can use this EC2 spot instances. Very useful for batch jobs, data analysis, image processing, any distributed workload that you are having. Next is workload with a flexible start and end time. It is not suitable for critical jobs or not for databases too. That is actually true, because if you are having a database, you want it to be stored for a longer time, okay. So in this type of instance, you are losing that. So you will not prefer that I'll be using spot instances for critical job or databases because I might lose this instance at any point of time. So there is no point of storing anything here which is useful to me. Next is EC2 dedicated host. Now what is this? So in this, a physical server with EC2 instance capacity fully dedicated to our physical use, okay. We will get a whole physical server with EC2 instance capacity which is very dedicated to us. Next, it allows us to address compliance requirements and use our existing server bound software license per socket per core per VM software license. Now purchasing options are very same, like on demand or reserved. You can reserve or on demand here for active dedicated hosts. You can also place your instance at any like you have that instance placement role here, you have that power here, you have that permission here to place your instance wherever you want. Okay, the most expensive option, because you have the whole server with you, you have booked the whole server, so this is actually most expensive option. It is very useful for software that have complicated licensing model like BYOL, which is bring your own license, so you can use this physical server here. Next, it is useful also for those companies that have strong regulatory or compliance needs. Next are EC2 dedicated instances. Now instances that run on hardware that is dedicated to you only, you are not going to share it, okay, but you can share it with changing instances in same account. Okay, may share hardware with other instances in same account. Suppose you are sharing your hardware from other instances. Okay, instances run on hardware that is dedicated to you, you cannot share it, but you can share hardware with other instances. Okay, in same account, you have your account, you will be using it, but you cannot share your hardware into another account, into any other account. That is not made for you. Okay, no control over instance placement. You do not have any control over instance placement. If you will start or stop, it can move, it will move. Okay, can move hardware after stop or start button. Characteristics, here are some usage which will be asked or might be asked in exam. So EC2 dedicated host and EC2 dedicated instance basically are not same. Actually they are very different. Okay, in that you are booking a whole server, here you are just booking an hardware. Okay, you are just locking a hardware. Next is EC2 capacity reservations. In this type, you are reserving on-demand instance capacity in a specific availability zone for any duration. Suppose it is 1 year or 3 year. You have access to EC2 capacity when you need it. Okay, no time commitment is here. Okay, you can create or cancel anytime. No billing discounts are here. Combine with regional reserved instances and savings plan to benefit from billing discounts. Suppose you want some billing discount, then you can combine it with regional reserved instances and saving plans. Next, you are charged at on-demand rate, whether you are using it or not using it, whether you are running your instance or not, you will be charged because you have fixed one instance for yourself only for a certain period of time. You don't want anyone to interfere there, and you don't want any stuff to be like interfering in your work, in between your work. So that is only for you and you will be using it. Suitable for short-term uninterrupted workloads that needs to be in a specific availability zone. As I said, if you don't want any interruption, or it is short-term basically, because it is charging you on demand. So if the work is short-term, then using capacity reservation will be good. But if it is very long-term thing, then you should use reserved instances, because if you know that it is gonna take your 3 years or 1 year or 2 years, then you should use your reserved instances strategy, that pricing, because that will be more beneficial to you. But if it is a short-term thing and you want that, I want the same EC2 instance, I don't want to change availability zone to, then you can use EC2 capacity reservations. You can go with this billing option, purchasing option basically. Now summary: on demand, coming and staying in hotel whenever we like, we pay the full price of room. Suppose I am coming to a hotel whenever I am liking, whenever I have a vacation, I am just paying the full price of the room and I am staying here. Next, reserved thing, planning ahead. I have planned that I'll be going with my family after 2 months, and then I'll be just living there for 3 years in a hotel, 2 years in a hotel, or 1 year. Then I have reserved that, or then I might get a good discount. They will give me a good discount because I am just using their hotel for 1 year, so I am their regular customer. Okay. Next, saving plan. Now saving plan, suppose we have taken a hotel as an example, so we are taking this. So savings plan, paying a certain amount per hour for certain period and stay in any room type. Suppose you are paying you will be paying like $10 or $15 or $20 or $30, whatever amount, for a certain period of time, and you are okay with, suppose they are accommodating you in any room, you can stay in any room type, king, suite, sea view, any room type. So this is your saving plan, that okay, I have fixed my amount, you can check whatever room type you can give me. Next is spot instances. Spot instances is basically the hotel allows you to bid for the empty rooms and highest bidder keeps the room. But this is not safe actually. Suppose you are living, you are staying, and someone bids more than you, then they will kick you out from there. So this is not a feasible option. Next is dedicated host. What is dedicated host? So this is actually like you are booking a whole and building of a hotel and you are using it. So if you are actually just acquiring the whole building of the hotel, you are booking the whole building, then it will be costly to you, it will not give you any discount, but you have that access to all the rooms. Okay, next is capacity reservations. You book a room for a period of time with full price, you don't want to stay in it or you are staying in it. Okay, suppose you have booked a room for 2 months, so either you stay in it or not, that doesn't actually matters. So this is capacity reservations, that I have this room, okay, whether I'm living or not, you should not ask me that, you just give me, I'll be paying price to you and I'll be living as per my choice. Next is price comparison. Suppose I have taken the example m4.large USCs one. So in this, these are the price type and these are the price per hour. Suppose on demand is $0.10. Spot instances are basically giving you much discount than on demand, and all the instances, all other instances are giving you billing options are giving you much discounts. Okay, dedicated host are giving you on demand price only. Capacity reservations also give you on demand price only. All other instances type, price type, gives you much more discount. So this was your video about purchasing options in EC2 instance. I hope you got that very nicely. So let's meet in our next video. Till then, thank you. So hello everyone. So in this video we will see spot requests, saving plan, reserved instances, dedicated host, and capacity reservations. We will talk all about all these things. Okay, let's start. So first is spot requests. So when you will open your EC2 dashboard, then in the left hand side in instances at the fourth position, there is spot requests. Okay, so what is this and how we can use it? So for the theory part, you can see my previous video which I have posted on this channel. So what are spot requests now? So basically they provide us a lot of discount, like apart from on-demand instances. When we were using on-demand instances, we had to pay more amount, but now when we will use spot requests, so these are basically some instances that can be lost if we reach our maximum price that we are giving to AWS. But this is a good thing whenever we are working on a small workload thing, or whenever we are working on a small project whose time duration is low. Okay, so let's see the pricing history first. Okay, so suppose we have chosen this instance type. Next is our data range. Data range might be, you can choose it for 1 month or 3 months. Suppose we have chosen it for 3 months. In 3 months we can also choose graph according to availability zone or instance type. With availability zone, you can see, suppose your availability zone is for AP Southeast 2A, AP Southeast 2B, or AP Southeast 2C. So this is the region which is the cheapest for us, which we can use, and we can get the most amount of saving, which is 74.92% savings. Next is how we can make this spot instance. So let's go back and see this. Okay, so you can request your spot instance here. Whenever you will request your spot instance, you can manually configure it, or you can use a launch template instead. Okay, suppose if I am here using manually configure launch parameters, so I'll be selecting an AMI. Suppose I am choosing Amazon Linux to AMI HVM only. I am keeping it default right now. I had made this key pair already, so I'll be using it, my key. Okay, additional request details. So this is my, if I don't use it by default, so what will happen, I'll be given an option to choose IAM fleet rule, which is request from or until. Okay, next is what is the behavior of our instance when that request expires. So I can choose it to be terminated or not terminated. Okay, so first, this is the case what we can do in additional request details. Next is target capacity. In target capacity, I can set the number of vCPUs, number of instances, or the number of memory, how much memory we are using. Suppose I want like 10 vCPUs. Okay, so I can enter here 10 vCPUs, and this is our total target capacity. If we have specified this, we can allocate part of the target capacity as on demand. But see, here it is written that we have set the target capacity, I want 10 vCPUs, so it will choose the best like 10 vCPUs from any instance. Suppose we want to maintain target capacity. Okay, so how we can maintain target capacity? So if interruption behavior, if any interruption is there, target capacity, the vCPU will be terminated. We can choose it to stop or hibernate. Okay, let's keep it default right now. Let's keep it one only. Okay, we will also keep this default additional request details. Next is network. We can choose network or availability zone. You can also choose instance type requirements. Suppose you can do two things here. You can manually select your instance type. Suppose you are selecting c5.large or c1.medium, you are adding them here. Okay, you have this spot saving, spot price, you are giving this whole stuff, that how it will charge you, how AWS will charge you for all these instances. This is here, you can choose any of them. Okay, next is, suppose I want to specify instance attributes that matches our compute requirements. Suppose I just want 32 vCPUs and I'm not confirmed that which instance type I should work on. So I'll be choosing the instance attributes only, and then AWS will automatically give me a proper instance that I should work on. So this is something which is very beneficial if you don't know about instance type, which instance type should you use. Okay, next is allocation strategy. So spot allocation strategy could be done on the basis of price capacity or optimized, or just capacity optimized. In this capacity optimized, suppose if you want a higher capacity but you don't care about prices, so you can go for this capacity optimized. But if you want that we should have capacity and it should be cheapest also, so this is the best option, price capacity optimized. We can see all the strategies here. There is lowest price option also, and last one is not so. Okay, next is your fleet request at a glance. This is our fleet strength, which is just strong. I'm not going to launch it because it might be much costly for me. But you can see this is 77% better than on demand, because I am getting 77% savings here. Okay, but estimated hourly price will be 0.023 per hour at this target capacity, so I am not going to launch it because it will charge me. Next is, if I want to launch this spot request from the EC2 instance launch time only, I can do this that also. While I am launching an instance, there is a option in advanced details. Suppose I am launching an instance here. So here in advanced details, we have an option for like this. Wait, let me show you. Okay, here is a purchasing option. Okay, you can request spot instance from here. You can customize it. Either you want to set some maximum price or no maximum price. You can also set your request type to be one time or persistent. Suppose if you are keeping it persistent, then it will request you until the time reaches. Okay, suppose if I have selected this persistent, I would have to also select the valid 2 time. If I want to set some time that this spot instance should request again and again till the expiry date. So I can set this expiry date, or if I don't want any expiry date, that it should not have any expiry date, then I'll be selecting this no request expiry date. Okay, here one time is basically it will just request for spot instance for once and it will be terminated then. Okay, you can also select the interruption behavior, as I said, terminate, stop, or hibernate. You can also hibernate, terminate, or just stop that interruption behavior. Next is capacity reservation. You can also set your capacity reservation, tenancy, RAM disk, all these things, and then you can launch your instance. So this is how we can set spot instances while we are launching an instance. Now we will see savings plan. What is the savings plan? Savings plan are basically, I have explained it in my theory, but I am just telling you this, that suppose you set a price in AWS and then you say that okay, I'll be paying this much to you, and whatever you will give me, I'll be working on it. Okay, so this is saving plans strategy. You can also purchase saving plans here. Okay, let's see this now. Here is cost management, billing and payments pages here. Now we can also purchase a saving plan. Suppose I want to purchase a saving plan, I can also choose that whether I have to choose compute saving plan, EC2 instance saving plan, or SageMaker savings plan. Compute saving plan basically applies to EC2 instance, AWS Fargate, and AWS Lambda. Here EC2 instance saving plan, as named, it will only be applied on instance, okay, within the commented EC2 family that you are choosing. Term, you can also choose term either it for 1 year or 3 year. Saving plan are basically, as I said, that if you are just planning to go to a vacation and you have booked your hotels there, so you are basically, what you are doing, you are actually choosing a saving plan for yourself, okay, that at that exact moment you won't be charged more. Okay, so this is a feature of saving plan which is available on AWS. Next we can see reserved instances. What are these reserved instances? So basically these reserved instances are, we can purchase our platform, we can set our platform tenancy offering class, and then we can choose a in an instance which is reserved to us only. This is basically an instance which is we will be choosing it for like 3 years or 1 year term. We will select that term. Suppose I've just searched and the best instances are here, like I have applied t3.micro. so effective rate are this, upfront price is this, hourly rate is $0.000. Okay, this payment option is here, and see, if all upfront payment I'm doing, I'll be getting more discount. If I am doing no upfront payment, I'll be getting lesser discount, and if I'm doing partial upfront payment, then I'll be getting moderate discount in this. I can also choose quantity here. I can add to cart and I can view cart, and then I can purchase that reserved instance. The reserved instance is basically that type of thing that you have just chosen that you want to stay for 2 year or 3 year on a place, and you are just paying that money, and you will not be like given, your instance won't be terminated here. You have reserved your instance for that proper term, and you have set your instance type, instance family, and you have also chosen your term here basically. Okay, and also offering class, standard offering class or convertible. In standard you can't change your instance type in between, but you can also choose your instance type in convertible offering class, sorry. So you can choose this. Next is dedicated host. Basically dedicated host, as I told you lastly, that a proper server will be given to you, like you have booked a whole building in a hotel, that is actually a dedicated host for you. Okay, basically what is this, you are just reserving a host, okay, physical server fully dedicated for your use, and you are just using like name tag, instance family, you are choosing that okay, this is instance family I'll be using. Instance type, then you will give that okay, in that instance family I'll be using this instance type which is launched on your dedicated host only. You will choose that in which availability zone your dedicated host is located. Okay, so all these things you can do. You can also choose quantity from here. So this is basically dedicated host and how you can choose this dedicated host here. Next is capacity reservations. Basically this is something like you are booking a room in a hotel, and what you are doing, you are visiting there sometimes, or you are not visiting there sometimes. So if you are not visiting, then also you will have to pay for the reservation. Like suppose I have created a reservation. I am creating a capacity reservation. I have this instance type which is a1.medium or a1.large. I can choose any of them. Platform is like Windows, Linux, whatever you can choose. Availability zone you can choose. Total capacity of instance you can choose. You can also choose the time at which specific time your reservation should end. Like suppose you have in a hotel, you have chosen that okay, I am just booking this for 2 months. Okay, and after 2 months from this date, this capacity reservation will end. So at that specific time your capacity reservation will end, and when it ends, that instance would be no longer of your use, or it would no longer be yours. Okay, you can also choose manually here. Okay, that either like you are booking a room in a hotel, and you have said that okay, whenever I want to cancel it, I will cancel it. Okay, I am not selecting a date. Okay, when I need it, I would just cancel that. So this is something that capacity reservation remains active in your account until you manually cancel it. Okay, so this is one option in which you can deactivate or activate manually your capacity reservation. Okay, so this was the video of all these saving plans: spot request, reserved instances, dedicated host, and capacity reservation. We talked all about these things, and next video we will see burstable instances. So till then, thank you, and meet in our next video. Hello friends, so today we will see burstable instance. The instances like T2 and T3 are burstable instances. AWS has the concept of burstable instances. And what are these burstable instances? So burst means that overall the instance has good CPU performance. Like if you are working and if your instance is getting burst, then your CPU will have a good performance. And when does it burst? So suppose when the machine needs to process something unusual or unpredictable thing, like a spike in load, for example, so it can burst. Okay, so your instance will burst, and then CPU can be very good. And why? So why I am saying this, because suppose there is a spike, then you know that your CPU usage will be more, so your CPU performance would be decreased. Okay, your CPU would slow down. To prevent that slowdown of CPU, your instance get burst. If the machine bursts, it uses burst credits. So according to your instance type, like in T2, if you are selecting T2.nano or T2.micro or T2.2x large, so according to your instance type, some burst credits are given to you from the AWS only, and you can use that burst credit whenever there is a load in your instance. Okay, if all the credits are gone, the CPU becomes slow. The CPU generally becomes slow. If the machine stops bursting, credits are collected over time. Suppose your machine is not bursting, so it will automatically be collected. Credits will be collected over the time. Next is burstable instances can be fabulous to counter unexpected traffic and getting the assurance or insurance that it will be handled in a right manner. Burstable instance, suppose it is very good because if you have unexpected traffic and if you have a higher workload, then it will assure you that yes, your workload would be handled in a right manner. Your CPU won't be slow down. Okay, if your instance oftenly runs low on credit, you need to shift on a different type of non-burstable instance. Because suppose if your instance is very oftenly it runs low on credit, then what? Then you should shift to different type of non-burstable instance, because your instance might not be able, that instance type in which you are in might not be able to handle that type of workload. That is why it is bursting again and again. Next, credit usage. So this is the picture of credit usage and credit balance. So here you can see that this is the time 0.0000002 by 10. So here at this time your credit usage is more because your CPU is having a load here. So your credit usage is here, but your credit balance, suppose it is around 590. Okay, suppose this is around 590. So this was 590 till this time, until this time. But when your CPU was on load and when it started using credit, here your credit balance is getting low. Okay, it's getting low. So this is a picture depicting your credit usage and credit balance relation. Next is CPU credits. So here all the information about CPU credits is given to you. T2.nano launch credits 30, vCPUs 1, CPU credits earned per hour 3, max CPU credit balance 72, vCPUs 1, baseline performance 5%. All these are instance types. Okay, and T2.2x large has the largest vCPU collection, has the highest launch credits, can earn most CPU credits per hour. It has also like you can earn CPU credit balance 1944, vCPUs are 8, and it can give you about 135% of CPU utilization. Experiment run a CPU stress command to peak at 100%. Suppose after the credits are exhausted, the measured CPU utilization drops. Okay, here is the picture of CPU utilization. Here it is 100% CPU utilization. Your CPU is being utilized at the full capacity here. Now your credit balance at the same time would be dropping drastically. Okay, and when it becomes 0, your credit is exhausted, then what? Then your CPU utilization would be slow again, low again. Your CPU will be slow here. Next is, it is possible to have an unlimited burst credit balance, but surely AWS will charge you for that. Suppose if you have exhausted your credit balance, then also your CPU performance won't be low if you are selecting unlimited burst credit balance, but they will charge you for that. If average CPU usage over a 24-hour period exceeds the baseline, then the instance is built for additional usage per virtual CPU per hour. And you have to be careful, you have to monitor again and again so that you don't go beyond your whatever budget it is for you. Here it is the picture representing CPU utilization, credit balance, and CPU surplus credit charge. And this surplus credit charge would be charged to you by AWS. So you should have this on mind. Let's do some hands-on on this. I have this running instance now. Let us see where we can have credit specification, where we can enable that unlimited or standard. So when you launch an instance, suppose I am launching an instance here, when you move down, my family should be T2. Okay, T2 or T3. So my family is here T2.micro instance family. Next I'll be moving to advanced details. Here are the advanced details. Let's look. So here you will find credit specification. Okay, and this credit specification, if you will select that like unlimited or standard, and on the basis of that your credit will be utilized. Suppose you have chosen unlimited, then if you cross your credit balance, then addition charges will be applied by AWS to you. And if you are choosing standard, then what happens? If you are choosing standard, then if your credit balance is used up, then your CPU will ultimately be slowed down, and that will be like your workload. If your workload is higher, then your CPU will not perform according to you. Next we can also see, like if I am moving back, this is my running instance. I can also monitor my CPU utilization from here, like in this monitoring. I'll click this and you can see that I have not used this instance much. I have just created it, and here is my CPU credit usage count. You can see it was spiked here, like this is the spike. My credit usage was the most here, and this is how my credit balance just dropped slightly, you can see, and now it is again regaining. Okay, so I can regain my credit balance ultimately automatically by AWS over the time. And my credit usage was more here. My CPU utilization I can also monitor from here, like it was utilizing the most here at this point, and suddenly it was dropped, and now it is also regaining. Okay, so this is how I can check my CPU utilization, credit usage. So I hope this was much understandable to you. Let's meet in next video. Thank you. Hello friends, so today we will see elastic IPs. Okay, so let's start now. So whenever you start and then stop the EC2 instance, you will observe that its public IP, that public IPv4 ID changes. Okay, it just changes and it gives you different values whenever you start and stop the EC2 instance. And if you need to have a fixed public IP instance, address, then you require an elastic IP. Elastic IP is a service from AWS which just fix your IP address to the server whenever you are working at an instance. Next is an elastic IP is a public IPv4 you own until you don't delete it. Okay, until you don't disassociate or until you don't delete it, that IPv4 address will be sticked to your elastic to your instance. Okay, you can fix it to one instance at a time and you can remap it across instances. You won't have to pay for elastic IP service if it is attached to a server. Suppose you are working and if it attached to a server, then you don't have to pay for that. But if you aren't attached to a server, then you will have to pay for that elastic IP to AWS. And this is a picture showing that how you can use elastic IP and how elastic IP is used. Because see, suppose you are a user and elastic IP just give you a fixed user IPv4 address, and using that IPv4 address you can connect to your instance again and again, and that will be logged like public subnet. Here it is, that will be logged actually, and that will be your own IPv4 address until you don't delete it. Next is how this can help. So with an elastic IP address, we can handle the failure of an instance or software by rapidly remapping the address to other instance in same account. Suppose you have two instances and you are working on an instance, and somehow it just fails. Okay, so that failure of an instance can cause trouble to you. So to handle that, this elastic IP address helps us a lot. Why? Because suppose your first instance is failed here, and now what you want that work to be switched on another instance. So your fixed public IP, this elastic IP, will help you. This will be remapped to another instance, which is instance 2 or instance 3, whatever name you have given to your instance. So it will be remapped to that instance, and then you can continue your work there actually. So now you can only have 5 elastic IP in your account. Okay, but if you want to increase it, you can ask AWS for that. How you can avoid using elastic IP? So you can think of other alternatives that are available to you. You could use a random public IP and register a DNS name to it. That will charge a lot. Or you can use a load balancer with a static host. So this is all. Let's go to hands-on now. Next hands-on is, suppose this is your instance. You have made this instance. Okay, this is stopped. Let's run it now. As I told you that whenever you will start and stop your instance, your public IPv4 address will be changed. Okay, so to fix that we use elastic IP. So this is our public IPv4 address. Let it be started. Okay, so this is my public IPv4 address, which is 54.253.137.94. okay, just remember it. I'll just stop my instance and then again restart it, and you will see that this public IPv4 address changes. Let's stop and restart it. This public IPv4 address is gone now. Now let me start it, run it again, and you will see that my address, public IPv4 address, will be changed now. And look, my IPv4 address is now 3.26.49.20 now. It is changed now. So how I can fix this public IPv4 address? I can use this elastic IP, which is there in the left side in network and security, the second one is elastic IPs. And now you can allocate one elastic IP address to yourself. Just allocate this. You don't have to change anything. So this is my allocated IPv4 address. Suppose I am just looking this 13.210.97.65. This is my allocated IPv4 address. If I name it here, let me name it like ELIP, elastic IP. Okay, I am just saving it with this name. Now what I'll do, I'll just associate this elastic IP address which is present here in action, or you can see here. So in action, associate elastic IP address, I'll just click it and I'll associate this elastic IP address to my instance. So I have associated this IP address with my instance which was running, and its IP address was something like 3.2. Which was in past. Okay, now it is changed. You can see it is changed now, and this public IPv4 address is now ELIP, that I have enabled, that I have created my elastic IP. Now this is that public IPv4 address. What I have to do, I just have to connect and check whether it connects me to the EC2 instance or not. So let's click on this connect button and then just let us connect it now. And so I am successfully connected with my EC2 instance. I'll just write one command to check whether it is working or not. So yeah, it is working fine. Now I have to stop and start the instance and check whether this IPv4 address is being changed or not. So if I'll stop, you will see that like private IPv4 address, it will also be fixed right now. Just see. I'm just stopping it. And yep, see, this public IPv4 address is here only and my instance state is stopped. In the previous case, when I had not created elastic IP and when I just stopped this instance in the past, what I just counted, and that was public IPv4 address was not there, it was just dash dash, and here I can see this public IPv4 address which is ELIP, which I have created in elastic IP address. Now I'll just connect or start my instance, which is instance state. I'll just start it, and now it is being started, and you will see that my public IPv4 address will not be changed, it will be the same. Though we have stopped and started our instance, but still we can see that our public IPv4 address has not been changed yet. So this was the hands-on. Now to prevent the extra charges, you can just disassociate your elastic IP and then release that IP to just prevent that extra charges that will be given to you by AWS. So just disassociate with this elastic IP address now, because if you are not connected with the server, then AWS will charge you for elastic IP address service. So I have just released, and now you can see my instance will have a default IP address that is given by AWS. Look, this is the IP address. So that's it. Let's meet in the next lecture. Thank you. Hello everyone. So in this video, we will see CloudWatch metrics, how CloudWatch is attached to AWS, and we will see all the things here. Now AWS provided metrics, like AWS provides some metrics, and these are like basic monitoring metrics which are fetched at a 5-minute interval. Okay, AWS pushes them for you. Now detail monitoring, it is a bit paid, and metrics are fetched at an interval of 1 minute. Okay, next is it includes CPU, network, disk, and status check metrics. Just remember these four are very important to you for the exam point of view. Custom metrics, you can push them, these metrics you can push, and basic resolution is 1 minute resolution, and if you want a high resolution, then you can go to 1 second resolution also. It includes RAM application level metrics. Make sure that your IAM permission of the EC2 role is given correctly. Okay, next is CPU utilization plus credit usage slash balance. This is the first metrics that is provided to you by AWS. You can check your CPU utilization, your credit usage, and credit balance that is used for burst. Network in or network out, everything will be provided by AWS. Next is status check, instance status, or the check the EC2 VM, your virtual machine, whether it is working correctly or not. Next is system status, check your hardware in which your instance is running, whether it is running correctly or it has some problem. Next is disk read write and bytes operations are given to you by AWS. Important note that RAM status is not included in the AWS EC2 metrics. It is not there. Next, do some hands-on and check whether. So here is my instance that I have created. I have just opened this instance. I hope you know how to open it. If you don't, just go to this instance, your running instance, and just click on this blue thing, okay, this link type thing, and just click it, that instance ID, and then you will be in your instance. Okay, now what you have to do, you just have to monitor. Okay, so you just have to click this monitoring button, and in this monitoring button you will see like these all things like CPU utilization, network in, network out bytes, network packets, CPU utilization, how much CPU is being utilized here, that is your CPU utilization. If your instance is running, it will show you. If you are working and if your instance has a load, then it will show you that CPU is being utilized here. And network in and network out bytes, network packets here, whether in how much network is coming into your EC2 instance and how much network is going outside from your EC2 instance. Packets transfer also will be shown here, network packets out or network packets in. Disk read bytes, disk read operation, all this will be 0. And why 0? Because we have an EBS backed instance, so that is why it will be 0. Credit usage and credit balance will be shown to you. You can also check it from here. If you want to add to dashboard, you can add some these two dashboards and you can have a good view of these. Like you can just create a dashboard of whatever name you want, so you can name anything like EC2 dashboard, and I have created, and now I'll be making a custom dashboard here. Like I'll be just given that what thing I want to give, so I can just do next here and I can check all the metrics here. Okay, what I have to do, I'll just delete this dashboard now. Okay, I can have a proper view from this EC2 dashboard. Now what I can do, I can also enable this manage detail monitoring. What is this detail monitoring? Now that I said AWS pushes your monitoring at every 5-minute intervals, but for if you want some detail monitoring, so AWS will push it for you at every 1 minute. If you have a heavy workload and if you want to be like in your budget, so what you will do, you will just pay for this detail monitoring and it will provide you the instance metrics at every 1 minute interval. By default it is 5 minutes, but then it will provide you at every 1 minute interval. This is your detail monitoring. You can just enable it and confirm it, but it will charge you a lot, so I am not gonna enable it right now because I don't have any work. So this was the thing, how you can see that CloudWatch is attached to AWS. So that's it. Let's meet in our next video. Thank you. Hello folks, so in this video we will see unified CloudWatch agents. So for virtual servers, EC2 instances or on-premises servers, these unified CloudWatch agents are there. They collect additional system level metrics such as RAM, process, use disk space, etc. They collect logs to send to collect CloudWatch logs like access logs or error logs, whatever the processes are being run in your like servers, virtual servers, all these are collected by these. No logs from inside your EC2 instance will be sent to CloudWatch logs without using an agent. So basically these CloudWatch agents send these logs from your EC2 instance inside your EC2 instance to the CloudWatch. Okay, they have a centralized configuration system using the SSM parameter store. but when you are using this, you have to make sure that IAM permissions are given correctly, and default namespaces for metrics collected by the unified CloudWatch agent is CW agent, and that can be configured and changed. This is the figure that shows you that how you can use your CloudWatch. You can send your metrics, or you can check your metrics to CloudWatch using CloudWatch agents. This is CloudWatch and EC2 instance, which is unified with CW agent. So basically these logs are being pushed there, okay, and metrics are being pushed, and this is the server which is sending all the things to CloudWatch. Okay, server is also sending these to unified CW agent. With the help of unified CW agent, server is also sending metrics and logs to CloudWatch, and EC2 instance is also doing this. Okay, next is collect metrics like Procstat plugin. What is this? So Procstat plugin basically collect metrics and monitor system utilization of individual process. It supports both Linux and Windows servers. Example is, suppose the CPU is taking some amount of time in processing, so that process time, that metrics will be also monitored by Procstat plugin. Next is amount of memory the process is using. So basically whatever an individual process is doing, like time or memory, all these things will be collected, and you have to select which process to monitor by. So suppose PID file, name of process is identification number, which is PID actually. So name of the process, PID files they create, or either exe, like process name that match string you specify, regex, and pattern like command lines used to start the processes. All these things will be monitored by these. Metrics collected by Procstat plugin begins with Procstat prefix, like Procstat CPU time, Procstat CPU usage. So all the data and metrics which is being collected by Procstat plugin will be having an name, will be having a Procstat prefix, and this will show that these all data are being collected by Procstat. Okay, this prefix shows you. So I hope this is clear to you. Let's meet in our next lecture. Thank you. Hello everyone. So in this video we will see that how we can make a CloudWatch agent. Okay, and we will just configure this CloudWatch agent for our access for our log files actually. And let us start by doing all these things. So first of all, what you have to do in AWS, you have to make a role, IAM role. You have to configure that. I have made for you actually. So I'll be just opening it like IAM. You have to search IAM, and then you have to open your IAM from here. Just wait. And this in your IAM console, you have to go to roles. Okay, just go to the roles, and then you will be making like create a role. Go to this create a role, and then on this AWS service, just your use case will be EC2. So select your EC2 here, then click on next. Like I am choosing this EC2, and then I'll be just clicking on this next. And what now? And now here you have to select for CloudWatch agent. Okay, and in this CloudWatch agent you have two policy, admin and server. Just click both the policy and just click on both the policies. Like I have just ticked the both like admin and server policies, and then I'll be pressing this next, and then you have to create a role here. Just add a meaningful name like Amazon CloudWatch agent, I'll be naming it. Okay, so you can name whatever meaningful name you want. Nice. And then you can work on it. So first of all, just create this Amazon EC2. I'll be just naming it Amazon EC2 role for CloudWatch. Okay, this is my name. And okay, what now? So in the next part I'll be just this is my description. These are my JSON files. If you will open this, you will see that JSON file is here. Your JSON file is actually, just wait, yeah, you can see all the things in your JSON file. In admin policy you have get parameter and put parameter both, so that is a better thing. Now I'll be just creating this policy. Okay, just create this policy, create this role from here, click here, and then you a role will be created of your name. I'll be just leaving this page because I have already created it for you, Amazon EC2 role for CloudWatch, and then I'll not be selecting it right now because I have to add it to to that EC2 instance. So for that I'll have to make an EC2 instance. I'll just cut this. Now we will select EC2, and this is my Elastic Compute Cloud EC2 instance, and I'll be launching an instance, and in that I'll be configuring, I'll be just adding this IAM policy. Okay, so let us launch this instance now. Let us name it like my CloudWatch, and that is better name. Okay, do one thing, you can select, like if you have this key pair stuff, you can just proceed without a key pair, that is all okay. In the security group you have to allow HTTP traffic from internet, because we will be making an HTML file and we will be running it on browser. So for that you should have allow HTTP traffic from the internet, and then launch this instance. Okay, now what? So we will be connecting this instance and we will be configuring CloudWatch agent for this, and before that we will be just running some command, and we will be seeing that how we can actually make a file, HTML file, and we can connect or see it in browser using our public IPv4 ID. And for that I have this instance. Now I'll be connecting to my instance. Let us connect it. So it isn't running right now, let it be started. Yep, it is running now. Let us connect to it. And before connecting to it, let me do one thing. I'll be adding, like in this instance, what I have to do in actions and in security, you have to modify IAM role of this. You have to choose one IAM role, which is Amazon EC2 role for CloudWatch, and you have to update your IAM role for this. Now you can connect, and whatever configuration you will be doing, this IAM role is there. Okay, and access policy and your admin policy is there for CloudWatch agent. What next? So let us connect and write some basic commands. And what are those commands? Like I'll be just entering into my root mode. I'll be entering into a super user using sudo su. So yeah, I am a root user now. What I have to do, I have to install httpd service. So for that I will be writing yum install httpd service, and yep, it will ask yes, so why, and then it is now installed. And after it is installed, we will be doing some echo stuff, like echo hello world. What now? So I'll be creating a file, and just I'll be entering its information, where www/html/ my file name is index.html, and that is better. Enter, and yeah, that file is created. And what I can do now, I can just start this service using sudo systemctl. Okay, and start httpd. I can also run one thing more, like enable. Using enable I can restart this httpd service. So I can write enable also, no worries, and both the things works for me. Now at as I have created this .html and into this IP, and as I have written this content hello world. Okay, so whenever I'll just copy and paste my public IP in my browser, I'll see that hello world here. You can see, just wait, you can see this hello world here, this hello world is here, this is my content for EC2. So that is a better thing. What now? Now I'll be configuring CloudWatch agent. Okay, so let us clear it now. For that, to configure your CloudWatch agent, it is a very tedious task. Actually, it is a complex task, and to make that simple, I have entered all the required commands. I have just created this file for you in this code, and this code basically shows you step by step configuration of your CloudWatch agent. What you have to do, you just have to copy this code and then paste sudo yum install Amazon CloudWatch agent, and yep, my Amazon CloudWatch agent will be installed now. I'll be just pressing yes, y, and yep, it is being installed. And once it is installed, we will be opening a wizard for configuration of Amazon EC2 CloudWatch agent, and we will be just configuring it. Okay, so this is complete. You can see this is complete message. This complete message is here, and make sure you give IAM roles permission correctly, and you are connecting your Amazon EC2 with your IAM role, and that is one thing you should keep in mind. Now run the wizard. To run the wizard, I have this sudo opt AWS Amazon CloudWatch agent. So I'll be just copying and pasting this command here. I'll paste this command here and just enter. Yep, it will show me some of the choices which I have to make to configure this. So I'll be just choosing some default values, and I'll be entering wherever it is required. I'll be changing all those default values. Like, on which OS are you planning to use the agent? So yes, it is my Linux agent. Next is EC2. I want to use EC2, so I'll be keeping it default. Next is, which user are you planning? CW agent, no worries. Do you want to turn on stats daemon? Yes, of course. Which port? The default port. What is the collect interval for stats daemon? So if it is 10 seconds, I'll be keeping it default as 10 seconds. What is the aggregation interval for metrics collected by stats daemon? So yeah, it is I do not have to aggregate, so I'll be choosing default value. Do you want to monitor metrics? Of course, but if I would have chosen no, that would have been perfect. But yep, as I have just entered yes, so no worries. Do you want to monitor any host metrics? So yes. Do you want to monitor CPU metrics per core? Yes. Do you want to add EC2 dimensions? Why not? Do you want to aggregate EC2 dimensions? Of course. Would you like to collect metrics at high resolution? Yes. At every 60 seconds. Which default metrics configuration do you want? Basic. Are you satisfied with the above configuration? Actually, I am satisfied, so I'll be just choosing yes. And this is my JSON configuration, whatever I have chosen yet. So do you have any existing CloudWatch agent? So I don't have. Okay, so I'll be writing no, and that no is not actually supported. I'll be choosing 2 for that. Do you want to monitor any log files? So yes, I want to. Log file path, so I'll be giving path for my error files and log files. So for access log files, I'll be giving my var path, like /var /log /httpd /access log. Okay, enter. Default choice access log. Log group class standard. Log stream instance ID. I'll be keeping it for every 7 days, so I'll be choosing option 5. Do you want to specify any additional log files to monitor? Yes, I want. Log file path /var /log /httpd /error log. Okay, so this is one thing, and yep, I'll just enter it, and my error log will also be added. Error log standard. All the things will be default. I'll be choosing 5 here. Default choice. No, I don't have to add any additional log files now, so I'll be just choosing no. Do you want the CloudWatch agent to also retrieve X-ray traces? Okay. Do you have any existing X-ray daemon configuration to import for migration? No. Which UDP port do you want XRAY daemon to listen to? Same, default. Enter the maximum number of concurrent calls, default. Enter the AWS region to send, okay, optional hai. So what we will do, we will just click 0 here, and yep. Do you want to store the configuration in SSM parameter store? So whatever choices you have made, this is your JSON file which is created. Okay, current configuration of your choices are here as a JSON. Now do you want to store this configuration in SSM parameter store? Actually I want to store, so I'll be choosing one. And what parameters store name? So Amazon CloudWatch Linux is the perfect name for me, so I'll be choosing this. Now default choice AP South is 2, and yep, AWS credential should be used to send JSON. So this ASIA one will be selected. That is actually okay. And yep, my Amazon CloudWatch Linux 2 has been created and it is successfully put on parameter store. So for that I'll be checking my parameter store, and to check that, what I have to do, I have to open this parameter store, and in this parameter store I have one parameter which is CloudWatch Linux. Okay, you can visit your parameter store actually from your search tab, and in that search tab you have to enter AWS System Manager, and in that System Manager you will be locating your parameter store, and in that you have this one. And this is my configuration for parameter store. You can say this is my configuration, default configuration. And now what I have to do, I have to boot up this configuration in my EC2 instance. Okay, so to boot up this configuration I have two choices. Either I'll be I have two options. Either I'll be just using this SSM1 command, in which I'll be adding this SSM, like the name of that parameter store, that JSON file, or I'll be adding the path of that. Okay, so either adding path, I'll be choosing this one, and I'll just go to my instance and I'll just paste it, and now I have to enter, and yep, configuration validation is succeeded, configuration validation second phase succeeded, everything is succeeded. So my CloudWatch agent is perfectly booted up here, and you can, whenever you will just update, you will refresh all these things, you will make changes in your file, everything will be stored in your log files, and you can check that log file in your CloudWatch, and then in log groups you can check. Okay, in CloudWatch log groups, you can check access log and your error logs, that will be updated whenever you will update the things here. Okay, so this is how we collect metrics using CloudWatch agent. We send metrics using CloudWatch agent, and in those log files actually that process, individual processes are stored. So this is how I have to configure, we can configure our CloudWatch agent. So I hope this video was much understandable to you. This video was actually very simple. This contained some basic configurations. So let's meet in our next video. Till then, thank you.
So hello everyone. In this video, we will see status checks in EC2. Okay, so let us start. So status checks are basically automated checks to identify hardware and software issues in AWS. System status checks, what are these? So we can see that system status checks basically monitors issues with AWS systems, which might be software, hardware issues on the physical host. That can be loss of system power and etc. It monitors personal health. It checks personal health dashboard for any scheduled critical maintenance by AWS to your instances host. Suppose if there is any personal health dashboard, and if it is scheduled for critical maintenance, and if your hardware fails, then it will just connect you to the other hardware if you will start and stop and start the instance. Okay, so then it migrates to a new host, to a new hardware that I'll be showing you in a picture in a moment. Let's see the third case, instance status check. First is system status checks, and second is instance status checks. It basically checks the status of an instance, like how the software and network configuration of your instance is done. If there is any invalid network configuration or used up memory, then it will monitor that. And for that, the resolution is you can change the instance configuration, or you can reboot the instance. Here is the picture depicting the first case, that is system status checks. So how you can do that? Suppose if you stop and start your this thing, then what happens? Your hardware, suppose if your first hardware fails, then it will migrate you to another host, which is host 2. Okay, so it is, suppose if your health dashboard has scheduled any critical maintenance for your instance host, suppose it is host 1, then it is failed, it will not be connected, then that will be migrated to your host 2. Next is status checks, CW metrics and recovery, CloudWatch metrics and recovery. Now, CloudWatch metrics is done on its status is basically updated on 1 minute interval, and that is status check field system, status check field instance, and status check field for both system and instances. Okay. Next is option one, CloudWatch alarm. So what is this CloudWatch alarm? So it recover EC2 instances with same public and private IP, EIP, that is basically elastic IP, and metadata and placement group. Okay, it just recovers your EC2 instance. If some instances fail, then it recovers. It notifies using SNS also. And option two is auto scaling group. So what is this auto scaling group? Basically, it sets your minimum, maximum, or desired one to recover an instance, but won't keep the same private and elastic IP. So what is the benefit of using auto scaling group? So suppose if you are using auto scaling group, and if you have done automation very well, then your instance will be recovered very well. Okay, it might be recovered, but your private elastic IP will not be safe, but you will get your IP at least, or your instance at least. Next is this is option one. Here you can see CloudWatch is monitoring EC2 instance logs, and if anything fails, it triggers it to CloudWatch alarm, and then it that CloudWatch alarm recovers your EC2 instance, and it might also send notification to Amazon SNS. This is auto scaling group. Suppose your instance fails, then it will launch another instance, but you will get another IP, different elastic IP, and your private IP won't be same anymore, but at least you will get your instance recovered. So that's it for today's lecture. Let's meet in next lecture. Hello everyone. So in this video, we will see CloudWatch status alarm. Okay, so how does it works? We will see, and then we will see that how we can just enable that alarm and recover our instance, or see what it does. Okay, so for you, I have created an instance. So you have to launch an instance, and in that launched instance, what you have to do, I'll show you. I have configured it for you. So let us see the steps now. In instance ID, you have to click your instance ID, and in that you have to go to status and alarms. Okay, here is the status and alarms. You have to just go into that, and now in this we have to create actions. In actions, we have to create status check alarms. Okay, and in this, what we will do, we will just create an instance status. Okay, in actions, we have to create status check alarm, and in this we will create an alarm, then we will write any of the existing topic you can write here. And then what you have to do, you have to enable this alarm action here. Suppose you will be enabling this alarm action, like just tick it, and then you can recover, reboot, stop, or terminate your instance, right? So suppose I want to recover my instance, then I'll just click on recover, then consecutive period, then I'll just keep it default, and then I'll just create this instance. So see, here is the create one. So I'll just click this button, and my instance will be created. What instance? Like my alarms will be created. Sorry, manage CloudWatch alarms will be created. Okay, so this will be created, and as this will be created, we have to check this alarm whether it is created or not. Then we will just go to the service like CloudWatch. Okay, we have to write CloudWatch alarm, and here CloudWatch will be open. Just click on it. You have to click on it. Now this in alarms or all alarms, you can click anyone. So this all alarms, you have to click here. And in this all alarms, see, I have created an alarm, okay, and its state is okay, by the way. You will see an alarm here. You have to click on it, and your status will be shown here, right? Then your events, your details for this alarm will be shown. Everything will be shown here. You can see the history of this also, that what this alarm has been doing. So I have just configured it at this time. State has been updated at this time. This the Whenever you will create an alarm, CloudWatch alarm, this message will be there, insufficient data. So it takes some time to update itself from insufficient data to okay, and then you can just trigger it, trigger this alarm. You can just enable this alarm in your Cloud Shell. And how you can do that? You just have to write some basic commands, and for that you have to seek to Google or your browser, and you have to write set alarm state, okay, in AWS, and then CloudWatch agent, or you can write anything. CloudWatch set alarm state. You can write, and then the first documentation will be open, and in that you have to come to this, and you will see the synopsis. And to set alarm state, you have to enter your alarm name, then state value, and then state reason, that why do you want to just enable this alarm. And here I have entered everything, every sort of thing for you. Just watch it. I've already configured it for you. We'll just clear it and then we will see. Okay, so this was our command. AWS, look, AWS CloudWatch, and then you have to write set alarm state like this, and then alarm name. Alarm name, I'll be copying it from here. Like suppose I had my alarm name. See, in the CloudWatch alarm, you will be having your alarm name here. You just have to copy it, right? Just copy it from here and then paste it using a right click button. Okay. So this is your state name, your alarm name. This is your alarm name, set alarm state. And this is your set alarm value. Your alarm value should be alarm. Okay. Your state value should be alarm, because some possible values are here. It is shown that the possible values can be okay, alarm, and insufficient data. So you have to show the value alarm. Okay. You have okay and insufficient data, but you will have to show it alarm here. So you will just enter state value as alarm, and then state reason will be testing recovery action. You can write any, you can give any reason for that, and then just press enter. And whenever you will press enter, right? Suppose I have pressed enter here, then what? Then I'll see that my alarm will be in alarm state. Okay, I'll just refresh it, and it is in alarm state. Okay, so that means your hardware is being changed. Uh, AWS is sending alarm that okay, there is some issue in hardware, and what now? So whenever your instance gets recovered, because I had chosen as a recover, okay, my state as recover alarm state. So what I want to recover my EC2 instance. Okay, so now what? Now AWS will just recover my instance, and when it is recovered, when it again becomes okay, so it will give me a message, or it will notify me through mail, my entered mail ID. It will just send me one mail that okay, your instance has been recovered and you can work on it now. So that's it for today's lecture. Let's meet in next lecture. I hope this was um, clear to you, and let's meet in our next lecture. Thank you.
Hello friends, so in this lecture we will see EC2 hibernation. Okay, so basically we know that there are two options whenever we launch an EC2 instance, and those are stop and terminate instances option, right? We get the option and we very oftenly stop an instance or terminate an instance. But there is also another option, you might have seen that, which is EC2 Hibernate. So how we can work on that option and what is that option? Let us explore in this lecture. So basically termination, what is termination? Let us see. So basically termination is that your EBS volumes also set up is to be destroyed. Your EBS volumes will be destroyed while whenever you will terminate your EC2 instance. Next, stop. So basically, whenever you stop your instance, then the data on EBS, okay, like EBS volume actually, the data on the disk is kept intact in the later start. Whenever you stop the instance and start later, then again that EBS is basically stored and your work is basically stored, the data is stored and it is kept intact. Whenever you will start it later on, your IB will be changed, but your work will not. Okay. On start, the following happens. What is the process? Let us see. First, start basically it gets the OS boots and the EC2 user data scripts runs there in the backend. Now, whenever you start again and again, the following starts. Uh, in that EC2 user data doesn't actually runs again. The OS just boots up and the following starts, and then your application starts. Caches that are there in your instances gets warmed up, and that can take a while. Okay, to start, right? Next is let us see what is EC2 Hibernate. So introducing EC2 Hibernate, the RAM state is preserved whenever you are hibernating an instance. Then your RAM state will be preserved. The instance boot is much faster. Also, the the hood, the RAM state is written to a file in the root EBS volume, and the root EBS volume that should be encrypted whenever you are hibernating. That we will see in our hands-on, right? Use cases. So, whenever we are having a long run process, then we can hibernate our EC2 instance or the services that takes time to initialize. There we can use EC2 hibernation, right? This is the picture depicting EC2 hibernation. So this is basically hibernation. In hibernation, your EC2 instance doesn't actually shuts down. Okay, it is running in the background, but you have to provide a memory for that. We will also see that in our hands-on. So let us move to hands-on and let us see how does it works, right? So this is our AWS EC2 dashboard. So let us launch an instance and see how hibernation actually works. So suppose I name my instance, any name I can give, suppose dash dash I'm giving. AMI, I'll choose default Amazon DNS, okay. Instance type T2.micro, that is good. Key pair, I'll choose my default key pair, or I'll choose suppose my EC2 SSH or first instance key, whatever I want, I can choose. So I'll choose my EC2 SSH. These are basically security groups, and that is okay. I'll just keep it default. Now here in configure storage, what you have to do, you have to open this, and then you have to add a new volume if you want, right? Or you can go to advanced settings. Okay. Suppose I'm here in advanced settings. Next, in EBS volumes, what you have to do, you have to just drop down this volume. You can see this volume is 1 AMI root 8 GIB. So 8 gigabytes memory is basically allocated to my instance. But this T2.micro, as you can see, it just uses 1 GB of memory. So here, whenever I'll be launching an instance, so here I am having 8 GB and my T2.micro instance is taking only 1 GB. So this allocated memory of 8 GB is enough to store my EC2 instance load or workload. So I don't have to worry for that. But yeah, if you are working with any other instance type, you should take care of this, that your EBS volume should have much like a memory to store your EC2 instance data, right? So in this volume, I have to do one thing. I have to encrypt that. As I said, that EBS should be encrypted. So I have encrypted it here using this encryption. Okay. Now what? Now in advanced details, we will see. Here we will see hibernation. So stop hibernate behavior. This is my hibernate behavior. I have to choose it. I have to enable it. Okay. I have to enable this hibernate behavior and then I'll just launch my instance. All the settings I'll be keeping it default. I'll just simply launch my instance now. Okay, you can see my instance is successfully initiated now. What next? So I'll just open my instance and I'll connect to my instance. Okay, my instance is running here. Now what? So let me tell you one thing. Whenever you stop your instance, then what happens? If you terminate your instance, everything will be lost. But when you will stop your instance, your new IP will be allocated to you, and your instance will actually be shut down. It will not be up. But when you are choosing instance state as hibernate. Okay, so this hibernate instance, this state actually hibernates your instance. That means that your instance will be running on background, but it won't be taking that much CPU process. Okay, let us connect to our EC2 instance and see the next steps. So I don't have to do anything here. I just have to write uptime. That will see that from how many times this instance is up. So this is up from last 1 minute as I have created it just now. So it is up from last 1 minute, right? I am one user, load averages 1.20. Okay. Now what I'll do, I'll just hibernate my instance. So you can see I'll choose it and instance state and I am just hibernating it. See, whenever you are working with this instance, uh, this message might appear, fail to hibernate the instance. This is because your AWS might not have been just processed it yet. You can retry it and again just refresh this page and now you can retry it. Your instance state will now be hibernated. You can check it now. Okay, you can see this is successfully hibernated because AWS might not have been updated yet in the backend. So this might give you this red tick sometimes. So okay, uh, now what I have to do, I have to start this instance again, right? So you can say fail to start the instance. Why so? Because it hasn't been updated. So I'll just refresh it again. And after one refresh or two refresh, you will see that my instance will be started if I will start it again. Just check. It is successfully started. So what I wanted to say basically is that sometimes AWS might not have hibernated what you want. Okay. So just cut all these notification. Now, uh, as you see, my instance is running now. Just wait. Okay, as you can see, my instance is running now. And if I would have stopped it, it would have been restarted again with a new IP. Correct. And also, whenever I stop it, that uptime is not there. Uptime is again 0 minutes because it is a it will behave like a new instance that is having a newer IP. But here, when I write uptime, so it will show me 3 minutes or 4 minutes. You can see this is up from last 3 minutes. That is because I hibernated it. Uh, and when I hibernated it, it was actually running in background, but this uptime is showing me this 3 minutes. If I would have stopped it or terminated it, if I would have terminated it, I would have lost my instance, and if I would have stopped it, then this uptime would have like 0 minutes or 1 minute. But it is running from last 3 minutes, and now I guess it is 4 minutes, right? So this is actually cool practical. You can see that we can just check our instance whether it is hibernated or not by writing uptime. So I hope that this was much clear to you and how we can work on hibernation and what is hibernation. So let's meet in our next lecture. Until then, thank you.
Hello everyone. So in this tutorial, we will see AMI's overview. So what is this AMI? AMI is basically Amazon Machine Image. And what does it contains? So basically it contains all the configuration of OS in your EC2 instance. Suppose you are making an EC2 instance and you want all the software configurations
suppose like you want Windows configuration or Linux configuration, you can choose any of the AMIs and customize it at your own work criteria. Okay. Next is AMIs are customization of an instance, EC2 instance basically, and you can add your own software configuration, OS or operating system you say, or monitoring tools. You can add all those things. Suppose you are making an AMI, so you can create your own AMI and you can just configure it at your own. Okay. Uh, while you are customizing your EC2 instance, so basically it will have some faster boot, okay, and configuration time will be lesser because all your software will be pre-packaged as you want. You will install it, you will pre-install it while making your AMIs. Okay, so suppose you are making an AMI and then what you are doing, you will just enter all the configuration that you want for your AMI, okay, and you will create that AMI. So whenever you will boot it or you will configure it, so that will be configured too quickly because all the software configurations will be pre-packaged by you only. Next is AMI. AMI is built for a specific region. Suppose we are making AMI, so we make it for a specific region, but we can share it for another regions too. Okay, we can copy it across regions and also we can add accounts in our AMIs. We can add some accounts in our AMIs that which account will be able to access AMI. Now you can also launch EC2 instances from a public AMI, you make and maintain them yourself. So, in like before, what we were doing, we were just using this service, a public AMI, that we were choosing an AMI, okay, and we were just selecting that AMI, and then as per our need, and we were launching our instance. So this is one thing. Next thing is an AWS Marketplace AMI. So basically, an AMI someone else made and potentially sells it to you according to your need. Suppose you need an AMI, a different customized AMI. So someone is making that AMI for you. So what you do, you just go that there and you see the configurations of AMI and you check whether it is of your work or not. If it is of your work, then you buy it from other seller. So this is what other businesses also do. Some businesses just make AMIs and then sell them to AWS Marketplace. So this is one thing. Another thing is AMI process. So in an instance, what you have to do, so you have to start an EC2 instance and customize it. Then you have to stop that instance for data integrity. You have to build an AMI. This will also create EBS snapshots for you. Okay, then the next step will be launch instances from other AMI. Suppose you have made that AMI and then you will be launching other instances from that particular AMI. So this is one image that is showing, suppose this is your instance which is in region US East 1A, and this is an instance you have just started it and customized it. Then you have created your AMI for this. You have your custom AMI here because in this you have customized this instance and then you have created AMI, basically image you have created, and then you will be launching another instances, other region also. You can do this, or you can also launch your AMI in the same region also. Like if this is US East 1A, you can also launch other instance in US East 1A, or you can launch other instance in US East 1B using this custom AMI only. Okay, so this was one thing in the overview. So I hope this overview was much clear to you. So let's meet in our next video. In next video, we will be doing some hands-on on AMIs. So let's wait for the next lecture. Till then, thank you. Hello everyone. So in this video, we are going to see that how we can work with AMIs. Okay, AMIs are basically like images which contains the software configuration. Okay, so let us see how we can work with AMIs, how we can launch instances from the AMIs. Okay, so I have created that for you, but before that, I will show you how we can make instances and what settings we have to do. So first of all, when you will be launching an AMI, so before launching an AMI, you have to create an instance. So for that, you will have to come here in a launch instance. Just click here in launch instances, and then in this page, in launch instances page, okay, you have to name your instance the same way. The way you make an instance, you have to do the same, but in advanced details, you have to make some changes that I'll be telling you. You have to add something like in this launch an instance, you have to name your instance here, right? Then you have to select your AMIs, whatever AMI you want, okay? Then what? Then you have to check the instance type, which instance type you want. Then key pair, that is not basically required, but yeah, you should select one key pair. So if you have created one, you can choose that from here, or you can create a new key pair and then you can name that. Okay, I hope till now you know how to make EC2 instances. Then I'll be choosing a security group, so you can create a security group. If you are creating a security group, don't forget to select this one, allow HTTP traffic from internet. Don't forget to select this one. As I have created one, so I'll be selecting like Launch Wizard 6 or whatever I am named. Okay. So basically, I'll be selecting this Launch Wizard 6 or Launch Wizard 7 because in these security groups, I have named like I have ticked that HTTP service. Okay. Now what? Now in advanced details, I'll be just opening this. And here in the last part in user data, what you have to do, you have to give some commands. Okay. You can do this here or you can connect your instance and do that here. Just click all these stuffs, okay? And before writing this yum, you should be in your root user, okay? So let us do this first. What you can do, you can just control C and you can just paste it here like this, right? And here I'll suggest you that before writing this, you get into your root user, okay? So this is one thing. And then you can launch your instance from here. Let me go back, I'll show you. I have created this instance, my instance, and I have entered that user data for you, right? Now what? Now, when this instance gets created, just click on this, copy this public IP, and in user data, I also pasted, in my instance, I have also pasted this one, this line also. So when I'll just copy and paste my link, this, okay, just cut it for now. Yeah. So when I'll copy this public IPv4 in my tab, so what I'll see that one file is generated, one file is created there. Let it be run. Okay, so this file is created here because I have entered this command also, right? Now what? Let's cancel it now. Now go to your instance, and in this instance that you have created right now from selecting AMIs or not and all. Now what? Now just go to this actions. In this action page, go to image and templates, this part, and just select this one. And from here, just click create image. And when you will create image, your one image will be created and that will be stored in this images part in AMI. Okay. And the left side, it is images part, and here in AMIs, you will see that. So over here, an AMI will be created. You can name anything like I have created it my AMI. Okay. And then what? Then I'll be just opening it. And when I'll open it, what you have to do, you have to wait. Okay. And for what? Just wait until this status gets available. Just check the status. And you will when you will create an image also, it you will get a notification. You will get a notification that check the status of your AMI. When it is on available state, then only disable your instance or do anything you want. Okay. So here my status is available. But when you will make your AMI, your status will be on pending. Okay, so you just have to wait for a moment or two. In 2 or 3 minutes or 4 or 5 minutes, you will see that this status is available here. Okay, then what? Then you have to just click on it, and then you will be able to launch instances from this AMI, right? And if you want to launch instances from this AMI, suppose select this AMI. I'm doing that for you. Just check. Just launch instance from this AMI, right? Okay, so my instance page is open here. What I have to do, I have to give a meaningful name to this instance like my AMI. I just written this. Okay, this is okay, all okay. That my AMI, I'll get to know that this is my AMI instance. I'll just name it my AMI instance. Right. Okay. Now what? Now I'll be choosing in this AMI catalog. What should I do? So I should choose my AMI because I have created this. You will get to see these all options. If you are launching your instance from AMI option, by default, this AMI will be selected AMI from catalog, which is owned by you actually. Okay. This shows that owned by me and this is configured by me. I have in user details, I have just entered that HTTPD service. I have installed that service. I have started that service. Okay, so basically that service allows me to copy my public IPv4 address into my browser and it will show the contents of the instances, right? And then when I'll be selecting this one in my MIs, you have to select owned instances that is owned by you actually owned by me, my AMI. Okay, it is selected. Instance type, you can select anything. Key pair, you can select anything. Like suppose I am selecting this my first instance key, right? You can create a security group or you can select existing one. So I'll be just selecting existing one. I'll be selecting launch wizard 6 suppose because I have enabled. Again, don't forget when you are creating your security group, don't forget to tick that HTTP column. Okay. Now what? Now in advanced details, I'll be doing one change. I'll be just entering this file name here, this echo file content and file path here, and I'll see that now I don't have to install any HTTPD service for this instance. Okay, so I have created this for you. Let me show you. Just copy this and you because in the previous part, what you have done, let us see. In your AMI, okay, your instance contains when you are creating your first instance, and in that first instance, what happened? Your user data is entered there. Okay, you have entered a user data which contains this code, which contains this code. This code actually installs HTTPD service, starts HTTPD service. So your first instance contains all these things, and you have created an AMI from that instance. That means that AMI also contains this settings installed. Like this is pre-configured in your AMI, you can see, right? And when you are just creating this instance, new instance, which is my instance or AMI instance, what you will see. Uh, you can just copy it from here. Okay, my AMI instance, and here in my AMI instance, just copy your public ID and paste it here. When you will paste it here, you will see that that file will be created actually because you have entered that in your user data to create that file and it is here created. So I hope this was much clear to you that how you can use AMI and how you can configure things in user data, right? So that's all for today's lecture. Let's meet next day. Thank you. Hello everyone. So in this lecture, we will see that how we use AMI no reboot option. So when you are creating an AMI using an instance, so in that you get a feature that is no reboot. Okay, that is an option which is by default it is disabled. It allows you to create an AMI without shutting down your instance. So whenever you create an AMI of your instance, your EC2 instance is basically shut down at that time, and then it reboots actually. That AWS reboots your instance, and then your new AMI is created. Your snapshot is taken. By default, it is not selected. It is by default disabled. AWS will shut down the instance before creating an AMI to maintain the file system integrity, and that is why it is by default disabled. With no report disabled, suppose which is by default process. So see here in the left side, this is the picture. EC2 instance is running with your attached EBS volume. Now, when you will be like no reboot is disabled, which is by default option, which is a default option actually. So your instance will be shut down, and then your instance will be stopped, and then the attached EBS volume, the snapshot of this volume will be taken, and that EBS snapshot will be creating an image and will be used to create an image of AMI. Okay, and through that your AMI will be created. But when you have your no root enabled, then your EC2 instance, running EC2 instance, will not be shut down. It will just take the snapshot. EBS snapshot will be taken from your running instance only, and then AMI will be created. See, you can do this at your own guarantee. And here is a short note which says that OS buffers are not flushed to disk before the snapshot is created, because as you know, the if your instance is not being here shut down, so your OS buffers are not flushed actually. You can do this at your own risk. Why I'm saying so? So let us see this. Because AWS backup doesn't reboot the instances while taking EBS snapshots. No reboot behavior. It doesn't have any reboot behavior. It doesn't reboot the instance while taking EBS snapshots. This won't help you create an AMI that guarantees file system integrity, since you need to reboot the instance. As I said, that yes, you need to reboot the instance. To keep integrity, you have to provide the reboot parameters at the time of taking example. For example, take uh, suppose you have an event bridge which is scheduled, and that will invoke your Lambda after 1 week, or whatever day you schedule, and in that it will take an API image, and then with reboot, and then your AMI will be created. So this is your picture that invokes event bridge. Actually, it invokes a Lambda function, and then it has its own code of reboot. Okay, it has its own code of create AMI using reboot, and then Amazon EC2 is here created, and then your AMI will be generated. If you are enabling that no reboot behavior, then your AWS backup will work like this: EC2 and then create AMI, no reboot. So this is your core process. So I hope this is clear to you. Okay, so let us see where is that no reboot behavior present. Okay, so suppose you have your instance, running instance here. Just right click here and then go to this image and templates. You will see the create image option, and it is just like before as I was creating AMIs in the previous videos. Okay, so here in this create image option, you will get no reboot option, which is by default disabled. You can enable it here, and you can work on it at your own risk. So I hope this was clear to you. That's it for this lecture. Let's meet in the next lecture. Thank you. Hello friends, so in this lecture we will see that how we can share our AMIs across the regions, and we will see how we can share EC2 instance migration between AZs, different AZs. So suppose this is the picture how we can share our EC2 instance migration, how we can do that. So suppose this is our EC2 instance and we have created an AMI, then we can launch the another instance from that AMI in different region. We can change the subnet of that AMI. Okay. Next is cross account AMI sharing. What is this? You can share an AMI with another AWS account, that is allowed to you. Sharing an AMI does not affect your ownership of the AMI. It doesn't affect that AMI will be yours only. You will be just sharing it to another target account. You can only share AMIs that have unencrypted volumes. If that is encrypted, then what you have to do, you have to suppose you have to give him that decryption key also. Okay. Next is, if you share an AMI with encrypted volumes, you must also share any customer managed keys to use to encrypt them, so that that target, that person who is accessing your AMI, he or she can decrypt that. Okay. Next, this is the picture that how you can share account from account A to account B, and that's it. Next is AMI sharing with KMS encryption. So how actually this is the, so this is the picture depicting how this is done. Suppose source is sharing an AMI to target. So here, if it is in US East 1 and other target is also in US East 1, that is not necessary. Actually, you can change that region. No worries. Now what? Suppose you have a custom AMI, you have created an AMI and then you are sharing it. That is encrypted with your CMK8. Then what? You will be sharing CMK82 to the target, so that they can decrypt that. You will be sharing all the things. And then they will decrypt it and then they will use it. Okay. Cross account AMI copy. If you copy an AMI that has been shared with your account, you are the owner of the target AMI in your account. What is this now? So suppose if someone is just sharing his or her AMI to me, and now what I am doing, I am just copying that AMI. I'm just making a copy of that AMI. So now I'll be the owner of this copy, not the actual shared AMI. But I will be the owner of this copied AMI. Okay, just visualize it and we'll see it in a moment. The owner of the source AMI must grant you read permissions for the storage that backs the AMI. So if you will have the read permission, then only you can copy that and then only you can decrypt that actually. If the shared AMI has encrypted snapshots, the owner must share the keys with you as well. You can encrypt the AMI with your CMK while copying. Okay. Suppose this is the thing, and let us see. If source has shared an AMI with you, custom AMI with you, he has also shared CMKA to you. Okay, then what are you doing? You are decrypting that using CMKA and then encrypting it using CMKB. And this is your copy actually. Okay, this target is your copy actually. You have copied that AMI and now you will be encrypting it using your own CMK. So this is what one can do. One can copy the instance or AMI using copy. Okay, so this was copy with AMS encryption. Let's see the hands-on now. It is a short and simple hands-on actually. So let us see that I have created an instance here. It is running, and here in images part, I have also created I have also created image of that instance. So what I can do, I can just select it and in the permission setting, I can go and edit AMI's permission. Okay. Other thing, what I can do, I can just right click it onto this AMI and then I can edit AMI permissions. In this AMI permissions, suppose if you have your unencrypted AMI, then what you can do, you can share it publicly. Like you can share it to the whole AWS marketplace and then anyone can use it. So be just be aware of that. Now next what you can also share privately to a specific AWS account into an individual or to an organization or OU. Okay. So while sharing someone like you want to share an individual, what you have to do, you have to enter here in shared accounts, you have to enter his or her account ID and then it will be shared to him. For that, basically, you will have to click this one also, this create volume permission, so that he or she can might access your AMIs perfectly. And here in shared organization also, if you want to share your AMI with the whole organization, then what you can do, you can add organization info from here, and then you can save these changes. Your AMI, your customized AMI will directly be shared to that organization OU or to that individual. So that's it for this lecture. I hope this was much okay to you and this was much clear to you. Let's meet in our next lecture. Thank you. Hello everyone. So in this lecture, we are going to see EC2 Image Builder, which is a new topic which has been introduced in recent years. And this service is included now in the AWS, and this can be asked in exam of SysOps Administrator course. And if you are pursuing this course, then this topic is very important to you. So let us see why this is used actually EC2 Image Builder. So this is used to automate the creation of virtual machines or container images in our like AWS. Okay, and whenever you are just automating the creation of VMs or the images AMIs, you can say. So all of those that basically to automate these things, the creations and maintenance. Also to automate the creation, maintenance, validation, and testing of EC2 AMIs. So if we are making an EC2 instances inside or from the AMIs. So we have to automate the creation, maintenance, or validation and testing of those EC2 instances, right? It can be run on a schedule like weekly or whenever your packages are updated, etc. So you can run this instances or this image builder on a scheduled date, time, okay, and that will be run as per your need. Next is it is free of cost. It is free service, but only the resources, underlying resources are paid. you have to pay for the resources that you are using. Suppose you have created an AMI, so you have distributed it. So basically, if you have distributed it, it will take some storage. That AMI will take some storage actually in other region. So that storage will be charged to you by AWS, and that is much justified actually. So let us see this with an example with a picture. So this is the picture how it happens. Whenever you just start EC2 image builder, so what it do? So it just creates a builder EC2 instance, and in that you actually configure, you actually just customize software on instance. Suppose you are writing all those customization that you want in your instance. So build components are applied by you only, whatever requirements you want from your EC2 instance. Okay, and suppose sometimes it can be like applications installed also. Next is basically it will automatically create a new AMI for you, and then uh, this new AMI will be tested. You want to validate this new AMI if you have created a new AMI, and then testing is done. Basically, it will create a new test EC2 instance, and in that test suite is run actually, and then those test cases you can run. You will set those test cases like, is the AMI working? Is it secure for you? Is it available? So all those things will be applied by you only. You will be applying all those test cases, right? And if you want to skip the test, you can skip that. But we should validate all those things. And then when the validation is done, AMI is distributed because it is a regional service. So AMI is distributed to a multiple region across multiple regions. And if you have distributed that AMIs, actually that will be charged by AWS because the storage of that AMIs in different regions, those AMIs in different regions will be charged. Also, if suppose you have initiated your EC2 image builder and it automatically creates EC2 instance, so actually those instance will also be charged because they are automated service and they will take some space and they will be assigned some public IPs and you will be working in it. So those resources will be charged actually. So that's it for this lecture. In the next lecture, we will see the hands-on of this topic. Okay, so let's meet in our next topic. Thank you.
So in this video we will see that how we can create an image pipeline. Okay, so let us start. For this is our EC2 image builder. You have to search it from services, and there your EC2 image builder will be there. Okay, and then what you have to do, this is the process. Basically you have to create a recipe, and then you have to define infrastructure configuration, which is optional, and then you have to define distribution settings, which is also optional. What you have to do now, you just have to create image pipeline. Just click here and then enter the pipeline name. Suppose I am just entering my demo pipeline. Okay, this is my name. You can enter any description if you want. I just don't want to enter anything. Build schedule, you can also click any one from this. You can choose anyone, which is schedule builder. It will automatically run the pipeline using a job schedule method. Like the default schedule is every Monday at 9 o'clock. Okay, at every week this will be running. This is your cron expression. You can also automatically run the pipeline using a syntax that defines its time or interval, whatever you want, or you can do it manually too. So I'll just choose manually for manual option for this practical for this lecture, because we are doing this manually for this hands-on. Okay, next is tags. If you want, you can add any of the tags. It is optional, so I don't want to add any tag right now. Just next, and then you can choose your recipe, whatever recipe you want. Either you want to choose existing recipe, so we haven't made any recipes yet. So what I'll do, I'll just create new recipes. And yes, in image type I have to choose AMI. I have two options to choose. One is Docker and second is AMI. Okay, so for this, as we are doing Amazon things, so I'll just choose AMI for this hands-on. Next is my recipe name. Okay, so whatever recipe name you want, you can give like EC2 image AMI. I just wrote here, and you have to select your version. So for version I'll be choosing 1.0.0. Description is optional. Base image, you have to choose what your base image is, like select managed images or AWS market replace images. So I'll just go with the default settings here. Now what do you have to do? You have to like skip all these things, and in this build components you have to select some things. Like in this build component you can create a new build component for yourself, or you can choose the options, given options from here. Okay, and before that I'll be choosing like custom AMIs. Like from this in image name I'll be choosing some AMI which is like Amazon Linux 2. You have to select Amazon Linux 2. Okay, just choose this one, not kernel, only Amazon Linux 2 x86, which OS is Linux and owner is Amazon. Just select this one and then go to your build components and select components by name, like Amazon Corretto. If you want to download or install Java at your AMI, you can do so writing Amazon Corretto. So you will get this here, Amazon Corretto 11 headless. Do this, click this one to just install Java 11 to your AMI. So I'll be choosing this one, and then you can also choose other one which is AWS CLI version 2 Linux. You have to choose this one also to install Linux. Okay, this creates the symlink user bin AWS that points to the you can see the documentation, more documentation. What we can do, it just points to the installed application, whatever you have installed. I can also just place these things, like shift these things, that which one I want to install first. So I'll be installing AWS CLI version 2 in Linux first, and then Amazon Corretto 11 headless. Okay, let's move to the next part. Next is what we have to do. We have to just click next here, and in this next, now you can choose default workflows or custom workflows. If you are choosing custom workflows, then you can choose your text workflows, skip test workflows. I'll not be doing anything, but for this, if you want, you can choose custom or default. So let's go with the default workflow here. Okay, next is, now you can create infrastructure configuration using service default. So this is defining infrastructure configuration. This is optional, but we will be configuring it. So I'll be choosing third option, which is create a new infrastructure configuration, because if you are choosing this one, default one, your instance type will be selected by itself through AWS only, and that will be like that will be large AWS instance type, and that can affect your pricing, that can affect your budget. So for that, to prevent that, I'll be making a new infrastructure configuration, and for that I'll be choosing IAM role. I have to choose IAM role, and I have already created an IAM role, okay, which is EC2 instance profile for image builder. Whether I have to choose it or not, so let us check what type of IAM roles you need to configure while you are creating a new infrastructure. So just you can check it from here using defaults. Just click on this default, and then it will show you this instance role is configured using this one, EC2 instance profile for image builder, EC2 instance profile for image builder, ECR container builds, and this one. All these are permissions that is required to create your instance role. Okay, so in IAM role you have to select that these all three. Okay, you have to select all these three permissions to create your configuration, to create your IAM role. So while I am just doing it, just go here and then create new role. Okay, let us see. In roles, I'll be creating new role, create a role here. Okay, service is my EC2 service only. Yep, in these what I have to do, I have to create like, let us check it from here, EC2 instance profile for image builder. Just copy it from here and then paste it. You will get the thing like For image builder I have to select. Also ECR container builds, so this is my ECR container builds, this one I'll be selecting. Next is Amazon SSM managed instance core, copy and just paste here, you will get your policy name. Now just click next, and yep, my role is being created. I have to name something, so role for AMI image or EC2 image builder, just role for EC2 image builder. This is my name, I have named it. Okay, and now I'll be creating a role. Okay, so role for EC2 image builder, this is role, this is created right now. Okay, so I'll be selecting it from here in this create a new infrastructure configuration. I'll be naming it demo AMI. Okay, and then I'll choose one image which is role for EC2 image builder. Then instance type, here to be in free tier eligible, I'll be choosing instance type as t2.micro. For this hands-on I need this one. Okay, other things I'll be doing it by default only, these are all optional, so I'll just press next. Next is you can create distribution settings using service defaults, or you can distribute your AMI to some places also, like here general, you can also select regions. This is region 1, which is AP Southeast 2, which is current region. You can also add regions like region 2, you can add regions like region 3. Okay, so you can select regions. I'll just be removing it because I just want single region, so I'll be removing it because I just want a single region, which is create distribution settings using service defaults, because this is my current region and I want to be this like AMI or image to be distributed in this region only. Okay, and then I'll be pressing next. All things are good as per my selection. Okay, and I'll be just creating pipeline. So I have clicked create pipeline and my pipeline will be created. See, everything is done here, my pipeline is created, it is successfully created. Now what I have to do, I have to select this demo pipeline, and for actions I have to run this pipeline. And yep, this pipeline execution is in process now. Okay, view details, now I can view this detail, and here is my pipeline. Okay, let's just wait. Recipe is here. See, these are components that I had added. Now what I have to do, I have to go to this image, and yep, EC2 image AMI, this one is here that I have created right now. I will be clicking it, and here is my image which is building. Okay, the status is building. This might take half an hour or more to be done, to be built. Okay, but for now this will be done, and this is how we can create our EC2 image. And the work we had done, like I have just created an instance, as so an instance would have been created using this AMI, because I have just made and I have built and tested all the things into this AMI. So I can go to EC2 dashboard and check. You can see that this build instance is running. Okay, and this build instance is basically building all the things, my images. This is in building state, and when it will be built, when all the processes will be done, a test instance will be initiated, and then this will be terminated by default, and a test instance will be initiated, and then after that, as I don't want to test anything, so it will also be terminated then, and my work will be done. Okay, so if you want to distribute, you can also distribute this AMI using this AMIs and distribution, as we have done in our previous videos. So you can done so all those things also. So that's it for this lecture. Let's meet in our next lecture. Thank you. So in this lecture we will see AMI in production. So what is this? So we can make user to select only EC2 instances from pre-approved AMIs. The AMIs which are tagged with specific tags using IAM policies. Using IAM policies, you can restrict the user, or you can make the user, force the user to work with your tags only. Okay, and it also combines with AWS configuration to find non-compliant EC2 instances. Instances launched with non-approved AMIs will not be connected. So let us see it through a picture. Suppose this is your condition tagged. This is IAM role permission that is given to a user, and then this launch permission will be only applied to the AMI approved one, not to AMI not approved. Okay, and AMI approved tag will be just configured, and that will be combined. Here it is that AWS config just monitors that which of the EC2 instances which is made by AMI, approved AMI. So suppose an AMI is there which is not approved, then it launches an EC2 instance. So it is not compliant or non-compliant. So AWS configure monitors it, and it doesn't connect you to that EC2 instance, but that is the tag, or sorry, the AMI approved tag, you can say, uh, will launch an EC2 instance, and that will be monitored by AWS config, and if it is compliant, then EC2 instance will be connected. So this is how your AMI in production works, and this is how we can just work on a combine AMI approved or non-approved, and you can just make sure or make user to select only EC2 instances from pre-approved AMI. So I hope this lecture was good to you. So we will meet in the next section. Till then, thank you.
Hello, so in this lecture we will see AWS Systems Manager overview. So first of all, System Manager overview is an important topic which is going to come up in exams. It helps you to manage your EC2 fleet of EC2 instances and on-premises systems at scale. System Manager has a lot of tools to provide you insights about the state of your infrastructure. Also, it can easily detect problems, and it has patching automation for enhanced compliances or any kind of automation. If you want to do, you can do it with System Manager. It works for both Windows and Linux OS. It is integrated with CloudWatch metrics and dashboards so that you can see your CPU runtime, CPU credit usage, or whatever metrics if you want to see, you can see that. It is integrated with AWS config also. It is a free service. You are not going to pay anything, but you are only going to pay for the resources that you are using for this system manager. Next is system manager features. So here are some features I'm mentioning, like resource groups, operation management, explorer, Ops Center, CloudWatch Dashboard, PhD, incident managers, and shared resources inside that documents, change management, inside that change manager, automation, change calendar, maintenance windows, application management, application manager, app config, parameter store, node manager, fleet manager, compliance, inventory, hybrid activation, session manager, run command, state manager, patch manager, distributor. Okay, but you don't have to know all these things. Just the things with orange lines or orange marks you have to know. And I'll be just going with these only, like resource group and documents, automation, maintenance window, parameter store, inventory, session manager, and command, state manager, patch manager in this session, in these upcoming sessions only. Okay, so let's move to the next thing, how AWS System Manager works. So we have to install the SSM agent onto the systems we have. Then we should know that it is already installed on Amazon Linux 2 AMI and some Ubuntu AMI. If an instance can't be controlled with the SSM, there might be an issue with the SSM agent. And also, you have to make sure that the EC2 instances have a proper IAM role to allow SSM actions. And let us know this through a picture. This is AWS System Manager. And suppose SSM agent is here, one SSM agent, second is here, and third SSM agent is here. So we have all these EC2 instances and on-premises server. If we have given correct IAM permissions, then only it will be accessible to AWS System Manager. So I hope now it is much clear to you what a system manager uh, does. This is the proper overview of a system manager, and in upcoming courses, in upcoming sessions, I say we will be continuing with this topics. So thank you, and let's meet in the next lecture. Thank you. In this lecture, we will start with the systems manager, and in systems manager, we need to first register into instances. Okay, so we need to register some instances here. So on the left hand side, you can see node management here, and in node management, the first one is fleet manager. Let's open it now. So here in fleet manager, what we have to do, we have to register some instances. You can see there is nothing now, but we can add instances here in a second. So let us go and add some instances. So for that, you will have to go to EC2 dashboard and make some instances. So let's go and do that first. So here is my instances EC2 dashboard, and let's launch one instance from here. So what we will do, we have to manage some instances. Okay, so we will not make a single instance, we will make two or three instances. So by default, we will make three instances, suppose, and then what we have to do, we'll see. Name, I'll just name it my SSM. Okay, or let's not name anything. We will select quick start, so it is Amazon Linux only. AMI, you can choose anything. Suppose it is Amazon Linux 2023 AMI, you can also choose Amazon Linux 2 AMI. So let us choose Amazon Linux 2 AMI. Next is instance type. I'll surely go with T2 micro. Key pair not required. If you want, you can have. So I will just create a new pair, or I'll choose one. So I'll just create one new key pair. So for that, what you have to do, you have to create one from here. You have to click whether you want to create it or not. Next is you can also choose any of the key pairs. Suppose demo key which I have created. If you will see my previous video, you will get to know how we can create new key pairs. Okay. And next is a network settings. In this network setting, what we have to do, we don't have to allow anything, any of the services, so that we can know that our instance is being managed with SSM. Our instances are using SSM, not any security group. So we'll create a security group without any of the services, without any of the rules to be ticked. Now in advanced detail, what we have to do, in IAM instance profile, we will be creating a new IAM profile. So here are the rules. We will create one role for this. It is an AWS service. Use case will be our EC2 only. Then we have to enter policies. So there is one policy which is Amazon SSM Managed Instance Core, which is Amazon SSM Managed Instance Core. Just search. Let us search it. Yeah, it is here. So this policy has everything which will just enable you to connect to your SSM. All right. So we will select this one, and then I'll just do next. Let's name this role. So I'll name it Amazon EC2 role for SSM. Amazon EC2 role for SSM. Yeah. So this is our permission policy, Amazon SSM Managed Instance Core. And yep, I'll create one role for this. So my role is created here. What I'll do, I'll just select this role from IAM instance profile. So here it is Amazon EC2 role for SSM. We have permissions, required permissions for it, and then nothing next. Number of instances, I'll just keep it 3, right? Now launch instance. So here you can see our instances has been launched, and when I'll go here, I'll just wait until their state is running. Okay, now right now it is pending, but we will wait until it's running. So let's wait. Yep, they all are, two are running, third one is pending. No worries, let's wait for other one too. Okay, all instances are running here. Now what? Now we will go to SSM and manage nodes. Wait. Yeah, here it is the fleet manager. Let's refresh it. And you will see that all three instances are running here. Ping state is online operation here. You can also see uh, agent version is also there. So our fleet manager, in this fleet manager, all the instances are running and they are using SSM services only. So that's it. That is how you can just check whether or you can create or you can register instances in your systems manager. So that is all for this lecture. Let's meet in our next lecture. So in this lecture, we will see AWS tags and what we can do with tags. Let's see in this lecture. First, you can add text key value pairs called tags to many AWS resources, not just EC2, but it is commonly used in EC2. You can use it on Lambda as well or S3 and other services. You have renaming convention in this, and common tags are basically named as name, environment, teams, etc., etc. They are used for resource grouping, automation, and cost allocation. And the thumb rule is that it is better to have too many tags than too less. Okay, and using these, we can make resource groups. Okay, we can leverage resource groups. So in this, while making resource group, you have to create, view, or manage logical group of resources. And very thanks to tags that we are having these types of feature. Next is it allows creation of logical groups such as applications, different layers of an application stack, and production versus development environments. This is a regional service, and you can use it in any region, and it works well with EC2, S3, DynamoDB, Lambda, etc. So here how we can do it. I have three EC2 instances in this lecture when we will see. So the key value pair is here. Key is environment, value is dev. Key is environment, value is the dev. So basically, the resource group with same environment will be grouped together to make applications better to use. So this is it. Let's see the hands-on now. Okay, so we have three instances running right now. Just look here. Yep. So in each of these instances, I'll be adding or managing tags. So for our first instance, let's go here in tags and manage tags, add tags. And tags are basically key value pairs. So I'll manage tags and I'll just give them a name. Name is inst1. So I'll just name it like my prod instance. My prod instance. Okay. And then I'll add new tag. And you can say we can just remove it and add new tag. Key is will be our name. So first name is use name, enter value. Value will be my prod instance. Okay. Next, add new tag. Our key will be now environment. Yep, environment. And in this, we will enter a value which is prod basically. Yep. And we'll now again add new tag which is team, and team will be our finance team, right? So let's group it in finance team, and then we will save this first instance tag. So we have added tag to the first instance. Let's do the same in second instance. So let us name this instance tag. Okay, so we will name it manage tags. We'll name it as my dev instance. Next is the same environment. So environment of this tag will be same dev. Last one was prod, and this is dev. Key will be team, and then here it is in finance only. Okay, so in finance team we have two tags, prod instance and dev instance, right? I'll save it. Okay, so two tags have been added. Similarly, I'll be doing this in the third instance, and I'll be creating or managing tags. Tag is basically a key value pair that I already told you. So in this third instance, I'll be naming it as my other dev instance. In dev instance, right? We'll be adding another tag, which is environment, and environment will be same as dev. Yeah, it's environment is dev. Next, we'll add another tag, team, which will be operations. This is in another team, which is operations basically, and I'll just save it. So we have added tags to all the three instances. Now what we have to do, we have to go to resource group from this search bar. So here I'll be having a resource group option. Okay, yep, here it is. We'll just open it into a new tab. We'll create a resource group here. It is a tag-based resource group, and in the grouping criteria, resource type will be EC2 instance, right? So let's find that EC2 instance here. Tag key. So I'll be entering tag key as environment and optional tag value as dev, right? And I'll be just previewing group resources. And yep, I have two resources, two instances, which have the tag value as dev, right? So tag value is dev, environment, and service is EC2. So now what? I can just create this group, and I can name also, like I'll be naming this dev group. I can name it. Okay, dev group. Sorry. Yeah, let's create this group now. I can make another group. Okay, here is my group. I can make another group from there, and that group will be. Let's create another group. This group is basically same EC2 instance. Let's find it. Yep, it is here. Tag key will be team now, and in this team we will be having finance as our option. Okay, and if you will review your group resources, you will find that yep, you have as tag is equal to team, you have finance here, and here are two tags, and you can also create them, and you can check that, right? So let us create that group. Group name is equal to, as we have entered finance, right? So finance group, let's name it create group. Yep, it is here. Finance group is been successfully created. So we have created these two instances, like prod instance, dev instance, and another one I can also see, which was third, my other dev instance. While I'll be selecting environment is equal to dev, then I'll have that my other dev instance also. So this is how we can create group resources, and this is how we can check instances, and we can create resource groups. So this is basically a prerequisite for our next lectures that we will be working on. So I hope this was clear to you. Let's meet in our next lecture. Thank you. Hello everyone. So in this lecture, we will see SSM documents. So first of all, let us see that documents can be in YML or JSON format. This is a service in SSM documents that automates your instances, and you will see that how we can just download resources on in our instances. Okay. This is my second point, which is you will define parameters here. Parameters such as you will define all the things, and then you will have to define actions too. Also, many documents already exist in AWS, like this. Just see, just check. This is the YML file, example of YML file. So this is your schema version 2.2 description parameters. So you can define your parameters here, main steps, so actions that what actions you want to take for your instance, like AWS run shell script, what name you want to give, configure server inputs, run commands, and these are the commands that you want to run inside your instance to pre-install all the things. inside your instances like sudo yum install -y httpd or sudo yum dash enable repo equals to apple install -y clamf. Okay, so this is one thing. Next is SSM. Okay, let's see what this. So this is documents, and when we create a document, it just redirects us to a run command. And then in the second step, we have to just work on this or initiate this run command. And when we will initiate this run command, something this will happen. Let us see the next slide for that. This is our SSM run command. You have to execute a document or just run a command, and in this run command around multiple instances, if you want to run your command around multiple instances such as one, two, or a cluster of instances, you can do that. Error controls or rate controls option are given here, like after how many errors you want to stop your instance, or you want to stop your process uh, of these documents, whatever script is written in the document. Or you will have another option called as rate controls. This checks that what is the rate, like 2 instance, 3 instance, 100 instance, what is the rate of the instance that is going into this process. And it is very like nicely created, or you can say nicely integrated with IAM and Cloud Trails. No need for SSH, and command output can be shown in the console or sent to S3 bucket or CloudWatch logs, and it can be implored using Event Bridge. Let's see this with a picture. Here is the picture. Suppose you initiate a run command, then you will see the output in Amazon S3 or CloudWatch logs. You can see your output anywhere. Then you can notify it to Amazon SNS, which is a notification service. And then this, like, it is also integrated with Event Bridge. Okay, so it can be implored or triggered using Event Bridge. Okay, and suppose these are all your instances, so this run command will work simultaneously in all these instances. So this is it in this theory part. Let us see hands-on. I'll just show you how we can create a document. In our previous video, I have already told you about the creation of SSM parameters, and in that SSM parameters, we had created some resources like prod or all the things. We will see that right now. Okay, and this hands-on, suppose this is my AWS System Manager, and in this Systems Manager, in the very left-hand side, you will see one option which is documents. This is my option, which is documents. You just have to click on that, and then when you will click on this documents, a page will appear, and here it will ask you create document. Also, here are some documents which are already present. As I told you, there are some documents which are already created by your AWS. Okay, and if suppose I am selecting one, this AWS apply patch baseline, then let me show you the description. This is your description, and you will get to know in the upcoming lectures what is this apply patch baseline. So scans or installs patches from a patch baseline. Platform will be Windows. Here it was created in 8 July 2021. This document was created then only. Its status is active. Owner is Amazon. You can see content from here. Okay, let it just load. Yep, this is our content. You can see what is written in this document. Okay, and version of this document. So if you don't own this document, because AWS own this document, so it just hides that versions facility. And this is my details here. Parameter is given, document version is one, default operation string, description is given here. So all these things are given, and this is how you can check a document. And when you will press this run command, it will connect you to that run command option that is present. Okay, so let us create our own document. It will be command or session only. name install Apache. Target type will be our say EC2 instance only. Okay, AWS EC2 instance. Here it is. Document type is command document only, nothing to change. Here are two options, JSON or YML. See, JSON is like this, and I'll choose YML because it is easy to read and you can see that what I will be doing. And for this document, I have some written YML commands that I need to do. Basically, in this document, I'll be putting commands to install yum update, install HTTPD service, okay, to connect to your instance with your browser, okay. So this is the command which I am writing, and yep, it will already create one message, hello world, or whatever message you want to write here, and this in this .html file it will be stored. Okay, this is the thing. But I have not created instance, so I'll not be showing that much. I'll be just telling you how we can create this document, right? So let's create this document now. And as you can see, this document was successfully created. Let us view the details from here. And yep, this is the detail, and you can run command from here, or if you want, you can also go to AWS Systems Manager, and in that, in the left hand side, you will see one option, run command, and from that, you can choose your owned document, and then you can press this run command. And now we will have to set up this run command also. So, okay, as we have just selected our install Apache, this document that I have created, document version is default one. Message, you can write any message that you want to display on your browser or on your screen whenever you are creating your instance. This is your target selection. Specify instance tags, choose instances manually or choose a resource group. I had already explained you that how we can create a resource group. So if you have created a resource group, you can choose it from here. So I have two resource groups, dev group or finance group. I don't have any instances there, but yeah, this is my option for the resources. You can select any of these and you can write comment or any parameters if you want to give. This is your timeout, which time, what time you want to give. This is your rate control, and you can just control like how many instances you want to give or how many instances you want to trigger from here. And this is error. So if you want, whenever you are installing anything in your instance, we generally get to see that there are approximately 5 or 6 errors. But right now I don't want any errors. So I'll just put up 0 here and then I'll move forward. If I want any CloudWatch alarm, I'll choose it from here. Output options. So I want to choose S3 bucket from here, right? So if you have created one S3 bucket, you can list that here and you will get to see your output there. And then you just have to press run and yeah, your document will be initiated and that will be applied on all the instances. So that's it for this lecture. Let's meet in our next lecture. Thank you. Hello, so in this lecture, we will see SSM automation and we will see the steps of SSM automation and the features of it in this lecture. It eases common maintenance and deployment tasks of EC2 instances and other AWS resources. For example, it restarts your instances, it automates the creation of an AMI and EBS snapshot. It automates runbooks or you can say documents. SSM documents of type automation defines actions performed on your instances or AWS resources, predefined runbooks in AWS or create custom runbooks. It can be triggered through manually using AWS console, CLI, or SDK. It can be controlled or triggered by Amazon Event Bridge or on a schedule using maintenance windows or by AWS configuration for rules remediations. Here is the picture of its automation. So maintenance windows, SDK, console, event bridge, or config remediation. These all are 5 steps through which it can be triggered. Okay, and this is your SSM automation feature. It automates the documents and executes on EC2 instances or AWS resources such as EBS, AMI, or RDS. That's it for theory part. Let's see the hands-on now. Here I have one instance which is stopped. I have this instance ID here. I'll just copy this instance ID for the automation. So see, I have copied this. Now in SSM, just search SSM in your search box, Systems Manager, and in this, in the left panel in change management, you will see automation option. Just click on that and then wait until it opens. So, one is in process in progress, one execution is in progress. I'll try to end up this execution so that I can do another one. So, let's just cancel this execution. Yep, it is successfully cancelled. See, to start an automation, what you have to do, you just have to click on this execute automation, and then here are run books or documents. Okay, and you can search any of these like AWS documentation, remediation, patching, security, instance management, data backup, AMI management, self-service support workflows, resource management, cost management, or any other run book you can choose. But for this uh, lecture, I'll be choosing AWS restart option to restart our instance. And basically, that restart consists of 2 steps, and that 2 step is to stop the instance and then to start the instance. Okay, so let's configure it now. Here it is execute automation, so just execute it. Click on that. Okay, we will go through rate control. You have 4 options. Simple execution, which executes directly on the target. Rate control, it executes safely on multiple targets by defining concurrency and error thresholds. Multiple account or region, execute in multiple accounts and regions. And manual execution, it is basically step-by-step runbook mode. And here you have to select rate control. For this lecture, I'm selecting target parameter. I will be selecting instance ID. You can select automation assume role also. So what are the targets? So I'll be choosing all the instances because I have only one. And yeah, then I have to choose I am a role. So if you want, you can choose I won't be choosing. I'll skip this step right now. Concurrency, you can choose any number of percentage of targets on which to execute the task at the same time. Error threshold basically stops the automation after a task fails on more than the specified number of targets. So here, one is the default setting, concurrency 1. So I'll be choosing that only. Let's execute this process now. You can check our instance state is stopped here, and as I'll just start executing this thing. So my execution has been initiated here. You can click on this link to see the steps, step execution ID. Let's click on this. And yep, as my instance was already stopped, so first step is already success, status is success. And second step is in progress, which is start instances. And you can see when I refresh it, it is in either pending state or running state. So yep, it is in running state. So my execution has been done perfectly. So this is it for today's lecture. Let's meet in our next lecture. Thank you. So in this lecture, we will see the overview of SSM parameter store, what it is used for. So it is an AWS service which is used for secure storage of your configurations and secrets key. Optional seamless encryption using KMS. It has some encryption using AWS KMS service, and it is serverless, scalable, durable, easy SDK, and it has a version tracking of configuration and secrets. It is secured through IAM rules or policies, you can say, and notifications with Amazon Event Bridge is there, and also it is integrated with CloudFormation. Suppose I'm taking one example. Here is your PC account, and your plain text configuration or encrypted configuration can be stored in SSM parameter store, and it will be checked by IAM permissions, and decryption or encryption services will be done through AWS KMS. Next is SSM parameter store hierarchy. So basically, all the stuffs are stored in a rank-wise basis. First is slash my department, and inside it there is subpart my app. Then inside that there is dev, and inside that there is DB URL or DB password. Basically, these are uh, your passwords or URL link that you are storing in your parameter store. Next is prod, and it has DB URL and DB password too. Then after my app, there is other apps which is like to be stored in parameter store. Next is other department. Apart from your department, there is other department option, and there is another AWS reference secrets manager, secret ID in secrets manager, and AWS services like AMI, Amazon Linux. So basically, these AMI configuration would be stored in the last part. Okay. So if you are having any AMIs, public AMI, that will be stored, that data will be stored in the last part, okay, in parameter store. So dev lambda function is basically associated with dev DB URL, DB password, and prod lambda function is basically associated with DB URL or DB password. Next is we have two tiers, which is standard and advanced parameter tiers. With in standard, total number of parameters allowed is 10,000. In advance, total number of parameters per AWS account and region is 100,000. Maximum size of a parameter value is in standard, it is 4 KB. In advanced, it is 8 KB. Parameter policies available. So we don't have any parameter policies available in standard tier, but we have in advanced tier. Cost, so there is no additional charge in standard tier, and charges are applied in advanced tier, and that is but obvious. Storage pricing, so standard is free and advanced is about $0.05 per advanced parameter per month. Next is parameter policies. So for advanced parameter policies, basically it allows you to force user to update or delete sensitive data such as passwords. It assigns a TTL, which is time to live, to a parameter, which is an expiration date actually, to force updation or deletion. Next is it can assign multiple policies at a time. And here is a example. Suppose first is expiration to delete a parameter. Second is expiration notification uh, through Event Bridge, and last is no change notification through Event Bridge. So in this, to delete a parameter, one code is there. It has some attributes. It has some timestamp. So it will just tell you that when this parameter which you are storing, like password or any secret key, will be deleted. Expiration notification will notify you before 15 days. Here you can just enter your number of days, that how many, after how many days you want that notification. So that will be notified to you through Event Bridge. And no change notification. Suppose if you are not updating anything in your password or in your parameter policy, then you will get one notification, that is no change notification actually, that you haven't changed anything. And this is one attribute, like after 20 days, you will be notified. So that's all for parameter store. We will see another things hands-on part in the next lecture. Till then, thank you.
AWS account, okay. And here I have made some of the things which might be easier for you. This is basically my Lambda function, which I'll be showing you later. Okay, let me show the first step. So in the first step, you have to open the system manager, okay, systems manager. In this systems manager, you have to go to this parameter store and then click on this parameter store, and then you will have some parameters. Okay, I have made some parameters. What you have to do, you have to create parameter. Okay, I have made these four parameters: my app dev db password, my app dev db url,
my app prod db password, my app prod db URL. I'll just give you a demo and then I'll show you how we can create a parameter. You have to click on this create parameter, and then what you have to do, you have to enter a name or path like slash my app, whatever it is, devdb URL. Okay, description you can give app URL for my app development, whatever you want. You can give a short description here. Okay, next is standard and then advanced. As I said, standard is free and advanced can create 10,000 parameters. Parameter value size up to 8 KB. That was basically charges applied here and no additional charges are shown here. Okay, and basically this is the 4 KB extension which is provided in advanced. Then if you are creating a URL, just a URL, you can choose the type string. And if you are using, suppose if you are making a password stuff, then your password must be secured, so you can choose secure string here and your value would be here. So suppose I am just making a simple URL stuff, so I will be giving this okay, let me give c3 dot s3 cloud, okay, .com colon 3067, whatever it is. Okay, I have given this value, and then you can create parameter from here. Okay, you can create your parameter from here. See this create parameter button, you can click it from here and your parameter would be created. Let me show you by creating that with another name. Suppose db, not db URL, not my app. I would be naming this s3 dash app. Okay, and then if I make the parameter, a parameter would be made. Okay, it must not end with a slash. So yep, my parameter is here. Now you can check s3 app dev db URL. This is my parameter, this is air, and this is name, and this is the value stored in it. Now what's the next thing we can do? The next thing we can do is we can create the same password by choosing secure string. See, here is your type secure string. You can do the same way. Like if you want to create a password, so s3 dev app db URL or slash. Okay, I want to give password here. Suppose I want to give password here. So what I'll be doing, I'll just give password. I'll write password for s3, and then I'll be choosing a secure string, and yep, I can keep the KMS key ID as the same. Now what I have to do, I have to give some value. Suppose I am giving s3 cloud.com colon 3306. Okay, I have given this. Now I'll create a parameter. My parameter would be created, and if I'll go and check my password s3 app, this is the stuff I'm checking here. This value is secured basically because I have used secure string here. So this password is secured here. I'll just check it, and yep, it is here. Okay, so now we will see some CLI things. As I have created these parameters, now you can check my parameters. Here are my parameters, like this is my parameter. Okay, and let us look at the parameter store for all the parameters that I have created right now. Okay, I'll check for these. Okay, my app dev db password, my app dev db URL, prod db password, prod db URL. I'll be checking for these. Okay, so let us check for these all things. On CLI, I'll be writing this stuff like suppose I am writing AWS space SSM space get dash parameters, and then what you have to do, you have to give double slash and then names, then slash, and whatever the name of my like this was the name, devdb password. I'll just control C and control V here. I'll paste it here. Then I can also search for my DB URL. Then giving a space, I'll just control V. I'll paste it here. And DB password, instead of giving DB password, I'll be giving DB URL here. And yep, what you can see, if I am doing this, okay, I have entered AWS SSM get parameters dash dash names space slash my dash app slash dev db, whatever the name of my parameter was. I have entered it, and then if I'll be clicking, wait a minute, okay, just let me handle this. Yeah, here it is. If I press enter, I'll get the information about these two. So I have pressed enter here, and yeah, here is the answers. I got the parameters, like first one is name, my app dev db password, its value is secured here, you can see. And the other one is, as I have written, other one is my db url, and yep, its information is here. So this is how I can do. Suppose I want with decryption, so what I can do, okay, so as I used with decryption, okay, what is the thing, basically, when I am entering this my app slash my app db deb, after this with decryption, I'm not getting the value. You can either write this my app db password with decryption, or you can do one thing to show this error you might get. Suppose I will be entering this whole thing, copied, okay, I'll be entering this whole thing here. Like if I want to check URL parameters too, I'll be just pasting it here, and let me give it some space, and then let's change this password to URL. So I'll get the parameter of that URL which I had created now. Okay, so here is the parameter and command, whatever it was, I got it. Okay, here it is URL, and here it is password, and password is secured here, uh, and now it's decrypted too, because I used this with decryption, so I can say decrypted password too. Okay, so this was Cloud Shell part. This is how I can check my parameters, my created parameters on CLI, or you can say Cloud Shell. Okay,
So in this lecture, we will be looking at SSM inventory and its services. So SSM inventory basically collects metadata from your managed instances. It can be EC2 or your on-premises instances. Metadata includes installed software, configuration, OS drivers, installed updates, running services, and all other services. Metadata basically contains all the images of these updates or running services. View data in AWS console or store in S3 bucket and query and analyze using Athena and QuickSight. Next is it specifies metadata collection interval, like in minutes, hours, or in days. You can specify that in how many interval you want your metadata to be collected for the instance. Query data from multiple AWS accounts and regions, and it creates custom inventory for your custom metadata. For example, rack location of each managed instance would be created there. Next is SSM State Manager. It automates the process of keeping your managed instances in a state that you define. It automates that how and when you are going to keep that managed instance, and in which state you are gonna keep it. Use cases. Its use cases are, suppose you have bootstrap instances with software or patch OS software updates on a scheduled time or date or in hours. State Manager Association. It defines the state that you want to maintain to your managed instances. For example, port 22 must be closed or antivirus must be installed. So that will be that state you can maintain to your managed instances. It specifies a schedule when that configuration, suppose you want port 22 be closed. So you can specify a schedule when that configuration is to be applied. And also it uses SSM docs to create an association. For example, SSM documents to configure CW agent, CloudWatch agent. So that's all for theory part. Let's see the hands-on now. So in AWS SSM Manager, we have in the left-hand side inventory. Click on that, and then this will be open. Here is your dashboard. I have one instance running. So here is your dashboard. Basically, manage instances with inventory includes instances in the current region and account. Currently, I don't have any data to display. Okay, so that is okay. Next is detailed view. In this detailed view, you can create resource data sync. So let us create one. For more information, we can see Amazon Athena pricing or Amazon Glue pricing. Okay, Athena is an interactive query service that makes it easy to analyze. And suppose I'm just naming it as demo sync. Okay, sync name is demo sync. I have my bucket, uh, and I will be showing that what I have included in this bucket. Suppose if you are just introducing yourself with the buckets. So let me introduce you. You have to open that bucket, and in this permission you will make one bucket, or just click on create a bucket, and then on permission part, go to the permission part and edit the bucket policy. Because if you create a bucket, suppose let me show you one thing. This is my bucket. To create a new bucket, you will just click here to create a bucket. Okay, then some options will be visible to you. Then you will have to name the bucket, and this name should be same as the name entered here in the resource data sync in inventory. Okay, so just check that whether it is same or not. Then simply create that bucket, and after creating the bucket, you just have to go to the permissions. Let me show you. You have to go to the permissions, and for that you will have to click here, and here are the permissions. You can add the permission here. Basically this permission I got from here, Amazon S3 block public access. Okay, and from there I copied this public access versions and everything. What you will have to edit when you will be copying that code, or you may copy this code, you will have to change this one. In the resource, you will have to enter your bucket name. Okay, here it will be like example one or example two, so you will have to enter your own bucket name. You can remove all other resources. There will be multiple resources available, and then you can also edit this one. And in the source account, you will have to add your account ID, and this account ID you can get it from here. Okay, just copy it and paste it, and when you will save it, it will be created. That bucket will be created, and then what you have to do, you just have to create this resource data sync. So click here, and yeah, the resource data sync was successfully created. You can view details from here. Okay, so it is a success. Let's go to Systems Manager again. Yep, in inventory. Let's wait. In this detailed view, you have a one enabled. You can select the resource demo sync from here, and then your like whatever the applications are installed in your instances, all the applications will be shown here. If you choose inventory type, as suppose I am choosing AWS applications, so all the applications that are installed in your instances, you can watch them from here if you have installed any. But right now I don't have any applications installed in my instance, so nothing will be shown here. Okay, so that is how you can create in a resource data sync, and that is how you can work on inventory. So that's all for this session. Let's meet in our next lecture. Okay, so hello everyone. In this lecture we will see SSM Patch Manager. So basically, Patch Manager automates the processes of patching managed instance that are running with SSM parameters. It gives you OS updates, application updates, security updates, and it automates all these processes. It supports both EC2 instances and on-premises server. Also supports both Linux, macOS, Windows, patch on demand, or on a schedule using maintenance windows. And we can schedule it, suppose at in night time or anytime you want. Scan instances and generates patch compliance report. Every missing patches will be the report of every missing patches will be generated, and patch compliance report can be sent to S3 bucket, and there it will be stored. Next is it has two stuffs. You can say it has two types. One is patch baseline and other is patch groups. So in patch baseline, it defines which patches should and shouldn't be installed on your instances. Also, it has ability to create custom patch baselines, and you can select whether to specify approved or reject patches. Patches can be auto approved within days of their release. You can just like suppose if there is no one to update or approve them, so it can be auto approved within the days. By default, install only critical patches and patches related to security is there. And next is patch group. And in patch group, it associate a set of instances with a specified patch baseline. Also, for example, suppose create patch groups for different environment like dev, test, prod. You can create any of these, and it should be in tagged with key patch group. Okay, instances should be defined with the tag key patch group if there is any instances which is in patch group. An instance can only be in one patch group if it is running with the SSM parameters, and patch group can be registered with only one patch baseline. So here, predefined patch baselines like managed by AWS for different operating systems, and they can't be modified. Next is AWS Run Patch Baseline SSM document. Apply both operating system and application patches, Linux, macOS, Windows Server. And next, other is custom patch baseline. It creates your own patch baseline and choose which patches to auto approve and which patches to reject. Next is operating system allowed patches, rejected patches. Everything will be customized by this custom patch baseline. You can just select all these things in your baseline, patch baseline. Ability to specify custom and alternative patch repositories. And let's see with a picture. Suppose there are three instances, EC2 instances, which are running with SSM parameters, SSM agent, and they have tags like key is OS first instances. For first instance, key is OS, value is Windows, patch group is dev. Okay. For next instance, which is second instance, key is OS, value is Windows. For third instance, key is OS, value Windows, tag key is patch group, and value is prod. So what will happen? Suppose these are all instances, and in patch manager, there is in patch baseline, you will be specifying the patch baseline ID, patch group, default, and in patch baseline ID, first one is default and second one is dev. Okay, and it is not default actually, so it is said to be no. Here is your AWS manager, and in this AWS system, you have all the things just predefined like AWS console, AWS SDK, and maintenance windows. And in maintenance windows, you have set that timing to run that document. So we have already discussed this run command and document, and here you have enabled run command. So through this, it will be automated, and it will just generate a run command. Okay. And when this run command will work on these EC2 instances, these EC2 instances will take the input from this patch manager that which instance to be covered and which instance will be using what type of patches, and it will be approving what type of patches. Okay, when using maintenance windows, you have to use rate control to specify the maximum number or percentage of targets allowed to run in parallel. We have already seen that what is error control and rate control. So rate control basically specifies the number or percentage of targets, that means EC2 instances, which are allowed to run in parallel. It looks complicated, but actually it is very simple. And if you get into it, you will be finding it very much easy. Next is SSM maintenance windows. So it defines the schedule for when to take actions on your instances, whether in night or in daytime. It will just set a time actually. For example, for OS patching, updating drivers, installing software. So it will define a schedule that when it will be happening in mid-time, that is the perfect time to like define or schedule it to take actions on your instances, to update your instances. Maintenance windows contains schedule, duration, set of registered instances, set of registered tasks. So I hope this was much clear to you and how we use SSM patch baselines, patch groups, and SSM maintenance windows. So that's it for this lecture. Let's meet in our next lecture. Thank you. So in this lecture, we will see the patch managers and patch baseline. So let us see that service. In Systems Manager, you can see your patch manager, and in that we can create some patches to automate our instances. So here you can see in the left hand side in node management there is a patch manager. So just click on it. So this is your patch manager. Okay, what you can do, you can create a patch policy, or you can start with an overview. You can create patch policy. You can view dashboard or view compliance reports also. So let us see this. How can we create a patch policy here? Okay, so here is how you can create a patch manager actually. This is the dashboard, and this is where you can just place your Amazon EC2 instance management. Here are your patch baselines, and these patch baselines are actually made by like AWS. So these are some predefined patch baselines, which is made by AWS, and you can create your own patch baseline. And here are the patches you can see. Okay, here are the patches, and suppose if I go for run and I just enter it. Okay, sorry, you can search for Amazon Linux 2 here, and yeah, in this I can run patch baseline it was. So I can search it and I'll just get it in some pages. Suppose in 1, 2, 3, 4, there's plenty of pages, and I can get that run patch baseline in any of that pages, right? So here how you can create your patch, and you can select your patch and you can automate the service. So this is how you can do that. Next is your maintenance windows. Okay, this maintenance windows is actually used to automate the uh, patch manager, right? So the tasks that you are automating through patch manager, that will be scheduled and implemented across your fleet. So you can create a maintenance window from here. And suppose this is my maintenance window, I can name it like demo patch. I can name it, and I can specify or schedule it with cron schedule builder, rate schedule builder, cron rate expression. With cron schedule builder, I can like specify that when I want it to just automate the task. By default, it is uh, every 30 minutes. I can do it hourly or daily. So this is daily at every day at suppose uh, 3 a.m. I want that. Okay. So duration I won't be setting anything, and I can just create maintenance window. Okay. Here is the duration. So if you want maintenance window duration, so I can take of one value here. Yeah. And here I can take one or two, I guess. Yeah. So here is my value. I can take anything. And now what I'll be doing, I'll be creating a maintenance window from here. Okay. And cutoff is actually 1 hour only. So I must select this two. And yeah. Okay. Okay. Just let us create this. Okay, so that is how we can create one maintenance window. And I have just named it like I just, when I was creating it, you can see the detail. Here is the description. Duration is 14 hours. Cutoff point was 11 hours before window closes. So it must be like in between, less than that cutoff time, less must be less than the duration. Okay, and it should be between 1 to 23, right? So this is my next execution time. It will be executed on Sunday, March 24 at 1 a.m. UTC, right? So that is how I can make. And here, if I want to automate all these tasks in maintenance window, I can just register some tasks from here. And suppose this is my run command task, and from here I want to like demo I want to take. And yeah, one will be AWS run, and let's enter, and yeah, run patch baseline. I should select it. That would be better. AWS run patch, and yeah, here it is. I can also select this one. I can use this one, this document, which is run patch baseline, and I can set, thanks to this rate control, I can set the concurrency. So it can be one, suppose, and this error should be one. I have to put any values. If you are not putting, it will show you error. So you have to put any of the values here. And next, what I'll be doing is just registering run command. Okay. Oh, I haven't selected any target yet. So you can select any of the unregistered targets or any of the targets if you want. Right. So you can do it manually, or you can select any of the targets and you can create your run command task, and it will just be completed, right? So I'm not gonna run this because I have just told you, I just explained you that how we can work on this run command task, but I don't have any targets, I don't have any instances right now, so I cannot run this command task. So that is how you can work on maintenance window and patch manager. So I hope this was clear to you. Let's meet in our next video. Thank you.
Hello, welcome to S3 Cloud Hub. So let's see today's lecture. So today we are gonna see SSM or Session Manager, you can say. So this is a cool service that allows you to start a secure cell on your EC2 and on-premises servers. Access through AWS console and AWS CLI or Session Manager SDKs is given here. It does not need any SSH access, bastion host, or SSH keys, or it the most cool thing is that it supports Linux, macOS, and Windows. Log connections, it provides log connections to your EC2 instances and the executed commands. Okay. And session log data can be sent to S3 or CloudWatch logs. And also, CloudTrail can intercept start session events. Okay. Here is a picture showing how you can connect. So if you are a user and you have correct IAM permissions, then you can connect to a session manager. And just like run command that we were seeing in this SSM in documents, so just like that, this session manager also works, and it executes command at your EC2 instances, but your EC2 instances should have SSM agent in them. Okay, they should run using SSM agent. So only in that case you will be able to execute command through SS session managers. And yep, this is very different from run command, but it actually uses the same process or same method. So see the next slide. And in this slide, we will see IAM permissions. So what it does, so basically it controls which users or groups can access session manager and which instances they can access. Also, it uses tag to restrict access to only specific EC2 instances. Suppose you have 4 EC2 instances and you want only two instances to be run under this SSM session manager. So what you will do, you will just use tags and you will use resource group there, and you will name one resource group, suppose dev or prod, whatever. And if you will enter that
Yep, I only want the dev instances to run. So the instances that will be in the dev environment, they will be only executing through Session Manager. Okay, so I'll be showing an example of that. It access SSM plus write to CloudWatch. Optionally, you can restrict commands a user can run in a session. You can also restrict that which commands a user can run in a session. And this is the picture, this is the code. Suppose you have this version, it affected allow action SSM start session, resources this, and yep, SSM resource tagged slash environment, and dev is the environment. So all the instances that are falling in the dev category, dev environment, they will be only executed through Session Manager. This second point is just highlighting this. Okay. Next is SSH versus Session Manager. So SSH, connect using SSH. If you are connecting through SSH, then a user uh, likely uses IPv4 address one dot. Suppose this is the IPv4 address 1.2.3.4, and this is the source. So if there is the IP registered in inbound rules, then only you can access the user's IP. If it is there in inbound rules, then only a user can access that EC2 instances, right? But if you are connected using SSM Session Manager, then you don't need any IPs here. You just need correct IAM permissions, and you can access the EC2 instances through Session Manager. You would be first connected to a Session Manager. Session Manager will be connecting through EC2 instance that are running under SSM agent. Okay, and then your commands will be executed there simply. And also the logs of your connection or EC2 instances or commands will be stored in Amazon S3 or CloudWatch logs. So that is how this works. SSM Session Manager works. So this is actually a cool service, and I hope that now you can go through this SSM Session Manager, and let's meet in our next lecture for the hands-on stuff. And till then, thank you. Hello everyone. So in this lecture, we will see the Session Manager and how it works, how Session Manager actually works. We will see that. So basically, Manager through Session Manager, we can do all the work, all the installation, and we can write commands as we did in our SSH, like as we did previously, and as we do in our basics when we launch an instance and we connect it through this CLI, you can say, or you can just connect it through UI, and we just click here and we connect, like we connect our instance, and then we write all commands in that, and then we install. So all that things we can do through SSM, or you can say Session Manager also. Okay. In Systems Manager, there is a Service Session Manager. In the left hand side, in node management, there is Session Manager, and you can enable sessions and you can write that code. And I have already told the difference between Session Manager and that SSH, like activating EC2 instances or connecting EC2 instances through SSM or SSH. Both are different, and I have already explained that in my previous video. You can check that video. Okay. Now here is our instance, and I have created this instance using my SSM manager, right? I don't have any inbound rules for SSH in this instance, this instance, and this instance only contains SSM permissions. It is connected through SSM, and here I'll be just connecting it. So let me start one session for you. So what you have to do whenever you will open this now, let us see from the scratch. Whenever you will open this state manager, and I hope till now you must be knowing that how we can connect our EC2 instances through SSM manager. Okay. Mm, so if you don't know, just watch our previous video. I have already told you. And okay, this is my session state manager. No, no, not state. Let me open my session manager actually. Yeah, here is my session manager. Okay, so I'll be creating one session and then we will be using it. So here is my session manager. What I have to do, I just have to start one session. I don't have any sessions, so I have to start one session for the target instance, which is my instance. Okay, right? Now I have to start one session, and yeah, my session is there. The basic command that we use to write in Linux is echo and hello world. And this shows that our connection is secure. We have connected correctly, and yep, command is being executed successfully. Now, ls will show the list of the installed stuffs in my, you can say, install services in my instances, right? So there is an instance mines, and in that mines, everything is installed here. Now what? Now I'll be checking one service that I had already installed previously while I was doing in my previous videos when we were uh, exploring that resource group stuff. Okay, so we have installed that, and let us see that how we can install that in our instance. So before that, I'll be clearing this page, clear, and now you can connect yourself through root using sudo su, and you are connected to root. Okay, now you are a root user in this instance, and you can install anything. So the basic thing, HTTPD service. What is that service? I hope you know. HTTPD service basically connects you through your browser, connects your instance through your browser. Okay, now sudo yum -y install httpd, and yeah, it is already installed, so that is why it won't be installed again. It is already installed, and it has its latest version in it. But if you haven't installed it, it will be installed, correct? And you can check that it works perfectly. So let us terminate this session now, and we will see the next things. Next thing is session history. So you can check your session history. This is my latest session history. This is the history that is stored here. Okay. And for the same instance, I have created sessions 3 times, and that is why it is showing me 3 times. Okay. I have worked it on this instance previously, and this is my current instance that I have terminated, the correct current session that I terminated. And these are the preferences. So general preferences is idle session timeout. If you are not doing anything in your session, if it is idle, then that session will be timed out in 20 minutes. Okay. KMS encryption is disabled here. CloudWatch logging is disabled. You can enable it through here. And S3 logging is also disabled. So you can edit these preferences, and you can edit this idle session timeout. You can increase it not more than 60 minutes. And CloudWatch logging, you can enable it. And in S3 logging, you can also enable it. So all the like commands that you are exploring, that you are running, all that log will be stored in S3 logging or CloudWatch logging. So I hope this was clear to you. So let's meet in our next video, next session. That's it for today. Until then, thank you. So hello everyone. In this lecture, we will see scalability and high availability. This is a basic lecture which you can skip if you want, but let me tell you, you should know about scalability and high availability. It is a very common topic, and let us see one by one. So scalability means that an application or system can handle greater loads by adapting. Okay, there are two types of scalability basically, and two types of scalability are vertical and horizontal. Okay, horizontal scalability is also called elasticity, and scalability is linked but different to high availability. Okay, let's dive into distinction using a call center as an example. So suppose there's a call center. Okay, so how vertical scalability works on it. So vertical scalability means increasing the size of the instances. Okay, suppose you have, let's take the example of that call center. So suppose you have a junior assistant and a senior assistant. Okay, and junior assistant can take up 5 calls in a day, and he is good at that. So what he will do, you know that he's just working like very good in that, and he can handle those 5 calls very quickly and in an efficient way. So uh, we can increase his post, we can make him a senior assistant, okay, or senior employee, and we can increase
the call size. Okay, we can increase his call size from 5 to 10 because he is able to manage those 5 calls very quickly. So we will just increase the load of that uh, employee, and we will increase the number of calls there. Okay, we will just increase the size of the instance, you can say. For example, your application runs on a T2.micro, and what you are doing, you are scaling that application vertically, means you are running it on a T2.large. Okay. Vertical stability is very common for non-distributed systems such as a database. RDS Elastic Cache are services that can scale vertically. There is usually a limit to how much you can vertically scale hardware limit. Okay, so there is basically a hardware limit, so you cannot exceed that hardware limit actually. So there is a limit, vertical scale limit that should be followed. Okay, here is an example: junior operator and senior operator. You can also think of another case, like suppose here is your junior operator and here is your senior operator. Okay, he can take 5 calls in 5 minutes, suppose, and he can take 10 calls in 5 minutes. So if you want that your number of calls should be more, so you will be transferring these 5 calls from this junior operator to this senior operator, and he will be doing that work apparently in 2.5 minutes, right? So that is one thing which goes with vertical scalability. Next is horizontal scalability. Horizontal scalability means increasing the number of systems for your application. What you are doing, suppose, let us take that junior operator and senior operators, that call center example. Okay, so horizontal scalability means what you are doing, you are just increasing the number of employees. You are hiring like one employee, instead of one employee, you are hiring 2 employees or 3 employees, or more than that. Actually, you are hiring 6 employees, suppose. So this is what horizontal scalability is. Okay, horizontal scaling implies distributed systems. This is very common for web applications and modern applications. It is easy to horizontally scale thanks to cloud offerings such as Amazon EC2, that we can just make multiple instances and we can work in those instances separately, right? So here are the examples. Suppose what we are doing, we are just increasing the number of operators. We are increasing the number of instances in Amazon. Okay, so this is what horizontal scalability is. High availability. So first building in New York and second building in Francisco. So what is this? High availability usually goes hand in hand with horizontal scaling. High availability means running your application system in at least two data. That means suppose you have two buildings, and if uh, by suppose any of the incident occurs in first building, okay, so the data which is stored in first building, you have also stored that data in second building, so your data will be available. If one goes unavailable, then other one will be there to support you, because you will be there with the data. Okay, with the duplicate data or the copy of the data will be stored in the second building too. Okay, so this is how you can work, and this is how high availability can be achieved. You can just take any of the common examples if you want. Suppose you have your mark sheet, you have your grade sheet, and you are just storing 2 or 3 grade sheet at multiple places. Like you are storing it on cloud, you are storing it offline or any online platform, or in your Gmail. And whenever suppose Gmail fails, you just cannot retrieve your data from Gmail, you will switch to another platform where you have stored that data, and that is actually what high availability is. Okay, centers are availability zones. In Amazon's, those centers are AZs, or availability zones, you can say. The goal of high availability is to survive a data center loss. Okay, as I said, if there is a loss in data center, so your data would be secured if it is stored in two or multiple places. Okay, the high availability can be passive, for example, RDS multi-AZ, for example, and data availability can be active too, like horizontally scaling. Okay, so this is what availability and scalability is. So I hope this was clear to you. Let's meet in our next lecture. Till then, thank you. Hello. So in this lecture, we will see what is load balancing. Okay, so let us see one by one. So basically, load balancers are servers that forward traffic to multiple servers. For example, EC2 instances downstream. Okay, and they just divide the traffic to multiple servers. Suppose you have user 1, user 2, user 3 here, and then Elastic Load Balancer will divide your load to the three instances. Here, EC2 instances will be connected to user 1, and then second, and then third. Okay. Next, why do we use a load balancer? We use load balancers to spread load across multiple downstream instances and expose a single point of access, which is DNS, to your application, and it handles failures of downstream instances, and that is done by health checkup. And health checks are done on regular basis to your instances, that whether they are running or not, and inspection is done. It provides SSL termination, which is HTTPS termination for your websites, and it enforces stickiness with cookies, and it is highly available across zones, separate public traffic from private traffic, and it separates the public traffic from private traffic on your EC2 instances or on your applications. And an elastic load balancer is a managed load balancer. AWS guarantees that it will be working, and AWS take care of everything. Like, it is managed load balancers, and AWS only take care of upgrades, maintenance, and high availability of the data, whatever you are storing on your elastic load balancer or through your elastic load balancer. And AWS provides only a few configuration knobs, and it costs less to set up your own load balancer. You can also customize your load balancer, and you can set up your own load balancer, but it will be a lot more effort from your end to set up one load balancer. Okay, but it costs less actually. It is integrated with many AWS offerings or services like EC2 Scaling Groups, Amazon ECS, AWS Certification Manager, which is ACM, or CloudWatch, or Route F553, AWS WAF, AWS Global Accelerator. Then health checks. What is this health checks? As I discussed, health checks are crucial for load balancers. They enable the load balancer to know if instances it forward traffic to are available to reply to requests. Suppose they enable health checks enable load balancer to know that whether the instance is there. Actually, it is enabled to reply to the request. It is okay to reply to the request. Then only uh, it just transfers the load of the user to an instance. Okay, and this is what health checks do. The health check is done on a port and a route. Health is common here. If the response is not 200, which is a default value for OK, okay, and if that response is not 200, then instance is unhealthy and your load will not be divided to that instance. Okay, here is how health checks are done. Here is the protocol, HTTP protocol, and the port number is here 4567, and endpoint is /health. And as I said, health check is done on a port and a route. /health is common. Okay, and this is how elastic load balancer performs health checks. And if this instance is okay, then what? If the response is like 200, then your instance is healthy, and if it is not 200, then instance is unhealthy. Elastic load balancer will not be like transferring load on this instance. So next is type of load balancers on AWS. AWS has four kinds of managed load in balancers. First is classic load balancer, which is version 1, which is older generation, launched in 2009, and it is a CLB. It is compatible with HTTP, HTTPS, TCP, SSL. And next is application load balancer, which was version 2. Actually, it is a new generation launched in 2016, and it is an ALB, and it supports, or it is compatible with HTTP, HTTPS WebSocket. So it is basically more secure. And another one was launched in 2017, version 2, new generation network load balancer. Okay, it is one NLB, network load balancer. Actually, this is the full form of NLB, ALB, application load balancer, and CLB, like classic load balancers. Okay, and this supports TCP, TLS, which is secure TCP actually, and UDP. Gateway load balancers, which was launched in 2020, and it operates at layer 3, which is network layer IP protocol. In IP protocol, that is network layer, which is at layer 3. And overall, it is recommended to use the newer generation load balancers as they provide more features and security, And some load balancers can be set up as internal, which is private, or external public ELBs. Okay. So I hope this video was clear to you. I hope now this is the overview which I wanted to give you, and I hope you have perfectly got it, right? So let's meet in our next lecture, and till then, thank you. Keep liking us and subscribe us if you haven't subscribed yet. Thank you. Here in this video, we will see second type of application load balancer, which is version 2. Application load balancer is basically layer 7 in HTTP. Load balancing to multiple HTTP application across machines. It can just balance your load to multiple HTTP applications across the machine or different target groups. And load balancing, it also performs load balancing to multiple application on the same machine. Okay. Like example is containers. Support for HTTP to slash and WebSocket is there, and it supports redirects to. Suppose if you have HTTP and HTTPS, for example, then you can work upon it. You can work on it, correct? So that is one thing. Application load balancers has routing tables to different target groups. Suppose they can route uh, on the basis of host name. Suppose in URL you have your host name example.com/users or example.com/post. So on the basis of that URL or host name, you can say, on the basis of that host name, it can just balance your load, or it can route you to different target groups that load balancer can route you. So routing based on query string or headers is also there. For example, example.com/users ID 123 and order is false. So this is header, order is false, and this is query string, and user ID is 123. So on the basis of these headers and query strings, your routing is performed, and it is just redirected to some different EC2 instance or some different target group. And let me give you one example. Let me give you one scenario. What happens here? Suppose you are just being connected, you are searching. Let's take the routing based on hostname URL example, this one. And suppose you are working and you are just sending a request with your hostname to the load balancer, and then that load balancer will smartly know that, okay, these two hostname are different, so I have to redirect them to different target groups. Like slash user and slash post are two different hostnames, right? So that will be that load balancer will uh, take these host name, and then it will redirect you. It will give you two different target groups, correct? And then your load will be balanced. No two same, like different host name will be uh, like attached with same target group. So this is how routing is based on host name or query string. ALB, which is application load balancer, they are a great fit for microservices and container-based application. For example, Docker and Amazon ECS has a port mapping feature to redirect to a dynamic port in ECS. In comparison, we would need multiple classic load balancer per application. Okay, so that is why application load balancer is great when we are using routing for different target groups. Application load balancer version to HTTP based traffic. So this is how it is done. So suppose you have two user names or you two host names, which is first is you are searching it through, you are routing it through slash user host name, and second is slash search here, and then it is connected to external load balancers, and then it this load balancer smartly takes both the host name, and then it knows that, okay, slash user is different and slash search is different hostname. So it will redirect you, or it will give, or it will just balance its load in two different target groups, one for user and one for search. So this is one thing. And also you can see in this target group, health check is being done. So health check is done on the target group level only. Okay. So that will come in this PPT, that thing, that note will come, and you should remember this, that health check is done on different target group levels. Okay. EC2 instances can be managed by an auto scaling group. ECS tasks. Okay, so what are the target groups? So target groups are EC2 instances, ECS tasks that are managed by ECS only, Lambda functions. So they are the base of everything. Like they are serverless in AWS and they are base of everything. They are basic Lambda functions. We will get to know this in this course. Okay,
In upcoming lectures, we will be talking about Lambda functions also. So this is one thing that you have to know, you should know. And then IP addresses. Target groups are IP addresses also, and they must be private IPs. ALB can route to multiple target groups, and health checks are at the target group level only, as I told you just before this slide. Okay. And this is how application load balancer is just balance its nodes on the basis of query strings and parameter routing. So suppose this is your query string platform mobile, and this is your platform is equal to desktop. You have requested to your application load balancer, external application load balancer, and it has query string or parameter routing. Platform is mobile, platform is desktop, so it knows that if your platform is mobile, then it will redirect you to target group 1, which is AWS EC2 based. And if you have desktop 2, then it will just route you to target group 2 on premises private IP routing. Okay, it will just route you to private IPs only. Next is application load balancer version 2, which is good to know things about this, that it has fixed host name, suppose xxx.region.elb.amazonaws.com. So it is fixed, and application servers don't see the IP of the client directly. The true IP of the client is inserted in the header X forwarded for. We can also get port, which is X forwarded port, and proto X forwarded proto. We can get that when requested, or we can just look into the header to get the client IPs or application like your client IPs, you can say. This is one picture. Suppose you have your client IP, for example, 12.34.56.78. This is your client IP, and you are being connected to your load balancer with a connection termination request. So this is something which you will perform, connection termination. And what happens here, that your classic, sorry, not classic, your application load balancer will be connected to the instance, EC2 instance, with its own load balancer IP. It won't be using client IP anymore. Okay, client IP will be there in header. It will be hidden, or it will be inserted in the into the header, which is X forwarded for. And if you want EC2 instance to get the client IP, okay, if you want your application or EC2 instance to get the client IP, then you will have to search for the header part, and in that header part you will get your client IP. So basic thing is client sends its request to the load balancer, and then load balancer is connected to the instance but with its own IP. Okay, it doesn't uses client IP, it has its own IP, but that client IP is inserted in that load balancer IP, and that like client IP is inserted inside the header part, which is X forwarded for. So, okay, so that's it for today's lecture. Let's meet in our next lecture. Till then, thank you and keep liking our work.
Hello everyone. So today in this lecture we will see how to make an application load balancer. Okay. So in this video, before making an application load balancer, what you have to do, you will have to create one instance, okay, or two instances maybe. So we will be creating two instances. As I have created one instance already, I'll just enable it, and I'll show you how to make instance for this application load balancer, right? So I'll launch another instance, and I'll take these two instances. This is my first instance, which I'll be just initiating it, or I'll be running it right now. And I'll be making another instance, which is instance 2. So let me, my second instance, let's name it my second instance. And what now? Okay, sorry, my second instance. Okay. Now this will be default. This thing will be kept default instance. That will be t2.micro. That's good. Key pair. I should be proceeding without a key pair, which is not recommended. But for this practical, we can do so. We can create a security group in which what we will do, we will just choose my IP or anything. If you want like if you want to select anywhere or custom, so here what I have to do, I have to create one security group. And what I'll be doing, I'll be, if I want to select existing security group, I can do so. And for that I have one security group. Here I have multiples, but what I can do, I will just show you that what you have to do while you are creating a security group. Let me show you. So you can select any existing security group if you have done this. And if you haven't, just create one security group, allow SSH traffic from anywhere, And then second is allow HTTP traffic to, because we will be working with the browser here. Next is configure storage, that is okay. Advanced details, and in this advanced details, you have to edit the user data, right? And in this user data, what you will have to do, you will have to select this one, this thing, slash bin bash till this part, bin bash part, okay? This is these three are actually same only, okay? Here till bin bash it is. So let's select this, let's copy this, and now I'll be pasting it here. And yeah, you can see it is done. Okay, okay. Yeah. And what I'll be doing, I'll be just launching this instance now. So this instance is already launched, successfully initiated. Now I'll be going to the instance, and let me show you one thing. This I'll be just running this top instance too, which is my first instance. Let me start it. You can say this is my second instance. It is running now. What I'll be doing, I'll be just copying its IPv4 address and I'll paste it here. Okay, let's wait. Not this one. Sorry. Okay, so what I'll be doing, I'll be posting IPv4 address. So as I have created one data here as HTTPD is installed, so it will show that it works, right? For next one, let us see the another one, which is the first instance, whether it is working or not. So yeah, let us copy the IP address of it and let's paste it here. Okay, so yeah, it is also working. It has created one hello world from this IP.ap southeast to .compute.internal. Okay, so I have these two instances which are running. Like, let me show you. What I have. I have these two instances. Okay, they are loading. Yep, my first instance and my second instance. I have both these instances on these IP addresses. Now, what I have to do, I have to just create like can say that I'll be creating a load balancer for them. And let us create a load balancer. In the left side, you will get that load balancers option. Okay, so for creating load balancers, we have to click on this create load balancers. There are basically three types of load balancer. One is application load balancer that we will be using right now. It is used for creating HTTP and HTTPS type of like operations at request level. Second is for TCP UDP TLS, which is very fast. Which is very fast. Okay, it can handle millions of requests per second. And the third is gateway load balancer to connect through different gateways. And this classic load balancer is the previous generation, and we want to be using it. So I'll be creating my work with the application load balancers. So, okay, let us name this application load balancers as demo ALB. We can name that. Okay, so let us name it demo ALB. Internet facing. Okay, okay, okay. Everything is mapping. So, where we can choose them. So, I'll be choosing it at all the places, right? Security group. So, for this, I'll create a new security group. So, let us create one security group for this, in which we will be handling HTTP traffic. Okay, so let us create. So let me name it like demo SG load balancer, demo security group load balancer, right? Next description. So what is the description? What we will do here? So we will allow HTTP into ALB, right? Next, inbound rule. So in inbound rule, I'll be sourcing it like from here anywhere. Okay, so custom TCP to anywhere. Outbound rule is perfect. We don't have to like add any tags here. So okay, that is okay. So let us create the security group now.
So as you can see, our security group is already created. What I'll be doing now, I'll be just refreshing it and demo SG load balancer. Okay, this security group is there. I'll be unselecting all these things. Okay, so this is selected. Demo SG load balancer. Next, listeners and routing. Okay, it is okay. I don't have to add any listener load balancer tags. So if you want to add any tag, you can add that. Summaries here, attributes here. Okay. Let us create one target group. Okay. So let me create one target group now. From this part, you will have to create a target group. Basically, target group is nothing but it will be your instances, like what type of instances you will be choosing. You will be like making in your selecting in your load balancer that on which type. So this target type will be my instances. You can choose IP addresses, Lambda functions, and application load balancers too. Target group name, let me name it like demo tag ALB. Demo tag ALB. Okay. Protocol is HTTP. Okay. IPv4 right. HTTP1 protocol version is okay. Health check is okay. If you want to add any tags, you can add, but now I don't want to add any of the things. Now I'll be clicking next, and yeah, let us register both the tags. Let us select these and include as pending below. And here, both the target groups are selected, both the instances are selected. I'll just create one in the target group using these two instances. And here you can see this demo tag ALB is just created, and load balancer is not yet associated. Zero healthy, zero unhealthy, two are unused. So let us use them now. I'll be refreshing this, and after refreshing this, I'll be getting my target group, which is demo tag ALB. Okay, I have selected it, and nothing more. Let's just create this load balancer here. So okay, my load balancer is already created. It will take a few minutes to complete registration process. Till then, just wait. Okay, so as you can see that our load balancer is active now. It was in provisioning state, so it is in active state now. Now you can just copy your DNS name from here and then just paste it. You'll click enter, and when you will click enter, then in some time, just wait and okay, so as you can see, this is our demo ALB, that load balancer that we created, and its status is active here. So what now? So if you will copy or paste your this DNS name, so if you will copy it and paste it here in your Google or any of the browser that you were using, so what will happen? You will be redirected to your that
address, IP address or DNS name, and in that your instances will be there, and whatever the file you have created will be shown to you. And the amazing thing is, whenever you will refresh it, so at 2 3 times, suppose if one server is not responding, then the third or second one will be responding, because we have distributed it at three availability zones. So it will be like AP Southeast 2B or Southeast 2C or Southeast 2A, and that will be your free availability zone. And according to these zones, your DNS or your IP address will be changed, and that will be your output. Okay, so this is how we balance load of these two instances on. So hello friends, in the last video we saw how we can create load balancers and how we can work on it. Now in this video we will see that like if on a load balancer we can access our instances, or you can say that message hello world from two types, like from this DNS name, and you can see I have copied and pasted it, and here is my output. I am getting this hello world from this IP, and whenever I will refresh it, it will just change its address. Why? Because I have distributed it on three AZs, three availability zones. So one is that using DNS, and second is using our instance IPv4 also. We can access it. You can check. So we can access it using this one also. Our instance IP would also give us the same output. But what if we just want to get that output from only our load balancer's DNS name? So for that, we can edit the security groups of the instances. And for that, we can go to the instance, and then we can edit their security groups. And in those security groups, I will show you how we can do that. So in this first instance, my first instance, let's change security group. So in this security, I'll be going, okay. Now I'll edit its inbound rules. So here, there are basically two things allowed. So I'll be just changing it right now, and let us edit that inbound rule. So I'm here in wizard, and in this launch wizard, I'll just edit this one and I can work on it. Inbound rules, edit inbound rules. And here you can see we have HTTP to custom. Okay. So what you have to do, you just have to delete this one, and then you can work like the same. Let us delete this one, and let's just add one rule. And this rule will be same as we will be selecting HTTP here. But here in the place of custom, I'll just select, like I'll search for sided blocks, and here is our security groups, and I'll be selecting demo SGALB. And this one I'll be just saving. And when I have saved this one, okay, demo SGALB, this is allow HTTP basically. So now when I will select on my instance, now when I will copy the IP of the second one, I guess I have changed the second ones only. Okay, yep. So as I have changed my security groups for the first one, so whenever I will now I'll be clicking, like whenever I'll be copying this IP and then I'll be pasting it here, it won't show me any output. And why so? See, it is not showing me any output. This site can't be reached because I have just changed the security groups. I have edited inbound rules, and in that I have just clicked. I have like recreated things that I have deleted that access port of our IPv4 of the instance. And now what I have done there, I have just created one new group, security group, one new rule, so that only load balancer DNS name could be connected with the instance. Okay. And that I can do, like if I copy my DNS name here, and then if I paste it here, I'll get my output as it is, hello world. But if I copy the first instance's public IPv4, I won't be getting any output because I have edited the inbound rules for this. Okay, so that is one thing you can do with your instance if you want to make it more secure and to make it like more precise for your load balancers. Now, what is the case? So the second case is listeners and rules. Okay, so let us see that also. What are these listeners and rules? So basically, whenever you are working on your load balancers, right? So here are listeners and rules. So you can click on it. Okay. So this is my protocol port HTTP 80 load balancer is demo LB, and here are the listener rules. You can just add rules here, and you can add rules and make your like load balancer more complex. Suppose if you want to add additional tags, you can do so. Okay, you can name your key or something. You can add listener details. So suppose I have error here and values I can select. Okay, and then you can like click next and then conditions, and these are conditions that you can apply, like choose conditions, so host header path, HTTP request method, source IP. Okay, so if you want path, suppose if you are setting that slash error, so if slash error, this path comes anywhere, your message will be displayed. Suppose this slash error comes anywhere while working, while loading your like IP. So for example, slash item slash this error comes. So your predefined message, suppose you are defining a message for this, that if slash error comes, show me 404 not found or 404 error not found. So you can also get that from this condition. Okay, so I hope this was clear to you. Okay, and I hope now you can just change your security groups for the instances, or go for the listener if you want. So that's it for today. I hope this was understood by you. It was a like easy video for you to understand. So that's it for today. Let's meet in our next video. Till then, thank you. Hello everyone, welcome to our channel. So this is our video on network load balancers in AWS. We have our previous videos uploaded on this playlist and you can check that. And here we have our network load balancers, and in this video we will do theoretical part, and we will see that how we can make that network load balancers in AWS too. Okay, so keep watching this video until end and just like this video. Network load balancers layer 4 allows us to forward TCP and UDP traffic to your instances. So what are these TCP and UDP traffic? So TCP are basically you can say connection full or connection traffic, and UDP, that means connectionless traffic. And in real life you can see UDPs in, like suppose live streaming in our TV. So most of the packets are sent through UDPs. Okay, and this is how it forwards. This network load balancer actually forwards TCP and UDP traffic to your instances. Handle millions of requests per second, as I said. So suppose there is a live streaming going on at your TV, and so there will be million and billions of packets or requests that will be like done on your network. So that is how it is balanced through network load balancer. Okay, less latency. Latency is very less, like 100 ms versus 400 ms for ALB application. Load balancers had latency of 400 milliseconds, and in this we have less latency, 100 ms only. NLB has one static IP per AZ and supports assigning elastic IP. Okay, it supports assigning elastic IP, and network load balancers has one static IP per availability zone. Suppose if you are in an availability zone of Southeast 2 or Southwest 2, so your IP would be static because it supports elastic IP. It is helpful for whitelisting specific IPs, and network load balancers are used for extreme performance because it works on or it forwards TCP or UDP traffics. Okay, it is not included in the AWS free tier, and it is like as the work suggests, as the load suggests, it should not be included in the AWS free tier because it has to handle millions of requests per second, and it is actually having much more load than ALBs. Okay, so let me show you this picture. This is how it works. So suppose you are working with TCP plus rules, like you are doing www dot and you are searching something. So external network load balancers would be like are smart enough. Suppose you have made two requests www, and those two requests would be forwarded to different instances, one through TCP or another can be done through HTTP, and those will be like for users, it will be for TCP, it will be transferred through TCP, and for search application, it can be transferred through HTTP, and this is all done by external load balancers only. Okay, EC2 instance, a network load balancer TCP layer 4 based traffic. So EC2 instances IP address must be private IPs, application load balancers. Health check supports the HTTP, TCP, and HTTPS protocols, and health checks are done within the instances only. Okay, and this is what picture depicts. So suppose this is my network load balancer, and here are two instances in the first one. So target group can be EC2 instances. Target group can be IP addresses, and target group can be application load balancers too. So here in this, you can select an application load balancer as a target group because like it can handle your application load balancers also. But in application load balancers, we only had the option of instances, IP address, and much more, but we were not having like option to handle network load balancer in its target group. Okay, so vice versa is not included, but yep, network load balancer can have target group as application load balancers, right? So this is uh, all for theory. Let's go for hands-on part, and let us see how we can work on network load balancer. I'll just give you some overview, and you will be able to work on it. Okay. So here is my page opened. You can see you can open your EC2 services, and in the left hand side, load balancers will be there. Like this is your EC2 dashboard, and here in the left hand side, you will get your load balancer. Just wait. Yeah, load balancing, and here load balancers are uh, available, and you can click on create load balancers from this part or this part. So let us click on it. We have already explored this application load balancers, and we have like watched and we have analyzed it in depth. So in this video, we will just be overviewing this network load balancer because it is not in free tier eligibility limit. So if we work on it, we will be charged. So let us just see how does it works. And this is how you can name your load balancer scheme. So scheme can't be changed once load balancer is created. So make it with more attention. It should be internet facing or internal. So internal load balancer routes requests from clients to target using private IPs only. Okay, it cannot request from clients over the internet. It can only like routes requests from client to targets using private IPs. Okay, EIP. So this is one thing. And IP address type could be IPv4 or dual stack. Dual stack includes IPv4 and IPv6 also. Okay, so you can select that on your work basis, on your workload. Network mapping, you can do your network mapping. You can select VPC or you can create a new VPC. And network mapping basically like you are just making it available at more places. Okay, so mapping basically includes that in how many availability zones you are dividing that load balancers, and whenever you will be accessing that load balancer, so that will be whenever you will be refreshing, that will be opened from uh, like if one availability zone is slow or it fails to send the request or accept the request, then the another one will be replying to you. Okay, so this is why we like select more availability zone, security groups, and in this security groups I have already told you what you have to do. So you just have to go for application load balancer, and whatever you have created, like you have to give HTTP request, so you can give it, and inbound rules you would be selecting from anywhere to anywhere, and that would be more than enough for you in inbound rules. And that is how you will be editing your security group, and you will be creating one security group. Listener and routing, you can add listeners from here, and like this is listener, as the name suggests, TCP 80. So this is TCP 80, and at this 80 address 80, port 80 you can say, this port basically ranges from 1 to 65,535, and this much port number you can get in this protocol, for this protocol. And you can also like create more or more listeners, so that if one port fails, another port replies to you. So this is one thing. And then you can check your configuration. This is some very basic configuration: security groups, network mapping, and listener and routing. Also, I just forgot one thing, which is target groups. So you can select target group, you can create target group, and let me show you that NLB, in LLB, ALB will be also an option as a network group for you. So let us see that. Let us look for that. So yeah, here is your Lambda function, and another is one is your application load balancer, and this is one option which is available to you. So in network load balancer, you can also choose application load balancer as a target type. You can name that target group, and health check protocols will be done, and then you can click on next, and your whenever you will refresh it, your new target group would be created, and you can select that, and you can work on that. And yeah, whenever you will click this, suppose if you have like included instances in that, and how to include instances in the target groups. So for that, you can watch my previous video, which is application load balancer, and from there you can extract that how we can add instances in target groups. Okay, I have already mentioned that here. So this is how you can create load balancer, and once your load balancer will be created, you just have to wait for some time. When its status is active, then you can work on it. Your DNS, if you will copy and paste your DNS name in your what we say browser, and in that you can get your output, whatever you want, whatever instance has. Okay, you can get that output. So this is what this video is all about. Let us meet in our next video for more info. Thank you. Hello everyone. So in this video, we are going to see the newest type of load balancer, which is gateway load balancers. Okay. So let us start. In this load balancer, we can deploy, scale, and manage a fleet of third-party network virtual appliances in AWS. And what are these fleet of third-party network virtual appliances? We will see this in a second. Okay. For example, firewalls, intrusion detection and prevention systems, deep packet inspection systems, and payload manipulation all are done here. It operates at layer 3, which is network layer, and it has IP packets, and it combines the following functions, which are transparent network gateway. That means it gives a single entry or exit for all the traffic that is on your gateway load balancer, and it has one load balancer which distributes traffic to your virtual appliances. Okay. And next is it uses the GNV protocol on port 6081. So whenever you hear in the exam or AWS exam whether uh, where this GNV protocol is used, so you can write that this GNV protocol on port 6081 is used in gateway load balancers. Basically, this GNV protocol is an encapsulation, virtual encapsulation protocol. Okay, so this is how it works. First of all, suppose user has some route table, which is actually VPC. User has some networks, and then it will just redirect. There are multiple users, there are multiple sources, and that traffic is coming to your gateway load balancer, and then that gateway load balancer will just spread that load on the target groups. And these target groups are actually your third-party security virtual appliances. And then
these target groups will be the traffic will be sent again if someone want to access, and then it will be sent again to gateway load balancer, and then that traffic will be sent to destination or application, you can say, and this will be very transparent for you. And this is how it works. And next is, what are gateway load balancers target groups? So target groups are EC2 instances. It can be connected with instance IDs, and there is another one which is IP addresses, and it must be private IPs. See this one, the left one, the gateway load balancer is being spreaded on two instances with their IDs, the respective IDs, and here are target groups are EC2 instances. And next, another one, right one is gateway load balancer. And suppose if you want to connect with your own IP address and with your own server, then you have to enter your manual IP there. And that is how you will be selecting your target groups. Okay. Doing hands-on on this gateway load balancer is a very tough task, and I'm gonna skip this one because it is actually very tough. It is complex and it will cost us. So we are not going to do that hands-on right now, because in exam also you will not be getting any deep dive questions. You will just be they will be asking you about how it works and what are its target groups. Okay, so that is all, and thank you for this lecture. Let's meet in our next lecture. So, hello everyone. In this lecture, we will see sticky sessions which are available in Elastic Load Balancers. So, it is very possible to implement stickiness so that the same client is always redirected to the same instance behind a load balancer. Okay. Suppose you have a user and you want that user to be sticked to an instance while balancing load. Okay. So, you can use this sticky session at that place. This works for classic load balancer and network load balancers only, not for application or gateway. The cookie used for stickiness has an expiration date you control, and you can control that expiration date of the cookie. Suppose of that stickiness, if you want to stick any session or stick any instance to a user, then you can set that date, day, time limit, or you can say, yep, expiration date, that till when you want that instance to be sticked to the particular user. Next is its use cases is to make sure that the user doesn't lose his session data while working on the target group, whether it is an instance or a load balancer, whatever it is. Okay. Enabling stickiness may bring imbalance to the load over the backend in EC2 instances, because suppose your load balancer is balancing your load randomly, and that random thing will not be much appropriate when you will just give one instance to a single user. Suppose you have set an instance to a user, and that instance will again be used by that same user, and it won't be random. If you will refresh your pages on the browser, then also your IP will be same. Okay, so that might bring imbalance to the load. So this is a picture, and this is how you can get this point. Client one is using the left instance. Suppose client, there are three clients, and load balancer has like given EC2 instance which is on the left hand side to the client one, and EC2 instance which is on the right hand side to the client two and client three. So this client one will be using this left hand EC2 instances till its cookie gets expired. Okay, so when its cookie will be expired, then only this client one will not be able to use this EC2 left one EC2 instance. Okay, uh, so this is how load balancer will like stick that EC2 instance to the user. Sticky sessions cookie names are application-based cookies, custom cookie. Custom cookie, these are generated by the target and can include any custom attributes required by the application, and cookie name must be specified individually for each target groups. Every target groups have their individual cookie name, and make sure you don't use AWS ALB, AWS ALB APP, or AWS ALB TG, because these are reserved by the ELB, which is Elastic Load Balancer. Application cookie, it is generated by the load balancer. Cookie name is AWS ALB APP. And next is duration based cookie.
and cookie generated by the load balancer. Cookie name is AWS ELB for application load balancer and AWS ELB for CLB, which is classic load balancer. Okay, so this was the theory part. Let's see the hands-on now. So I won't be doing any like practical stuff here. I will just show you that how we can work with target groups. Here is my target group, which is TGT1. And let me just show you, this is my working protocol port, which is HTTP 80. And what I'll do, I'll just go to the actions and then I'll edit target group attributes. And here you can deregister, delay, this is one thing. And this is in target selection configuration, you can select stickiness. Stickiness allows the load balancer to bind a user's session to a specific target within the target group, and you can turn it on. It is not compatible with the weighted random routing algorithm, okay, and can't be turned on if cross-zone load balancing is off. So stickiness type, you can select load balancer generated cookie or application-based cookie. So this is the stickiness duration and unit of time. This can be in seconds, minutes, hours, or days. And stickiness duration can be from 1 second to 7 days. You can select unit of time here and duration from here. You can you can name your cookie so that whenever you refresh it or whenever you inspect it, your cookie name doesn't changes. Okay, and you can check that where suppose you will just make this stickiness, you will turn on the stickiness, and then you will register a user with a target group. Then if you will refresh it, and if you will refresh it multiple times, then also your like address will be same. Okay, your availability zone will be same. So that is how you can work with stickiness. That is how you can work with elastic load balancers, and that is how you can specify like a session to a user till the cookie ends or till the cookie expires. So this is what this lecture was all about. I hope you got this lecture very well, and let's meet in our next lecture. Till then, thank you. Hello and welcome everyone to our channel. So in this video, we will be discussing about cross-zone load balancing. Okay. So in our previous videos, we have been discussing about load balancers, and today we will be discussing about cross-zone load balancing and what is it and what it can help us with. Okay. So the first point is with cross-zone load balancing, each load balancer instance distributes evenly across all the registered instances in all AZs, or you can say availability zones. Suppose you have one user with availability zone 1 and second one in availability zone 2. Okay, and in both the zones, you have in first zone you have 2 instances, and in the second zone you have 8 instances overall, right? And both the instances are using available load balancer actually. Okay, so in AZ1 there is one load balancer, and in AZ2 there is one load balancer, and both are using their own load balancers. Suppose a user sends 50 instance load to this one and 50 load to second availability zone. So while you are using cross load balancing, what will happen that no matter if your availability zone is 1 or 2, your instance load will be divided evenly on all the AZs available with cross zone enabled. Okay, if you have cross zone enabled, then this 50 and this 50 makes up 100, and these are overall, let's count it 1, 2, and in AZ2 we have 8, so total 10. So according to this 100 load would be transferred or would be like equally distributed on all the instances, no matter in which AZs they are. So they are all getting the same load, 10, 10 load each, and then they are equally balanced, equally like weighted, and that is how they will be working with cross-zone load balancing. Let us take another situation where cross-zone load balancing isn't available. So requests are distributed in the instances of the node of the elastic load balancer. Suppose this is the same case, availability zone 1 and 2. User is sending 50-50 load each, and then in AZ1, we have 2 instances load balancer enabled and AZ2 load balancer enabled, but we have not enabled our cross zone load balancing here. So this 50 would be distributed to AZ1 in 2 instances like 25 and 25, and this 50 will be distributing in AZ2, which is 6.25, 6.25. And this is how you can see that if you haven't enabled your cross-zone load balancing, then your load could differ on different AZs, and that could affect your working efficiency, or that could affect your working time also. Okay. Uh, Instance may be loaded much, and some instance would be loaded less. So there would not be like a proper balancing without cross-zone load enabled. So let us see another thing now, application load balancer, and let us see how we can work with cross-zone load balancing on both of them. Uh, Application load balancer, in application load balancer, we have enabled by default. It is enabled by default, and it can be disabled at the target group level if you are going to the target group, and then if you are just like going there and you will editing that, so you can disable that cross zone balancing in the target group level, not in the load balancer level, right? Next is no charges for inter AZ data are there. Network load balancer and gateway load balancer both have disabled by default. Okay, both cross zone load balancing, in both of them, cross zone load balancing are disabled by default, and also you pay charges in dollars for inter AZ data if enabled. Okay, you have to enable it. If you are enabling it, then it would balance your like load very nicely or very efficiently. But what would happen that you will have to pay charges in dollars for that. Okay. Classic load balancer, it is also disabled by default, and no charges for inter-AZ data if you are enabling that. Okay, so that is how we can work in application load balancer, network load balancer, and classic load balancer, and also gateway load balancer with cross-zone load balancing. Let us see one example. Let me show you one example. Here is my TGT, okay, and I have this load balancer, okay. This is my network load balancer. You can see network load balancer, and I am just going to this part, and whenever I see this attribute, okay, I have load balancer enabled. You can check. This is my load balancer, okay. I will just click it, and once I click it, I'll just get into this load balancer, and in this in attributes part, I'll see that, yeah, I have cross zone load balancing off, and I can edit it according to my need, and I can just enable cross load balancing. Okay, cross zone load balancing. If I am enabling it, each load balancer node loads balances traffic among healthy targets in all its enabled AZs. Okay, and data transfer charges may apply in this. So this is one example. We can work similarly in cross gateway load balancer, classic load balancer, or application load balancers. Okay, so that is what I wanted to tell you in this part. I hope this was easy for you. I hope you just got what I wanted to show you. And let us meet in our next lecture then. And I hope to see you in the next lecture. Till then, thank you.
Hello, so in this lecture we will see SSL slash TSL TLS basics. Okay, so let us start now. So an SSL certification is basically a thing which allows traffic between clients and load balancers, and that is encrypted in while it is sending or it is traveling from client to load balancer, then at that time it is encrypted, and that is what SSL certification allows. Okay, SSL refers to secure socket layer. It is used to encrypt the connections between user and load balancer. TLS is a newer version of SSL. TLS refers to transport layer security, which is a newer version, but still, this term SSL is being used because nowadays TLS certificates are issued by certificate authorities. For example, Komodo, Symantec, GoDaddy, GlobalSign, DigiCert, and etc. And SSL certificates have an expiration date that you set actually, and they can be renewed, and you will have to renew that certification if you want that encryption between user and load balancers. Load balancer SSL certificates work like this. As I said, it has encryption. SSL certificate is here. If you see between user and load balancer, it works. over World Wide Web. It provides you an HTTPS and encrypted stuff. And then through load balancer to EC2 instance, it goes over HTTP only. But yep, in the transport layer, this TLS works, TLS certification or SSL certificate works here in this part when it is in transit. The load balancer uses an X.509 certificate, which is SSL or TLS server certificate. You can manage certificates using ACM, which is AWS Certificate Manager. You can create, upload your own certificates. Alternatively, if you want, HTTPS listeners are in that. What you have to do, you have to specify a default certificate. You can add an optional list of certificates to support multiple domains if you want. The security on the multiple domains. Suppose if you want that I want this website, and many of the websites to be certified. So you can enter those certificates in all those domains if you want if there is something in your app which is redirecting you to some other domain, you can add your SSL certificate there. Clients can use SNI, which is server name indication, to specify the host name they reach, and ability to specify a security policy to support older versions of SSL or TLS, which is a legacy client. So you should like specify which can work on the older version of SSL certification, which can, if it supports older version, then only it will be better because some of the PCs or some of the users will be there who will be using those old versions. Okay, so you should specify that, and your HTTPS listener should have this ability to specify a security policy to support older versions. So SSL name indication, suppose, let me give you one example through this picture. Suppose you are a client, okay? So this is your ALB application load balancer, and here you have set two target groups. You have two target groups, one for domain1.example.com and second for www.mycorporate.com, mycorp.com. And you have used in that ALB, you have two certificates or certs for two different domains, which are domain1example.com, which is this one, and second one is www.mycorp.com. You have SSL certification for this one also. So this is here. So if you are a client and you are searching this www.mycorp.com, ALB will just take this certification on, and whenever you are connecting your client to ALB, then a certification protocol would be there, and this certificate would be selected, and then you can go through your target group, whichever target group you are selecting or you are using. So this is how it works. Next is SNI solves the problem. SNI means server name indication. Solves the problem of loading multiple SSL certificates onto one web server to serve multiple websites. Okay, it's a newer protocol and requires the clients to indicate the host name of the target server in the initial SSL handshake whenever initially when they are verifying each other. So it's a newer protocol which requires the clients to indicate the host name. If you have the host name of the target, then only it goes. It's a newer protocol and it uh, gives you the permission and it secures your connections. The server will then find the correct certificate or return the default one. What it will do, it will just find that if you want that target group which was www.mycorp.com, then it will just that server will pick that SSL certificate, and then it will provide it to you, and then it will allow the connection to be encrypted, right? Note is it only works for application load balancer or network load balancer, which are newer generation, and on CloudFront also, right? It does not work for classic load balancer, which was an older generation. So this is how it works. Next is Elastic Load Balancer SSL certificate. So classic load balancer has version 1. It supports only one SSL certificate. You must use multiple classic load balancer for multiple host name with multiple SSL certificates. So you will have to make multiple classic load balancers if you want to provide multiple host name with multiple SSL certificates. Application load balancer. So unlike classic load balancer, it supports multiple listeners with multiple SSL certificates in a single application load balancer. So it uses server name indication, which is SNI actually. This is a newer version. To make it work, we will be like clicking that SNI topic in this series only in the further part. And then network load balancer comes and the role. And what is that? Supports multiple listeners with multiple SSL certificates. It uses server name indication to make it work. So I hope this was clear to you. Let's meet in our next lecture. Till then, thank you.
Hello everyone, so in this lecture we will see the hands-on about SSL and TLS certification. Okay, so how can we enable that in load balancers? We have to see that in this lecture, so let us proceed with that. 443 will be selected and here you are enabling your SSL and TLS certification, right? So this one, if you choose routing actions, you can go to forward to target groups or redirect to URL or return fixed response. You can add your target group here. Suppose I am selecting this TGT which I have made. This target group is here, and now I want to select my SSL and TLS server certificate from ACM source. So you can select that from ACM source. You can select if you have any certificate from there. From IAM you can select, and if you have to import some certificate, you can also import certificate, import to ACM or IAM. Okay, you can just paste the PM encoded certificate private key. So certificate private key, if you will just copy and paste here, then you will be asked to, okay, yeah, from which you like you want to import it to ACM or IAM, and then you can paste it, and then it will be like added to this configuration list. Okay, next is suppose we have to work on network load balancer. So you can also select network load balancer, and in its listener, what you can do, you can go to add listener part, and in this add listener part you can select the protocol which is TLS, and TLS will select your port 443. You can select a target group from here, TGT2, and then you can go to certificate source, and like the previous one, you can select it from ACM, IM, or import certificate. You can import one certificate if you want, and then you can just add your certification, and that will enable your SSL and TLS certification. So I hope this was clear to you. This was a very easy hands-on and a smaller one. Let's see other things in the next video. Till then, thank you.
Hello everyone. So in this lecture, we will see connection draining. So what is connection draining? It is a feature which is named. Suppose if you are using a classic load balancer, then it is called connection draining. And suppose if you are using application load balancer or network load balancer, it is called deregistration delay. Time to complete in-flight requests while the instances is deregistering or unhealthy. It is basically a time. Suppose if you have an instance, and if you have an instance and it is running, and your elastic load balancer is sending some load onto that instance, and if you are just deregistering that instance, and if some work is going on, then that time to complete will give enough time to your instance to complete that task before it gets deregistered or while it is being deregistered. It stops elastic load balancer is smart enough to stop sending new requests to the EC2 instance, which is deregistering, and you can set the time limit or the time period deregistering time between 1 to 3600 seconds. The default is set to 300 seconds only, and it can be disabled, which is set to value 0. If you have 0 seconds, that it will be disabled. It If you have a very small request, very low request, so then you can set to a low value. If your requests are short, then only you can do that. Suppose if you have a very short request, you will set that deregistering time to 30 seconds, and then that 30 seconds would be enough for your elastic load balancer to know that your EC2 instance is being deregistered, and it will shift that load from new user to another instances. Let us understand this with an image. So suppose these are your users and this is your elastic load balancer. Here are your three EC2 instances, and one of your EC2 instance is set to draining mode. suppose if this is in draining mode, this is being deregistered. So suppose if it is having some load and it is completing a task, then it will be having enough time to complete its task. This ELB will not send the new coming request. Suppose these users are now requesting something, some new load is being given to uh, a elastic load balancer. Then this elastic load balancer now knows that this EC2 instance which is in draining mode, this won't be able to take up any load now. Okay, it is being unhealthy or it is being deregistered. So the load which is coming on ELB is smart enough to know that okay, I do not have to send this load, new coming load onto this instance. It will transfer these loads onto other two instances. Okay, and new connections would be established to all other instances instead of being transferred to the third instance, which is in draining mode. So I hope you got this point, and what I wanted to show you is this only. Let's meet in our next lecture. Till then, thank you. Hello. So in this tutorial, I'm gonna tell you about health checks. So you must be aware of health checks because we have discussed in our previous video about health checks. So let us see some more things and let's get deeper into this. Okay. So ELB health checks, that means elastic load balancers health checks. So what are these? Let us focus. And first is suppose you have a target group associated and here is your application load balancer. So what does health check do? So what is its working? So setting is basically health check protocol, and in health check protocol, you will have the value which is HTTP value, and suppose protocol which is used to perform health checks, and the port will be set default to 80. You can customize that port also. Health check path, that path, if you have your own application, then basically it default value will be selected as slash. But if you want, you can give the full path also, the URL of that path you can provide. Health check timeout seconds is 5 seconds. Suppose this is set default, and you can customize that timing. And what it will do, application load balancer will just consider the target group unhealthy if it takes more than 5 seconds to respond. Suppose if you have your value 5, and then if that value crosses, then your health check would be considered as failure. Okay. Next is health check interval seconds. So suppose what is the working of this health check interval seconds? Suppose it has a value 30, and when application load balancer sends that health check to the target, so that 30 value basically decides the time interval between the, you can say, the duration of health check interval. Okay, so it sets the duration that after 30 seconds only you will be sending another health check, or it has sends health check every 30 seconds. Healthy threshold count is 3. Suppose if it is set to 3, then you can also customize it. But if it is set to 3, that is default value, then you can consider the target healthy after 3 successful health checks. Suppose you have 3 successful health checks, then your target group would be considered, or the target, whatever target is it is EC2 instance or application load balancer or network load balancer, whatever it is. So that would be considered healthy only when it passes the values or the threshold count of healthy threshold count which is in your health check. Okay, that setting, if it crosses the value of healthy threshold count, then only it would be considered as successful health check. Next is suppose you have unhealthy threshold count. What is that? So before considering a target unhealthy, that health check would be done 5 times. Suppose you have a value of 5 there, then that health check would be done 5 times before considering a target as unhealthy. Okay, so that unhealthy threshold count decides this. Target health status, initial, then registering the target. If it says healthy, then your target is healthy. If it is unhealthy, then your target isn't responding. Unused, that means the target
isn't registered yet, you will have to register it. Draining, as seen in our previous video, we have seen that draining, that means you are registering the targets. Unavailable, that means health checks is disabled. And next is, if a target group contains only unhealthy targets, Elastic Load Balancer routes requests across its unhealthy targets. Okay, it routes requests across its unhealthy targets, not to that. Okay, it will just go across it, but not onto that unhealthy target. Okay, so that is what I wanted to tell you in this theory part. Let's move to the practical part. Suppose I am having my target group here in EC2. You will find that in the left hand side target groups. If you have made any target groups, you will find that I had made one target group named as TGT1. Okay, and I clicked it, and now I am editing its health check settings. You will find it in the bottom part. And health checks. So suppose, what is this health check protocol? This is HTTP and HTTPS. One is secured and another is HTTP. So I had my selected HTTP. So with that, I'll be moving only forward. Okay. Next is health check path. So as discussed in the PPT, so health check path you can give if you have your own uh, default path. If you want to perform health check on the root, you can go with the slash, or you can specify a custom path if preferable. Okay. Health check port is traffic port or override. The port load balancer basically it uses it checks the ports, which port you want, override port or traffic port. Okay. Next is healthy threshold as discussed. If you will select 2 here, so lower threshold value makes your health check very quickly. Okay, and it makes your target healthy very quickly. Suppose if you have 2, so after completion of 2 health checks, your target would be considered as healthy. So if you want that my target should be considered healthy very quickly, so after 2 health checks, it would be considered as healthy only. Unhealthy, if you want to increase it, you can increase. Suppose because sometimes what happens, uh, health checks might fail because of some uh, unexplained reason, or some abnormal reasons. So if you want to set it to 5, then after 5 health check failures only, it would be considered as unhealthy. Before that, it won't be considered unhealthy. Okay. So what it is basically, its default value is 2 to 10. Like its limit is 2 to 10, not default value. Default value is 2 only. Limit is 2 to 10. You can set any of the values between 2 to 10. Next is timeout. And suppose if your target doesn't respond in 5 seconds, then it would be said that your target has failed the health check. Okay. So you can set the time here. Interval, basically the gap between two successive health checks is this. Okay, your interval part. Next is success codes. So HTTP code uses when checking for a successful response from a target, you can specify any value like 200, 202, 203, or whatever value you can give. For example, 200 to 299, any values you can give. This is codes. Like if you had a successful response from a target, it will show that okay, 200 is the successful. Like error 404 we see many times. That 404 is a code basically, unsuccess code that okay, your error is found and this is your code. So success code you can similarly you can set a success code there. Suppose if 200 is showing there, then you can like observe and you can say that yep, my check has been successfully done. Okay, my target is healthy. So that's what I wanted to tell you. That's it for this lecture. Let's meet in our next lecture. Till then, thank you. Hello. So in this video, we will see the load balancer error codes. Okay, so let us see one by one what happens. Successful request. Suppose if you have a successful request, then the code you will get will be in 200 terms. Then unsuccessful, if it is on client side, then it will be in the 4xx code format. Suppose any of the services which are unsuccessful at the client side, like If it is error 400, it is bad request. If it is error 401, it is unauthorized. Then 403 is forbidden. 460 is client closed connection. 463 is X forwarded for header with less than 30 IP, okay, which is very similar to multi request. You don't have to remember all these, but you just have to remember that 4xx code is actually for the unsuccessful requests at the client side. Okay, so the unsuccessful request at the server side will be in the format 5xx, and suppose an error, internal server error, would mean some error on the ELB itself in the elastic load balancer itself, and if it is the error, then you will be getting 5xx code error. Error 502 you will be getting if there is a bad gateway protocol. Okay, if service is unavailable, we generally get an error of 503. So basically, that access X after the 5 is the numbers 0203, whatever it is. So 504 will be for gateway timeout, probably an issue with in the server, and 561 is unauthorized server. So that is how you will get your errors. Let's move forward. Next is load balancers monitoring. So all load balancer metrics are directly pushed to CloudWatch metrics, such as all the data what you want to fetch about your load balancer will be fetched or will be pushed to CloudWatch metrics. If you have any backend connection errors, healthy host count or unhealthy host count, that will be counted. HTTP code in the backend, it will be in the code at 2xs. Successful request will be 200. Then HTTP code in the backend 3xx, it will be redirect request. 4xx will be client error codes. Next will HTTP code. 5xx will be server error codes, which we saw just in the previous slide. Latency, request count per target, search queue length. All these are important metrics that could be watched over, which help to scale out ASG. Max value is 1024. Spill over count, you generally don't want this to be more, because the total number of requests that were rejected because of the search queue was full. Because suppose you are requesting something, and because there is on one request already in the line in the queue, then your another request is being rejected. That type of thing you don't want in your load balancers. Suppose this is your application load balancer. Here are your like instances in TG1, TG2, TG1. You have two instances which are unhealthy, and one instance which is healthy. And other in TG2 or target 2, you have three healthy instances. So total health count will be 4, and unhealthy host count will be 2. So that metrics would be counted, and that would be pushed to CloudWatch metrics. That's it. Next is application load balancer request tracing. So request tracing, basically each HTTP request has an added customer header or custom header. Uh, like suppose this is your custom header XAMZN trace ID. Example XAMZN trace ID, and then this is your header, and this is what it will be like. Dot root is equal to 1 minus whatever the number is. Yeah. This is useful in logs, actually, when you have access logs or other logs, when you save those logs. This is actually useful in logs. Distributed tracing platform to track a single request. Suppose if you are requesting something, that access log will just that log would be counted that yep, you have requested something. So a log is made, access log is made, and then you have to go through that. Application load balancer is not yet integrated with X-Ray, so it won't be able to access that. So that's it for today. Let's meet in our next video. Till then, thank you.